National Conclave on Longitudinal Cohort Studies. A very warm and cordial welcome to each one of you gathered here to celebrate this important conclave. Before we start, I'll first brief about the safety protocol of this hall. We have 4 emergency exits from this hall and 1 VIP exit from this hall. So 4 exits are from either side and 1 VIP exit from the back side. And we have 15 number of fire extinguishers installed in this hall. In any emergency, we exercise that. So, yeah, so we don't have to worry because this conclave is related to medicals and doctors are present here, so we should feel safe. So it's indeed a privilege to host this important gathering of scientists, clinicians, data experts, and policy researchers who are working towards one common goal: to strengthen India's scientific network for long-term evidence-based and population studies. Longitudinal cohort studies form the coherence of modern public health research. They help us understand how genetic, environment, nutrition, and lifestyle collectively influence health outcome across generations. This conclave is a platform to bring together national efforts, share experiences, and deliberate on future of cohort-based data science and translational research in India. As you know, the formal inauguration of this conclave will take place today later at 1 p.m. in presence of our esteemed Honorable Minister of Science and Technology, Dr. Jitendra Singh ji. But until then, we have an exciting set of scientific discussions, interactions, technical session planned for this morning to set the tone of this conclave. Before we proceed ahead, I would like to request our Dr. Umakant Subudhi sir to invoke the auspiciousness and begin the program. Dr. Umakant Subudhi sir.
Om Sri Gurubhyo Namaha Harihi Om Gananam Tva Ganapatigam Havamahe Kavim Kaviram Upamasravastamam Jastharajam Brahmanam Brahmanaspata Anasrinmannuti Vishridasadanam Prano Devi Saraswati Vajevir Vajanivati Dhinama Viptrayavatu Ganeshaya Namaha Sarasatwai Namaha Sri Gurubhyo Namaha Harihi Om Om Sahanavavatu Sahanau Hunaktu Sahavirjam Karavavahai Tejasvinavadhitamastu ma vidyasavahai Om Shantihi 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 Swasti Prajabhyo Paripalayantam Nyayena Margena Mahi Mahisha Go Brahmanebhyo Subhamastu Nityam Samasta Lokaha Sukhino Bhavantu Samasta Lokaha Sukhino Bhavantu Samasta Lokaha Sukhino Bhavantu Om Shantihi 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 Swaswagatam Suswagatam Suswagatam.
Thank you, sir, for invoking the auspiciousness to begin the program. Dr. Subudhi is vivid spiritualist, renowned scientist, and coordinator of cohort program at CSIR-IMMT. Now, to begin this program, may I first request our director, Dr. Ramanuj Narayan, to deliver the welcome address.
जय जगन्नाथ, जय जगन्नाथ, जय जगन्नाथ। आप सभी को इस कोहोर्ट कनेक्ट प्रोग्राम में हार्दिक वंदन, अभिनंदन और सुस्वागतम। It's a historic moment for this institute, CSIR-IMMT, that today we have who is who into the medical fraternity in front of me and in front row, 2 rows of you. It was never imagined that so many doctors that the current God and who has led our medical field in the country, they are there. So on behalf of our institute, it's our proud moment to welcome all of you, sir, to this CSIR-IMMT. It was never imagined. I must thank the leader of this organizing team, that institute, CSIR-IGIB, who has given us the opportunity that we work in minerals and materials, and that place you have brought lot of doctor. तो इसको एक ही बात बोला जाता है कि पत्थर में फूल खिले हैं. So that is the opportunity given by our lead lab of cohort program, CSIR IJAB. I must thank Dr. Santanu Sardana and Dr. Saubik Mathi for giving us the opportunity. With an equal pace that we are jointly hosted by our Honorable Minister, tell that we have to collaborate, and cohort is a part of collaboration. So CSIR-IMMT in collaboration with BIRAC ILS is organizing this program. In what words I welcome? I know most of them in our general knowledge that we have the doctors from All India Institute of Medical Sciences, the top institution of our country. We have luminaries like Professor Ganguly, that he was a general knowledge for all of us, that we know him through his days that when I was at ISCT. So on behalf of the organizing team, let me welcome that today, whole day, that our cohort team across CSIR lab, all the coordinators and all the volunteers, and the most important, the students who has become the testing doctor in collecting the samples. So I welcome all of them that who are there and whoever is the organizing team. When Dr. Santanu sent me the program, then whenever you read the program and you will see the medical imaging of our country, that in which field it is not there. So I will read out the names for the benefit of the person who are not in this field, and what is things they have done. Krishna Reddy sir is there, that if you go to Hyderabad, everybody will know, or even in India or in Odisha, there is a direct connect of the healthcare of Hyderabad and the Bhubaneswar, and most of the hospital has been established with a collaboration from the Hyderabad Connect, and Indigo has put flights only to bring doctors, and you will find 6 flights coming and going, and lot of doctors comes and goes from the Bhubaneswar. So thank you, sir, for making this Bhubaneswar city the second on a small medical destination, I can tell, and our AIMS is also here. So on behalf of the organizing team, I welcome Professor Ganguly, Dr. Krishna Reddy sir, Dr. A.B. Day, Dr. Vivekanand Jha ji, Dr. Govind Makharia ji, Dr. Sanghmitra Bandyopadhyay ji, Dr. Kartikeyan ji, Dr. Sandeep Seth ji, Dr. Jawairkar ji, Dr. Nikhil Tandon, Dr. Sudha Vasudevan, Dr. Jimon, Dr. R. Lakshmi, Dr. Ram Krishnan, Dr. Rajesh Dixit, Dr. Purnima Prabhakar. Now all of you go, and whatever name I read out, do the AI and ML search and Google search, you will know what they mean for our country and what service, great service they have given to our nation. So it's a proud moment, sir. From our institute and this organizing TT, a big pranam and we are grateful to you that all of you having your so much busy schedule and you have come to bless us, to guide us. Then I must also welcome Dr. Saubik Maiti, that who has given us the opportunity, Dr. Binay Nandakuri, that who is on the way, he is our health care theme director, Dr. Devashish Das, a co-host director, then Dr. Ulhas, Dr. Parida, Dr. D.S. Reddy, the chemical theme director of CSIR, and the glue of everyone, Dr. Santanu Sen Gupta, and our chairman, Dr. Dhal, and all my organizing committee members that who are putting their tireless efforts, that whatever they have done, there may be some little bit of difficulty to you. So all credit goes to my organizing team, and if any shortcomings is there, so please direct me, please scold me, but our team has put a good efforts into this direction. I also welcome Dr. Gopal Kundu, all my cohort coordinators, the cohort participants, all the delegates, all the speakers who has come from across the country, from CSIR and outside CSIR. Then the details of the cohort and connect, being not from the medical field, only I can tell the doctors are the gods of today, and we have to respect the directions that whatever that AI has come, a big interruption in between. So whatever doctors tell, you have to follow that, and your health will be in the very, very good condition. You should not read in between the most of people what we do, AIML, that whatever treatment has been done, and we will try to read ourselves and we will try to become doctor. So Neem Hakim Khatre Jam, that always go to the doctors, understand that whatever prescription they give, and being not from this science of the field, but I have been educated by Dr. Saubik and Santanu that this direction is going towards personalized medicine, then digital health, that tomorrow if Honorable Prime Minister and President of CSIR, Honorable Vice President of CSIR, Dr. Jitendra Singh Ji, who will be going to bless us in the afternoon, and the leadership of CSIR led by Dr. N. Kalai Selvi has put IGIB as the lead in the cohort program, although 10,000 samples, but I think based on your interpretation, based on your direction, that when third phase will complete, definitely something will come out which will set the tone for Viksit Bharat, Atmanirbhar Bharat, personalized medicine Bharat, digital health Bharat. So once again, I am thankful to all of you, grateful to all of you that you have come, and a warm welcome to all of you in the land of Jagannath, the land of the blessings of our Utkal Bhumi. So my pranam and welcome to you. Jai Hind, thank you, Vande Utkal Janani.
Thank you, sir. Now we have privilege to have with us Dr. Saubik Maiti, none other than the director of CSIR IGIB. IGIB has been the forefront of genomic research and national cohort initiative, and his presence here today truly make this conference more enlightening. Now may I request him to please address the gathering, sir.
Good morning, everybody, and again welcome all of you to these next 2 days. Very important program, at least for CSR at this moment, and we hope that it is going to be an important program for many researchers of our country. I will not explain what is cohort, what is Phenom India. Most of you know by this time. If you do not know, Santanu also will elaborate. He will have time to elaborate it. But why we are meeting today? So this is the second time we are meeting. Initially we started within CSIR last year in Goa, and this year in Bhubaneswar. but we have extended outside of CSR also. So we are a very small institute. As IGIB, we have only 35 scientists, 4 or 5 people are working, and we are collecting health data and trying to integrate genomics, proteomics, multiomics, approach, including metabolomics. And I don't think that, with a small number of researchers, we can justice the funding or support that we are getting from either government or from the participants. And there are many cohorts. We are the newest maybe cohort that we are running. There are many old cohorts are running years and years for a particular. First question which came to our mind is that can we connect all cohorts together, bring them together, share our experience, share our competence, share our knowledge, and can we make it larger impact that a particular cohort can do it. So that's the ambition of this 2 days conclave, and that's why we have kept the conclave name is Cohort Connect Conclave. I hope that end of these 2 days we will have certain positive direction to this ambition that can we bring few cohorts at least together and then start bringing one after another. So that is the basically expectation from my team, as well as I will request most of you have huge experience, help us to understand this data, how best we can come out the results and their outcome. So I am again thankful those clinicians, researchers, clinical researchers, because that is the most important knowledge which we need, came forward, participated. Some of you have come individually to our institute, helped us. So we need your guidance, your vision, so that we can deliver much better way. That is my expectation. I hope next 2 days a successful interactions among ourselves. Thank you very much.
Thank you, sir, for valuable insight and for highlighting the integrative role of genomic science in longitudinal research. Next, it is my pleasure to invite Dr. Shantanu Sen Gupta, the principal investigator of Phenome India Initiative, to share his thoughts with us. Dr. Sen Gupta has been instrumental in leading India's efforts towards developing a unified and dynamic phenomic database, connecting the molecular science with real-world health data. Sir, we invite you to address the gathering, please.
Good morning, all of you. I'm not here to address, just to thank all of you who have, immediately accepted the invitation that was sent by our director, and here we are. It looks like the hall is empty, but there are 650 seats here. So even if there are 150 people, you will not find the halls full. But believe me, there are more than 150 people from outside Bhubaneswar, and within Bhubaneswar there are 150 people. So this is a 300 people gathering today. The students have prepared posters. They are there. Request all of you to encourage the students during lunchtime by going through their posters. I am also thankful to the sponsors. We had not planned for this event 1 year back. We had planned only 2 months back, and all companies, they plan their budget well in advance, yet they supported us so wholeheartedly, and we are really thankful to the sponsors for that. Now just telling them this is going to be an annual event, so budget accordingly next year. Finally, we are already overshot the time by 5 minutes, so I will not delay. We have a packed session, so request all the speakers to please stick to the time, otherwise nothing will happen to me. Your dinner is going to get postponed. Thank you.
Thank you so much, Dr. Sen Gupta, for enlightening the addressing and setting the scientific direction of the discussion that follows today. With those inspiring words, we now move towards the technical sessions. Session that will showcase the diversity and depth of the ongoing cohort studies, data management framework, and translational linkage across scientific disciplines. May I now hand over the proceeding to the session chair, Dr. Krishna Reddy, sir. It's my privilege to introduce him. Dr. Krishna Reddy Nalamala, cardiologist by profession, in the CEO of SS Health International, a non-profit global health systems think tank. He oversees its global and regional offices located in India, Singapore, UAE, Egypt, and the USA. He designs and develops various programs around 8 core theme and sub-theme of health system. He directs multi-stakeholder networks, alliances, and collaboratives. He co-founded many health enterprises. These include Care Hospitals, a multi-specialty hospital chain in India, Reliance Medical Devices, a pioneering indigenous cardiovascular medical device technologies, Trust Healthcare, an emerging model of integrated healthcare, and Incubate, an incubator of in vitro diagnostics and therapeutics. He currently leads these expecting care hospitals as their chairperson. So we welcome you, sir, to please chair the session.
Thank you. It's a wonderful and unique experience for me with so many scientists from the CSIR labs gracing this occasion. I have the great privilege to introduce Professor N.K. Ganguly. I think he does not require introduction to this audience. When I joined PGI in 1985 for my MD, he was heading the experimental medicine, and I still remember I was just mentioning the conference that he arranged on oxygen-free radicals for reperfusion injury. I went on to become cardiologist, so I could easily connect with Professor Ganguly on that count. I also used to listen about Dr. Ganguly from my wife, who is a CCMB scientist, because he was the chair of the research committee of CCMB. But to summarize his wonderful achievements, distinguished biomedical scientist and global health leader with a prolific career spanning over 5 decades. He currently serves as president of the Apollo Hospitals Education Research Foundation and holds honorary emeritus positions at several premier Indian institutions, including PGI Chandigarh, NAMS, ILBS New Delhi, and Jamia Hamdard University. He is a former Director General of Indian Council of Medical Research and also Director of PGI Chandigarh. Professor Ganguly has made pioneering contribution to infectious diseases, immunology, and public health policy. He has authored over 800 research papers, supervised more than 150 PhD scholars, and edited numerous scientific books. His global influence extends through his service on WHO, European Union, and Bill and Melinda Gates Foundation advisory boards, as well as his leadership in national vaccine policy, bioethics, and clinical trial regulation in India. A recipient of over 120 national and international awards, including the Padma Bhushan, Shanti Swarup Bhatnagar Medal, and multiple Lifetime Achievement Awards, Professor Ganguly continues to shape India's biomedical research and translational health ecosystem as one of its most respected scientific visionaries. With this illustrious introduction, I welcome Professor Ganguly to deliver the oration.
Okay, it's working. Okay.
Next, ये वाला back, नीचे वाला next.
Okay.
Slide change करने के लिए.
Okay. Thank you. So, thank you, my brother Dr. Krishna Reddy, for this nice introduction. I will also give my sincere thanks to Dr. Ramanuj, Dr. Maiti, and Dr. Sengupta for giving me this opportunity to be here. Although Dr. Sengupta has spoiled my presentation by rejecting my main presentation and selecting something which was a little longer, and he told me that I should talk about data sharing a little more, so I will have to improvise. My talk was in several sections. One was and it is on the community-based cohorts, not the clinical cohorts, which I think Dr. Karthik, Dr. Jha and many others will be presenting. So my talk will be on community cohorts. And I had 4 sections in there. One was my work in Aragonda, which was funded by Dr. Pratap Reddy, the chief of the Apollo group, because it was his birthplace. And we'll skip the others with which I was strongly associated as the chair of the scientific advisory committee. Other talks were on the SAS, that is Nita Bhandari's organization, where I chaired the scientific advisory committee right from the beginning. And the second one was the VADU, because right from the 0-day KEM hospital scientific advisory committee also I was chairing, so Dr. Yagnik and VADU. And the 4th section was Dr. Mohan's work on the diabetes, which I had funded and was closely associated with. So I will only talk about Aragonda. The others, I find that there are several representatives from there, right from Dr. Mohan's lab to the one of the Garbhini program. And maybe somebody from the KEM Pune will also be here. So I will skip those. So talking of the data sharing, there are 2 sides to this. One of the major advantages of the data sharing has emerged in India in a 2 very forceful fashion. When we were struggling with the maternal mortality, like we had at that time almost 500 and more maternal mortality, and this figure was shaming us around the world. And whereas we had all the technologies, like we had the beautiful family planning technologies, birthing technologies, and Dr. Banu Koyaji and Sune Bergstrom created technologies for mifepristone and mifepristol for the postpartum bleeding. All of them were developed in India. But Egypt got much better results from us. And there was a demographer in Egypt, his name was Mahmoud Fatallah. So I asked Mahmoud one day that, Mahmoud, we taught you everything, and how do you do better than India? So he made a very strong comment, and today's meeting actually makes an amends for that by joining India together. He said that Indians don't work together. And that's the major problem. They're individual brilliance, but together they don't work. And when I was in the Apex committee, I was the only non-Nobel laureate of the Grand Challenge of the Bill Melinda Gates. There were some beautiful Indian entries there, but they were not collaborative entries of the different institutes. They were single brilliant proposals. So the ones which got funded was from the Africa, because they created a good network. So I'm very happy, Shantanu, that you could create this kind of network where almost everyone relevant is participating. So here, because here the data gets joined, and So I was talking of maternal mortality. So there was a Indian from the Toronto University, Dr. Prabhat Jha. So he somehow or other is a very smart guy. He somehow or other, in the Census General of India, convinced the Census General of India, and then he analyzed the data. And analyzing the data, we were shocked because nobody has that kind of a data in India, that we have halved the maternal mortality in India. And the major causes of the maternal mortality was also highlighted. So that actually showed for the first time that how the data is so important in India and how you should have an access to the data. The second major achievement came from Dr. Lalit Landona. He was in the George Institute, the same place where Dr. Vivekanand Jha works. And the NACO data was there in the realm, in the open source at that time. It was made open source. So he went to the NACO data as well as the census data, and we were at that time struggling with the HIV/AIDS, and for the first time he showed that we have plateaued HIV/AIDS. It has plateaued in Chennai, it has plateaued in Maharashtra, two peak states where the HIV/AIDS was there. So again that was an eye-opener, and again it came through the data. Then the third, the data sets which was made public and was very, very important, that data set was in the million death studies. I was an author in the million death studies with Dr. Jha, and there they showed that Indian mortality figures are, the death count is one of the very important method of the analyzing the important events which are happening in a country. And lo and behold, it came out that the cause of death, like the death through the stroke, ischemic stroke, was different in the Northeast India and in the Northern India and Southern India. In the same way, there is a guy known as Dr. Abhay Bang and Rani Bang in Gadchiroli. They have 40 years data in the forested area of Gadchiroli. And even the internet doesn't work very well, but that huge data set they had analyzed and identified that majority of death in the Gadchiroli area is either through oral cancer or through malaria. So I then sent Dr. Anvikar there to investigate and help them out. So this is the power of the data and availability of the data in the open source. But here, the data need to have a quality. If the data doesn't have that quality, then you are sunk. This we realized when I was given with Mr. Qureshi. He was a election commissioner at a period, and at that time he was the NACO chief, and I was ICMR chief, and we were given to count the death to because of the HIV/AIDS, or the numbers suffering from HIV/AIDS. The whole world was criticizing us for the numbers which we were given. So one thing in India, when we collect community data, we had forgotten that we need first-rate international quality demographers. If we don't have good demographer, then the data evenness doesn't come. So we realized that we do not have a peri-urban data. We had urban data. We have very poor rural data, and we didn't have any peri-urban data. The same way we also realized that we do not have data sets from the MSMEs and some of the major special groups which were at the risk. So since we didn't have those data sets, what happened that our numbers were wrong. So we were using assumptions, huge assumptions. So those assumptions have to be corrected by actual data and actual surveillance, and then only we could give the actual number of this. So this is the importance of the data collection, data cleaning, data gathering. And now we do it much better in the hospital system. The HI system and LIS system have worked up very well, but not in all, in some places and not in all the places. So perhaps this time the way the Souvik and Santanu had collected the guys who are different than normal IGIB guys and the CSR family guys, this perhaps will make this particular critical change. So, but data has got two flip sides. There is one more example which I give, that myself and Dr. Ramlinga Swami were investigating plague in India when the Surat plague, pneumonic plague came up, and Latur bubonic plague came up. So we went around India, collected data, published it in Nature, and whole world stopped trading with us. In a week, there were 13 countries where the plague was prevalent at that time, apart from India. But no ships will come, nobody will buy our goods, the planes stopped coming to our place, and we lost billions of rupees in one go. The so here we have to be sharing the data with responsibility. After SARS, the things changed. After the Wuhan experience, things changed, and with the Ebola, with the Zaire Congo data, which was made public, like all the 90 sequences of the Ebola in the Zaire was made public. The first H1N1 data sets from California, the sequence data set was made public. So this happened with one very major thing, and somehow or other I also had a central place to that. 2 days back I had my birthday, and this particular day I received a message from Peter, who set up the GISAID, and Peter and me set up the GISAID. We were friends. He was in Geneva, and Geneva was one of the most frequent cities which I visited. His friend was the CEO of the Lufthansa. There was a lady there. So we were sitting in the Frankfurt airport, and both of us thought at that time H5N1 was raging, and both of us thought that we should have the sequences of the H5N1 available and a data set and repository available. So the Lufthansa CEO funded it. So he thanked me that we were able to set that up. And later on, Shekhar Mande and his wife also wrote to me when the INSAGOG was set up and these things were happening, that how the GISAID helped. So we went hunting for two organizations will we produce the data. So we went in Geneva, the Swiss School of Medicine, where the genomic data were gathered, and went to the Basel Institute of Proteomics, where the proteomic data was gathered. And that is how, and we know that how important the GISAID was during the COVID time. But then there is a flip side also. During that time, we persuaded, I was in the IVR, International Vaccine Research Center, we persuaded the Indonesia to share their sequence data, which they had sent to the Australia, that somehow or other use this data to produce a vaccine. So Baxter made a vaccine, and Baxter sent that back to Indonesia with about the price of about $28 per chicken. In Indonesia, you could buy 4 chickens with $1. So they saw red. They said that our data set has been used to exploit us. So at that time from the IVR, one of the thing which we took up, and then from the LC with the Tiki-Pang, that we will enable all the countries for the sequencing capabilities, and also making a meaning out of those sequencing facilities, so bioinformatics. So with that, we funded 10 different initiatives for this effort. So data also has a flip side. The data ownership in the policy is a very, very important policy system. And when the data is shared, the data sharing policies have come up with the WHO, CSIR, as well as the WHO. I was also part of that committee. But there are major impediment in data sharing. People have fears, people have all kinds of problem in their mind, but somehow or other, if we don't share data, only thing we have to look at that we do not become economically disadvantaged. India doesn't become economically disadvantaged in sharing the data, as well as India should be able to, the world should be able to gain out of that particular data, and those who have produced that data, they should get ownership of that. This I experienced in Timor-Leste. In Timor-Leste, their parliament was made by Chinese, their institutes were, the research was done by Australians. So they did two kinds of research there. One is known as a parachute research, that you descend there with the do the research and then fly away and don't leave any capability, anything behind. The other is the FedEx research. You send the samples to FedEx and do the research, give name of those people in the authorship, and ultimately they don't gain anything. So again, in the data sharing, the data ownership and leaving some capabilities to your partner so that they don't become only the sample suppliers, they become a participant and they become part of the analysis. So this is some of my thoughts on that, and these are all practical things. This happened and we need to look at how we do it. So before I go to Aragonda, I will like to say 2 small works which I did as a community cohorts. One was, my main work was in rheumatic heart disease, where the Karthik will perhaps be talking little more. So again, the demography was very, very important, that we have done it now for 40 years. In Raipur Rani and Ambala district, we still are doing it. But the demography was important there because it is scattered. It is not actually clustered into one places or periods. And the demography has gone to the poorest of the poor. So when you collect data or when you screen, the households where there are 10 or more people living, when there are no kitchen, when there is a mass fuels, these will be the places where there will be a challenge. So data has to be collected from there. And how do you collect the data? So we use school children, and we used the teachers and the primary school guys for this. And we created a appliance which will make the auscultation sounds, because with anemia you also get those auscultations, which is very prevalent in India, that these were reported. And ultimately, portable echocardiograph was used to make the final diagnosis. But Then after we got the data, we implemented 3 interventions. When you actually do community cohorts, you have to do interventions. So we did 3 interventions. One was that we gave penicillin every 4 weeks to those who had the infection. We started creating a algorithm because the diagnostic test for group A step was not available. We created an algorithm that anti-adenitis, pain in throat, secretion, etc., and created an algorithm, and that algorithm was used as a point of care, but later on, of course, the cultures were also done. The third was that I developed a genetic marker for susceptibility. 16% are the group A step prevalence, and 0.3% is the rheumatic fever, rheumatic heart disease. So I developed a test system which was a B-cell alloantigen, and this B-cell alloantigen was ultimately, I converted into a lateral flow test. So it was tested, and those who tested positive were put on a strong surveillance. And later on, of course, we started developing a vaccine, which we never succeeded, and still there is no vaccine. But this particular thing brought in and those who were the young girls who got rheumatic fever, rheumatic heart disease, we put them a stronger surveillance, because if they got pregnant, they died, because the heart valve was very, very expensive. Later on, of course, Dr. Vailyathan, Dr. Krishna Reddy have come up with the indigenous heart valve. So this was our study and still going on. This was a community cohort and a very strong cohort for that. The other one, which I didn't present here, this we are doing, this is not a community cohort. This is our study on the centenarians, those who are 100 and more year old. And we have now 400 in our registry. They are coming from all over India, because from one place in India you don't get all centenarians. Our target is 1,000, but it will be representative of all over India. We have people who are participating in, which are all over. And the actual data is a multi-omic data, metabolomes, proteomes, genomes, as well as the functional entities. Some of the arrays and algorithms is developed, so we determine the biological age, but we do 4 interventions. We restitute their microbiome by identifying super donors. We give them NAD injection to restore their energy. We reduce their dementia through various major interventions, and we deal with their frailty by providing the mesenchymal stem cells to them. So this is one of the things with which we are looking forward, and we are looking forward to work with IEIB and other organizations to really create a world-class data in this, so that our centenarians' quality of life becomes better. Now I come to the Aragonda. So this I will not go. This is Aragonda side, sorry. So Aragonda demography is very, it is somewhere between Andhra and Tamil Nadu border. This is Dr. Pratap Reddy's birthplace. There was nothing there, no water, no money. People were very poor. And so firstly we gathered the demography, that what was the demography. So after gathering the demographic data, we started doing the surveillance over there, which is equally important. So what we did, we took mobile vans with the laboratories, and we went to about every other household. It is not moving. Oh, sorry. Okay. So the program pillar was built on 5 pillars: care, nutrition, mental well-being, WASH, and community empowerment for holistic health. So what we did there, that our cohort was it was about 2013 household, and 31,453 residents were looked into it, and we tracked up to, after our surveillance, 1,980 NCD patients. So how do we dealt with these NCD patients? What we did a community empowerment program. So we put up a shed for the ladies to make the jute handicraft over there, and these we sold and we put money into their bank, so empowered the ladies. Then it was a mango growing country, and all the mangoes were wasted and the farmers were poor. So we brought in the food packing and food processing guys, so the packing was improved, the processing was improved, and they become richer. With the Sai Trust, we put their children to a very nice school, and so we educated the children. Their adolescent children or their growing up children, we provided them employment through the Tata Skill Development by teaching them paramedical courses and welding, so all of them got job. And we provided, with the ONGC, we provided them pure water. With the Indira Awas Yojana, we provided them better housing. So essentially, their economy increased and their education increased. And so what we did in the household survey, after we found out that how many were diabetic, how many were obese, and how many were hypertensive, we then created a clinic, 5 clinics there. In these clinics, they went and their biochemistry was done, and they were treated, they got the medicine. And we took up a 50-bedded hospital over there, and this hospital, when they were referred, they got care. And if they had somebody had a cleft lip with a smile, the cleft lip was corrected, and some small operations were done. We took up a Chittoor hospital. Now it is a medical college and a university, and some of them were referred there. For the cancer screening, in the cervical cancer, we had this small device, which is a kind of a colposcope, which could be inserted by a class 10 trained girl. And the image went to a caregiver, that is a gynecologist, and we developed cervical cancer very early. And those who needed an operation, we provided them operation. The breast cancer, we took mammography, but later on we got to a breath test in breast cancer, which has come up very well. And this year it got a Anjani Mashelkar prize, this particular. So breast cancer screening was done like this. And those who needed operation, they were provided free of it in the Chittoor Medical College. So the NCD also got very, very corrected. We provided an intervention. With the Bangalore Yoga Institute, we taught them yoga and pranayam. And then this particular thing ultimately created a huge, so few slides and I will finish. So this was the prevalence, and you could see that the diabetes was 6.25%, obesity was 16.7%, and women it was 12.2%. Hypertension had a varied risk thing. Maternal health, we improved maternal health, I must tell by one thing, that what we did, that we got the ladies and gave them 650 kilocalories of additional food, very palatable food, eggs, the jaggery, the dates, and they sat together and they had a primary antenatal screening, and maternal mortality was 0, and infant mortality was 0, peritoneal mortality was 0. So, because we gave 2 other interventions apart from the diet, we gave azithromycin, which took care of the pelvic inflammation. We took care of the postpartum bleeding by putting up the mifepristone and mifepristone right at the spot. And taught the mother-in-law and the husband to be supportive. So these were all these interventions as well as this Bangalore yoga thing. They brought it in the resurvey. We are doing a resurvey now. It brought it down. So, and we provided eye care by Dr. Raju, and this eye care restored vision of a huge number of people. So this data set is now over there. And if each household, each subject data set, community cohort data set is there. This we are doing for 20 years. So all the 20 years data is also available. So we have taken help of the Infosys, and they are doing, Dr. Venkataraman from Infosys is providing the free analysis and algorithm of this data set. So this was one mandala. Now all the mandalas have come because now the community is taking care of their own health. They don't have to go anywhere. We have made a repository of their plasma and the serum samples, and this particular repository is now being processed for multiomics to find out are there any precision disease trends there or not. So this is what is happening in Aragonda at this given moment. So I close my presentation by saying that community data sets could be done by the involvement of the communities. If the communities don't become a partner to you, then it becomes a problem. One last word I will say, which made me that we should do work for the community, which community desires. So after my rheumatic heart disease thing, we were feeling very, very happy that we did so good for the community. So we called a meeting of the elders and we said, are you happy? So, well, but our problem is tuberculosis. So they thought that tuberculosis had a higher priority and we should have worked on the tuberculosis. So this was an eye-opener. Not only involve community, also identify that what they really need and give them what they need. Thank you very much for this opportunity.
Thank you, Professor Ganguly. I think it was a masterly oration. Starting with the importance of the data, the quality of the data sharing. I think that sets the context for the next 2 days of conversations on how to connect the different cohorts and share the data. The second thing, I think he clearly demonstrated the power of the population health management. The only difference between the public health management and a population health management done as a study, how this can be actually scaled up. I think that's a second lesson I think I learned from the oration, is how effective population health management can be scaled up by both public sector as well as the private sector. The third lesson I think from the oration that I have, whenever we have these cohort studies, the insight of preserving biobank so that it can be used for years together in unraveling some of the insights from your precision medicine, omic studies, and the genomic studies. I think these are the three valuable pearls of wisdom from this oration. And I presume for the oration we won't have the questions. Thanks, Professor Ganguly again.
Sir, we'll wait for a minute. We request you to wait for a minute, sir. On the behalf of organizers, I'll request session chair to felicitate our orator today. It was very insightful to listen to him first regarding this cohort studies. I also request Director IGIB to please come over the dais and felicitate the orator with memento. Thank you so much, sir. I'll request organizer also to express our respect to the session chair with a flower bouquet, please. Thank you so much. By this we conclude this inaugural session, and now we move to the technical session 1. For this, I request organizer to please introduce the session chair and moderator for the next session. Thank you.
So, good morning all, and it is my privilege and honor to introduce the chair and the moderator for this session. So, I'll first introduce Dr. Govind Makharia. Dr. Govind K. Makharia is presently a professor in Department of Gastroenterology and Human Nutrition at All India Institute of Medical Sciences, New Delhi. He is also Associate Dean Research at AIIMS, New Delhi, and has published over 390 articles with 43 chapters for different books and edited a handbook on celiac diseases. His H-index is 67 and publications have been cited more than 18,000 times. He has been a luminary with being listed as a top 2% researchers globally and plays a leadership role in both global and local professional organizations, including Governing Council Member of Indian Council of Medical Research, Governing Council Member World Gastroenterology Organization, Chairman of Clinical Research Committee, Chairman of Asian Pacific Committee on Celiac Disease, Board Member of International Societies for Studies on Celiac Disease, and immediate President of Indian Society of Gastroenterology. He has developed many Asian and Indian practice guidelines in the field, and as an educator has trained over 110 fellows in gastroenterology and 10 PhD students. He has also initiated and nurtured many educator programs, including Young Clinician Program, Evidence-Based Gastroenterology, Train the Trainers and Master Classes, and has been a member of many national academic and scientific committees at different institutions. It is my privilege to introduce Professor Vivekanand Jha, who has been a luminary in the field of nephrology. He is the Executive Director at the George Institute for Global Health India, the Chair of Global Kidney Health at Imperial College London, and past President of the International Society of Nephrology. He also holds academic appointments at the University of Oxford and PGI Chandigarh, where he was the Professor of Nephrology and Head of Department of Translational Regenerative Medicine. He is the Editor-in-Chief of the IJN, which is the Indian Journal of Nephrology, Executive Committee member of KIDCO, is on the editorial boards of several senior journals, and editor of Cochrane Kidney and Transplant Group, and a senior editor of Oxford Textbook of Nephrology. He is also a member of WHO Task Force on Transplantation of Human Organs and Tissues. Professor Jha is recognized as a global expert on kidney diseases and focuses on emerging public health threats globally and in India. He currently leads research projects operating in more than 20 countries, and his current research interests are around development testing of individual and system level strategies to improve healthcare delivery in vulnerable populations to prevent disease development through a range of approaches, including multidisciplinary health system strengthening, development and implementation of multi-sectoral interventions. Sir, we welcome you both on the stage to chair this session 1, and handing over to you.
Thank you very much. Before we start the session, I perhaps would like to request the organizers perhaps to abbreviate the the text that you use for introducing chairs and speakers, because we want to hear from the speakers rather than their introductions. And we will go straight into the sessions. We are already running a bit behind. I know that the minister is scheduled to come at a specified time, so we'll try to stick to time as much as possible, and we'll straight run into it. So the advantage here is that the first couple of speakers have already been introduced in detail, so we won't go give their introductions. And I have the distinct pleasure of inviting Dr. Shantanu Sen-Gupta from IGIB, and he's going to tell us about the Phenome India CSIR Health Cohort Knowledge Base. Shantanu, over to you.
Good morning, everybody. So, Phenome India is So Phenom India is probably the latest entrant in the field of longitudinal cohorts. Although we conceived this idea in 2013, it's 12 years back, with Dr. Brahmachari being there, but then he retired and it never saw the light of the day till in 2018, Dr. Shekhar Mande visited IGIB and I proposed this and he was very excited. So he told that we will fund it, so you submit a proposal. We submitted in 2019 to be funded from 2020, but then COVID came. And I remember during COVID, I was actually having fever. I got a call from him and he said that, can you use your cohort to tell us the burden of COVID infection in CSIR family? I agreed. Little did I know how difficult it will be, but he said money is not a problem, so that was encouraging for me. So I formed a team from 37 laboratories. Most of the coordinators are here. I'm really grateful to them, and I'm grateful to the team of students who actually made this possible. We have now finished 2 rounds. I'll not show any data today. I'll just introduce what we are doing here. All the data you can, we are actually unraveling the data for the first time, and students are presenting posters. We'll request all of you to please go see what kind of data we are getting. So, this is not moving. Okay. So, why we thought about CSIR is the fact that it is present across the country. You can see here, we have CSIR presence in 16 states and 24 cities of the country. This usually has a very high scientific enthusiasm, and we believe that the attrition rate will be less. Does it represent India? No. It represents a population which has similar socio-economic status, a middle class, urban, literate people like us, who usually spends at least 8 to 10 hours sitting in the chair doing nothing. So these are the people who are vulnerable to cardiometabolic diseases, and so we felt that this is a relatively homogeneous population. So we had to give some objectives, although this is an open-ended study, but funding agency CSIR, Madam Vandana is sitting here, wants objectives. So we started with 2 objectives. One is, can we develop a binary prediction model for normoglycemic population to develop prediabetes and diabetes? And the second one is on liver fibrosis, to create a prediction model for people from no fibrosis to F2, F3, F4. So we started with this, and I think I'm audible here, right? It's better to. So this is the plan. What we do here, this is all voluntary. So we go to all institutes, try to create awareness on people that why should they do a health checkup. And we expected 10,000. I don't know where the number came from. At that time, there were about 40,000 people, including pensioners and spouses. So we thought even 25% of them, if they enroll, should be good enough. So 10,000 was the number. And the other reason, there is representative of funding agency anyway. So the other reason was we could not go beyond 100 crores. Then it goes to cabinet. So we had to be below that. So once we register the participant, we give them the slot for sample collection, and I'll show you in more detail here. So this is a busy slide, but let me just walk you through it. So the person registers, the coordinator approves the registration, and then he's given a registration ID. Once the team goes to that particular institute. The person is given a slot of his choice. He or she comes to the site. We give them a sample ID against the registration ID. So there is a data anonymization happening there. And then at site, we do oscillometry, spirometry, 2-minute ECG, phlebotomy, of course. In the first round, we have looked at gut microbiome. We did the skin analysis. Of course, we take blood pressure, anthropometry, and fibroscan. We collected all the questionnaires from them online with consent. So the plan was basic phenotyping will be done in 10,000 samples. So all the scanning has been done in 10,000 samples, including blood parameters. From there, we'll take 5,000 samples and do advanced biochemistry, proteomics, metabolomics, look at cytokines, look at telomere length, do genomics. Although the plan is to do whole genome sequencing, but we didn't have money. So we did the next best thing. We are doing the GSA array, metallomics. So this institute has taken lead along with IICT in trying to quantitate the concentration of 32 elements in our plasma. So this is probably the first time that we are doing it. We are looking at miRNA, of course microbiome, and in a further subset of 500 samples, we are doing immunophenotyping and RNA-seq. So I told you this, people get the sample ID when they come to give the sample. The sample are then aliquoted. A part is given to the diagnostic lab, which was Healthians in this case. And part of them, we separate the plasma and the serum there itself in the institute and store it at -80. Then these are shipped to IGIB. At IGIB, the first thing that we do is against each sample ID, we give a test ID. So now you see there is a 3 level of anonymization that has already happened. And for each participant, for proteomics 100 microliter, cytokine 200, we have divided it. We divide it according to this, and a part of it, we keep it for biobank. So one of the most important things that we use is the control rate freezer. So we don't directly take the sample from the field and put it in -80. We pass it through this, which actually increases or decreases the temperature by 1 degree. That way the sample integrity is there. There is no coagulation. So some proteins are actually susceptible if you put them directly at -80 or bring it from -80 to room temperature. So this is our biobank currently housed at IGIB. We call it Bharat Biobank. And this was inaugurated this July, 6th of July 2025 by Honorable Minister. In fact, that's the day when he committed that he'll be present here, provided we were planning for 14th and 15th. He said 14th is Diabetes Day, I have to be in Delhi. If you do it on 13th, I'll come. So I'm grateful to him that he has kept his promise. So these are the institutes. It cannot be done by a single institute. Most of the institutes are participating in various activities. We have standardized these assays across different institutes. So after first round, this was what we got. We have done phlebotomy of 10,267, body composition analysis. So we look at the fat composition, the distribution of the fat. We did spirometry, and I think if I'm not wrong, oscillometry, 7,000 samples has never been done. Probably this is the highest in the world in a single study. Fibroscan, liver fibrosis, we checked for 10,000 people, ECG 10,000, and gut microbiome has been done, full sequencing of gut microbiome has been done in 6,000 individuals, which is probably the largest in the country. So apart from that, I told you we also do metallomics, and you can see here, Phenome India Consortium, which is the first column, it is actually, we are the largest in the world currently. We have done more than 5,000 now. We have also developed a method where we can quantify proteins, at least 50 proteins. We can quantify proteins which are involved in cardiometabolic diseases using MRM-based mass spec technology, and we have now reduced the time of the assay to 10 minutes. We are also doing metabolomics. We are using BioCrates kit. Representatives of BioCrates are here. So we did this in 3 different laboratories, and I was very surprised to see that when we were trying to see the difference and trying to normalize, there were absolutely no difference between 3 institutes. So it is such robust system. We got, on all 3 institutes, we got about 450 metabolites comprising of amino acid, lipids and all from the BioCrates kit. We have also looked at cytokine. This was mainly done by IICB, and we have looked at 48 cytokines from the plasma. At IGIB, we are also looking at miRNA. So we started using large miRNA in less number of samples. Then we saw that about 20 miRNAs are consistently coming, and they have different characteristics. So we chose about 20 miRNAs for this. And we are also doing the genome-wide association study. And I should thank Director IGIB that he has given us money to at least do 1,000 whole genome sequencing. I would, from this platform, request other directors of CSIR, if they can spare some money from their LR, we can do 5,000 sample, and this will be a fantastic data set having both genotype and phenotype. As I told, we did the gut microbiome, and in 6,251 samples, we got 24 phylum, 1694 genus, 3279 species. What is interesting is our gut microbiome is different from European gut microbiome. This is important, and Rakesh has a poster. I think he can explain it to you better. But all these, remember, are employees' data. We need to keep it confidential. So what we did was, we tried to ensure HIPAA compliance. Data is secured at rest during transit and during edits. We have also started sharing the data currently amongst the CSIR labs. So we have a request form in line of UK Biobank. They send us the request, we verify the request, and then we share the data to everybody. So this is what this conference is about. We wanted to see if we can convince other cohorts. From 10,000, if all the cohorts come together, currently we'll have more than 2-3 lakh samples if we take all the cohorts together. It is very important for reproducibility. One important caveat, and I think Hildian's team is going to show the data, if you take one sample, same sample, you measure it in 3 different biochemical analyzers, you get 3 different readings for a lot of parameters. We have done 31 parameters, and we have seen, for example, apolipoprotein A1, apolipoprotein B, they differ from one instrument to other by about 25 to 30%. Vitamin B12, they vary 100% between one instrument to the other. So what is important is, it is not only study which instrument was used to look at the blood parameters are also necessary, and because we have done these 3 instruments, we have created a calibration curve, so we can say that data from this corresponds to how much in the other instrument. The goal, this was one of the things that accelerated our desire to do it. You see UK Biobank, all biobanks, you can see at the top red, all Asian biobanks are there. Japan, Korea, China. India is not there. Can we put Indian or Bharat Biobank here in this graph? That is the motto, and with that I request all of you to please create a forum where we can at least talk to each other, see, harmonize the data, and try to share the data wherever possible. The goal is to take it from right to the left. We want wellness. Prevention is better than cure. Not that I am taking, doctors will lose some money with this, but it is important that, we go for, from disease side, we have to go to wellness side. That's the motto. Thank you.
Thank you very much, Shantanu, for really very, very comprehensive exposition of the Phenome India cohort and for sticking to time. We have time for a few questions if people want to get up and speak. Yes, please go ahead, sir. Can you please introduce yourself and then use a microphone? Can someone get a microphone there?
Chandru, excellent. I mean, this is like really what things are and what we should move to. Two short questions. One, I was intrigued by your gut microbiome. So what was exactly the sampling point of time point for the gut microbiome? Because you said you collected all samples on site.
Yeah, that's a very good question. So what we did was, we gave the kit to the person 1 day before, 1 or 2 days before, with a very simplistic procedure, and I should thank Rakesh for that. He created a fantastic procedure so that, you don't have a problem, and the gut was transported to the lab by the person within 2 hours of collection.
Oh, yeah, that's a great product development also coming up. The second one, I was impressed with your funneling down the miRNAs to smaller numbers. But in terms of proteomics, are you planning to do that? Funnel down to something like a Olink panel and then screen larger numbers?
Yeah. So proteomics, we will do 500 sample, the entire proteome, but we have now selected about 50 proteins, 50 or 60 proteins, which are important for cardiometabolic diseases, and we are going to quantitatively determine that using MRM technology.
Thank you.
Can I have one question here?
Yes, please.
Yeah.
What I'll suggest is that if you have a very specific question about any cohort, then perhaps you can take it up later with the cohort investigator. But here we are here to, indulge in knowledge exchange.
So I have one quick question, Dr. Shantanu.
Yes.
Myself, Professor Gopal Kundu, Director R&D, KIT University. So the sample which you have collected from different cohorts, what are the comorbidity of those individuals, and whether they have any disease and where they have developed any resistance based on their specific drugs?
Yeah, so we collect all those clinical history. We are also asking them what drugs they are taking. So we have all those data and we are analyzing based on that.
All right. Thank you, Shantanu. We'll move on to the next talk. Thank you.
So after the wonderful talk, it's my pleasure to invite Dr. Krishna Reddy. Dr. Krishna Reddy, all we know that he chaired last session. He's a cardiologist by profession, and also he's CEO of Access, and also has quite an interesting enterprises that he is also co-founder of Care Hospitals, so well established in Hyderabad. So he'll speak to us on some adoption of standard-based interoperable EBDM compliance system. Dr. Reddy, please.
Yeah, thank you. I think taking forward from what Shantanu has outlined, and my purpose of the talk is, since the prominent clinicians are there, prominent scientists are there, and hopefully the policymaker will be coming here by that lunchtime. This is to a vision to create a kind of a national mission in addressing the great lack of any evidence from the Indian population per se, to frame risk models, to frame guidelines. We don't have any national guidelines. We don't have any national data that is representative. We still depend upon the Western cohorts and the Western research data. As a part of a scientific advisor for the phenomic study, as well as since as a Access Health CEO, we are involved in the National Ayushman Bharat Digital Mission. So we are the knowledge partner to the National Health Authority in its implementation. And also as a provider, I have a unique opportunity to have a cohort, a kind of a longitudinal cohort, population health management of all our patients that come to our provider system. Not only our patients, but also all the undertakings, the public sector undertakings and the private sector undertakings, and the population that actually are there. We try to now gather the entire population health management approach. So there is a demonstration of population health management in the private sector in a more efficient way. The second is, since it is going to be a longitudinal, interoperable, standards-based electronic health record system, whatever we do in terms of the analytical systems, whether it is genomics or the multi-omics, how do we actually knit together a national level policy of evolving national health information system? And there is also policy of, now with the CSIR labs coming together to initiate this Phenome project, the multi-omics project. So when you have a combination of this multi-omics project and the different labs focused on different aspects of diseases, right from the promotion to the palliation, I think somebody said the data is the new oil. I think the data coming from 1.4 billion people has a tremendous value. In fact, the data can actually fund the entire healthcare needs of the people. I mean, so this is a kind of a larger national vision in terms of how we can integrate these things. There are so many things determine our health and disease and its natural history. In fact, the health system does not determine the health, but it is the upstream determinants. It's the social determinants, the environmental determinants, the economic determinants, the commercial determinants, and the cultural determinants. They account for 2/3 of the health. So in addition to our genomic determinants, we need to take into consideration these 5 determinants plus the lifestyles that happen to that. And some of these determinants are causal, that means there is a cause and effect, and some are attributive. They are not causal, but a kind of a attributive thing. And the disease onset and its natural progression, it's not static, it is dynamic. That means if we have a point assessment, point analytics as for the phenomics there, I mean, we are studying the multiple proteins, the microbiomes, and other things, but it's a point assessment. What is stationary is the genome. What is dynamic is the proteins and everything else. So unless there is a longitudinal study, the interpretation and inference of this correlation between the phenotype versus the multi-omic may produce some mistakes unless there is a consistent longitudinal correlation. So that's the reason why we need a longitudinal course. As a clinician, I mean, in terms of the disease assessment, I mean, what we used to assess just by clinical examination, then went on to have the imaging systems. Imaging systems have gone to the level of molecular imaging, including the functional imaging, even without doing a biopsy or without doing a sample. So that is one set of advance in terms of understanding the disease and its evolution. The second set of understanding is through what we have this just a sample-based, a fluid sample-based analysis of health and disease. So these are the two methods of parallel approach to how we are trying to understand the human health at a molecular level, at an atomic level. So that's the progress that we are having. So in this context, I mean, there is a continuous information coming up across the world, not just within the India, across the world. There is a continuous bioinformatics, continuous genotypic data that is coming up, continuous evolution of the correlates of some of the genotypic variants with the phenotypic manifestations, the disease correlation. So this is continually evolving. So, but still, all these correlations are not well established for its clinical application. So there is a movement towards a stage where some of these correlations can be adopted in the clinical application in terms of translating a personalized healthcare to precision healthcare. So that has a time. I mean, that's the reason also this study has to be taken forward beyond what it started. It was a good beginning, and it is a catalyst for that. Similarly, there are many unknown biomarkers. I mean, we have multiple biomarkers, but we can have much more simple, excellent, which can be tested at point of care so that they don't have to, and which are timely. For example, we don't have a biomarker to differentiate in the clinic. Is it a viral infection? Is it a bacterial infection? Just we need that biomarker so that we don't have to unnecessarily start empiric antibiotics without knowing what exactly is the organism. I mean, what is the root cause of AMR is, we don't know. It takes 3 days to know the microbiological diagnosis. So if this research can actually throw up a molecule which can differentiate, is it a viral, is it a bacterial? Then I avoid unnecessarily giving. This should be in the office. It should not be in the lab after 3 days. So these are some of the targets for that. And traditionally, we are focusing on pathological microbes in disease causation and progression. However, the importance of the microbiome residing within us, the microbiome residing on the surface of us, we don't know. I think that's still unknown thing. And the damage that we are causing by just popping antimicrobials, what damage it causes in the immune system, what damage it causes in the mental functions, what damage it causes in the structural causation of some of the triggers for acute MI and heart failure. So these are, I think this is a tremendous evolution of, it's still a beginning of that. And since the disease process are not static, a longitudinal record of health and related data becomes essential to bring out meaningful correlations. So this brings to the question of the need for longitudinal health records, not just as a part of a cohort study, but as a part of a national movement. I think it should be mandated. It should be mandated that any provider, whether it's a private provider or a public provider, should be mandated to give essential health data to the patient, their personal health record. I mean, that is the objective of Ayushman Bharat Digital Mission. So, however, most of the data is either not documented or not digitized for processing or not standardized. That means nobody has documented on paper, documented but not digitized, digitized but not standardized, standardized but not processed. So these elements are being actually, the solutions are being actually, now with the natural language processing and also AI transcribe, you can actually capture the data as I'm actually talking to the patient. I don't have to enter the data. The challenge of entering the data can be eliminated. The challenge of not standardizing the data is being eliminated by large language models. So the new digital disruptions actually can provide you a longitudinal health record system because it does not require the doctors to enter the data. It can be collected on the go as you actually manage the patient. So these are some of the disruptions that are happening that makes it possible. With the disruptions happening in digital technology across countries, many health systems are going through digital health transformation. I think many of you are aware of the digital health mission, which basically aiming at creating a standards-based, interoperable national health information system with privacy by design and security by design. So I think this will be providing a tremendous thing. And the structure of a longitudinal health record, you have a clinical parameters, the diagnostic, the labs, medications, and the imaging. Then you have the behavioral parameters, the diet, activity, sleep patterns, and activity and sleep patterns. With your wearable rings and wearable watches, you can get it. I mean, you don't have to struggle to get this activity and sleep patterns. You have environmental data, where you live in terms of the indoor pollution or outdoor pollution, air quality, location, exposure. You have the digital data that is coming up continuously in terms of the wearables and the smartphone metrics. And then you have added the omic layer, that is genomic, transcriptomic, proteomic, and metabolic data. So these are the sets of the data that can be easily captured and correlated in a longitudinal fashion. You have the data sources and linkages. So you have the electronic health record. The difference between the medical record and health record is interoperable and it's portable. Then you have the biobanks and the cohort studies, which Shantanu has alluded to in terms of the Bharat Biobank. wearables and the mobile sensors, the population genomics initiatives, and integration challenges. I mean, these are being addressed as a part of the ABDM mission implementation. How do we actually overcome some of the challenges in implementing these longitudinal health record systems? We need, I think, the collaboration of statistical institutions comes into the picture, because these correlations requires the highest end statistical methodological applications. It's not the routine epidemiological statistics. So in this case, I mean, you need a huge data processing normalization. You have integration methods in terms of the deep learning, Bayesian, and network-based models. And you need outcome correlations in terms of disease trajectories, because there are so many factors that are involved. Unless you have the multivariate analysis using the powerful statistical tools, you end up actually mistaking a correlation which does not exist. So we need to do all this. So this can be possible only when all the labs and all the scientific labs, the DBT labs, DST labs, and CSIR labs actually can come together with the premier institutions like All India Institute and the PGI. So unless they come together, we cannot dream of a national vision for the longitudinal health record. And there is a federated learning for privacy, so the data can be federated. It's not like a platform data like the Geo or the Amazon and other things, where they own the data and they're monetizing the data. The ABDM is like a highway. There's no data storage. The data comes into the highway and the data goes out of the highway. There's no storage. So that's the beauty of the federated architecture in designing the National Digital Health Blueprint. This is why integration is chronic disease result from complex gene, environment, and lifestyle interactions. Statistic studies must miss temporal dynamics, so that's why the longitudinal health records provide time-based context, and integration enables personalized prediction. These are some of the example applications in terms of the cardiometabolic, which the Phenome study is trying to do in terms of predicting diabetes onset using metabolics, cancer tracking mutational changes versus treatment response, neurodegeneration correlating proteomic shifts with cognition, and infectious diseases host pathogen omic interaction analysis. And what you need is infrastructure requirement in terms of cloud-based secure data lakes. So there has to be a national cloud. It cannot be international cloud. We have to preserve the data within the country. The scalable AI analytics platforms, consent, privacy, and ethical governance in terms of the fair data. So these are evolving in terms of the data security and the privacy and the regulation of the new data. So lastly, I think the challenges and limitations in terms of the data heterogeneity and participant retention, standardization of omic clinical measurements, ethical, legal, and social implications. So these are some of the challenges, but they can be easily overcome if there is a collective approach and a mission mode. There are emerging trends: digital twins and continuous health modeling, AI-driven longitudinal integration, then federated global cohorts, and integration with national health data systems like India's ABDM. These are the UK Biobank, everybody understands because of its longitudinal multi-omic pilot, and they have a unique national health information system. So that's why they're able to come up with, first time in the world, with many new innovations. 50,000 participants with repeated omic and clinical data, and identified metabolic markers preceding diabetic onset by 5 years. So this was the outcome of this biobank. In conclusion, I mean, my approach, in fact, I'm pursuing with CCMB on a pilot basis in terms of building this population health of 2,000 staff and the beneficiaries CCMB. But if it can be extrapolated to all the 50 labs, that means we're talking of about 100,000 to 200,000 population. It also improves the health of the population, CSR people, in terms of health promotion, disease prevention, and early detection. But also, each lab can actually do the study of their interest in terms of the disease progression, the discovery of new molecules, discovery of new therapeutics based on the understanding of this. So this is my strong, I think, recommendation as a closing thing, which is apt for this Cohort Connect, is to how do we actually collaborate both the clinical sciences and the basic sciences and the applied sciences across the research labs and across the national institutions. We have the wonderful, I think, opportunity, because everything is converging in the country, and to bring out information which have been missing for many years. I mean, we still depend upon. I think, I mean, even for just predicting cardiac risk in 10 years, we still depend upon the Framingham study. We don't have our own study, and that study is not applicable to us. Our pollution is different, our genes are different, our infections are different. We are double the risk. Suppose if you come estimation of 10% risk in 10 years, you have to extrapolate it to 20 years. But our primary prevention programs in the public policy still depend upon the WHO-based the risk assessment, which may not be erroneous. Nobody has. So I think this study, this phenome study and the CSIR and also some of the ABDM, this convergence, we have the golden opportunity. Apologies if I exceeded the time, but thank you.
Thank you, Dr. Reddy, for a wonderful talk and new insight at how should we go in future. Any question for anyone? If none, thank you so very much. Do you have any question? Oh, thank you so very much for a wonderful talk. We invite other speakers.
Yeah, the next speaker is Professor A.B. Day. Professor A.B. Day is the founder head of the Department of Geriatric Medicine at All India Institute of Medical Sciences, which he started as a weekly clinic and eventually became a full-fledged department. And he was also instrumental in establishing a National Center for Aging. He has been involved in a number of government programs and is a principal investigator of the NIH-NIA's Longitudinal Aging Study of India, Harmonized Diagnostic Assessment of Dementia, in addition to several funded projects as well. And that is the topic he's going to talk to us today about, going to provide an overview of this study.
Computer kahan hai mere samne?
Over to you, Professor Day.
Computer kahan hai? कंप्यूटर कहाँ देखूँ? नहीं मेरे सामने भी कहाँ? Good morning, everybody. I was supposed to be in Pune this morning for our Academy's conference, Indian Academy of Geriatrics, but Lord desired that I should be in Bhubaneswar, so he instructed Dr. Maiti, and I had a good darshan yesterday. Thanks, Dr. Maiti, CSIR institution, IMMT, and IGIB for having me here. We started doing geriatric medicine quite some time back and realized that apart from multimorbidity and comorbidity, the terms you learnt during the COVID time, we had three entities which are extremely important for older people. That is cognitive impairment or dementia, sarcopenia, and frailty. I'll give a short description of LASI because this data comes from LASI. LASI is a Government of India study started in 2016 and ended in 2018, fast wave. Fast wave 2 is yet to start. LASI contains 73,000 old Indians above the age of 45 years, of which 32,000 are above 60 years. So this is the base on which LASI-DARD was started. LASI-DARD is a sub-study of LASI. We have completed 2 waves till now. As this audience is not very familiar with dementia, aging brain, etc., let me tell you, like graying of hair, the brain also grays and lot of things happen in our brain. As a result, some individuals have some memory lapses, and others do have severe cognitive impairment which makes them socially unacceptable and unable to perform or exist independently, so we called it dementia. Dementia is a clinical syndrome where all these things are happening. It contains a lot of behavioral problem. What matters to the family is cognition in the beginning, but at the end of the day, it all behavioral problem that affects caregiving. There are many causes of dementia. There's a big list, and Alzheimer's disease is the #1 cause, followed by vascular dementia. We being very high risk of hypertension, diabetes, and coronary artery disease, possibly we have more vascular dementia than Alzheimer's disease. Difficult to predict at the moment. Alzheimer's disease was romantically described in a German lady who was suspicious of her husband's fidelity in 1906 by Alois Alzheimer, and lot of research have been done, but treatment is yet to be developed. Treatment is to be established. Dementia diagnosis requires, it's quite difficult, it's the clinical diagnosis. First we diagnose dementia, then try to find out a cause. And in LASI-DAD, we wanted to look at how things are. Diagnostic criteria change from time to time. The latest is 2024 revised diagnostic criteria. And in 2024, Lancet Commission found published an article on, there's the latest one on dementia prevention and intervention, and kindly look at this design, which says that of all the dementias, because we cannot make Alzheimer's disease diagnosis in the field situation, 45% have a modifiable risk factor. So LASI-DAD probably started as a dementia diagnosis study, but we are now looking at more at modifiable risk factors than anything else. If we look at how it started, it's an in-depth study of people who are above the age of 60 years. It linked to LASI, and as I told, LASI-DAD has moved a big way. Please look at this. This is the map of LASI-DAD. The green map is, green states are all the where both the waves have been done, and the yellow states are where the second wave has been done. So virtually it covers most of the country except Himachal and some northeastern states and the states or islands in the sea. It's very difficult to organize a field study where we do not have a collaborator or a partner in the local areas who can recruit staff and go on having field work. So all these people who are recruited are part of the main LASI, and from there we, with the permission of IIPS, which owns the LASI data, or with the LASI cohort, we took up the persons who can participate in the study, a lot of refusals. So in the wave 1, we wanted to do 4,500, but LASI and COVID made it 4,096. We stopped it there. In wave 2, we discovered that 982 deaths have taken place, interwave deaths of about 25%, and lost to follow over 549, of which 225 could not be located because they have moved with the family or something or else has happened, and 324 refused. So we had a new sample of 2070 and 2,565 repeat samples were done. These are the places where the study was done, quite an exhaustive one. These are the Indian places where things have been done. Please look at the left side of the study. Initially, we were having state medical colleges, and then I thought that it will be good to get the AMSs involved so that we can have continuity and lesser bureaucratic control over the work. So that's why there are 8 AMSs involved. Then we have schemes, and then JIPMER, Nizams. So we, from state medical colleges, we moved to AMSs and state autonomous institutions. All India Institute of Medical Sciences was the starting organization who had the HMSC and the ethics for the LASI. University of Southern California is our US partner, which provides the technical and the funding, and International Institute of Population Sciences Bombay owns or conducts LASI, so are the basic mother of all the survey. So these are our international partners. Currently, we are working in Tamil Nadu for an eye pilot, and also we are trying to develop a collaboration with CCMB Hyderabad for genomic studies. And these are the commercial partners. We looked at as the issue of harmonization of analysis. All our blood tests were done by Metropolis Labs, and Medigenome Laboratory did the genomic studies. And these are the 5-6 MRI labs which did the MRI studies. This is the protocol. This is a study protocol. You can have a look at it. I will wait for a few seconds here. A geriatric assessment, a cognitive assessment, and then blood samples, biomarkers, MRI, and some special tests. So quite an exciting work and difficult to organize also. The innovation is that of online clinical and clinical consensus study for diagnosis of dementia, where the data was analyzed by 4 geriatricians or psychiatrists, and when there was no consensus between the diagnosis of dementia, it was referred to 2 referees, Matthew Verghese from Nimans and Mary Ganguly from University of Princeton. They looked the final call whether this patient has got dementia or not. So this was quite interesting. 12 local languages, the protocol was translated to 12 local languages. So all the interviews were conducted in local language and Hindi or English if the patient referred to so. We had ocular imaging, the study is going on. We are looking at hearing, that study has been completed, looked at pollution in the home setting. So these are some of the things that we have done. So these are the cognitive tests. Different scales were taken up and we picked up questions to make a scale that is acceptable to everybody. And there are two components of LASIDAT data collection, the informant, and the respondent who is the patient or the study on whom the cognition is being tested, and a family member who corroborates with the question answers that the respondent is giving. So this is how this was conducted. The health assessment was a comprehensive geriatric assessment. Lot of things were done. We have done some innovative nutrition assessment, which have developed a scale and harmonized to all the states so that we can draw some conclusion about what sort of nutritional factors are preventing or accelerating dementia. The blood test, all routine blood tests were done, and then the six proteins were tested by a single equipment, Simoa, in AIIMS biophysics department. So there was no risk of having different equipments used for the laboratory test. So the tests were rather harmonized. So standard blood test in Metropolis and specific proteins in at AIIMS biophysics with Simoa machine. So these are some of the geriatric tests we have done, functionality tests we have done, and found them to be very useful. Neuroimaging was done in wave 1 in 137 and in wave 2 in 640 persons, 40-minute duration. It's rather difficult to organize a MRI in wave 1 because 3 Tesla machines, Siemens, Philips or GE having standardized, they agreeing to get a person. So, but in the second wave, more labs were available to us to get all our MRIs done. We looked at various exposomes, if you remember that Lancet diagram. So a lot of factors outside the body are affecting our cognition. So these are the things that we have done: ambient air pollution, indoor air pollution, CO2 monitors, and we also looked at GPS data to find out how pollution is affecting our cognition over a period of time. We had finally, this is the final important slide. What is the prevalence of dementia? After all, we were looking at dementia step prevalence. 7.4% of Indians above the age of 60 have cognitive impairment. Dementia prevalence is greater among less educated females and rural residents. And there is significant variation of dementia across states. Please look at 3 states, the state of Odisha, West Bengal and J&K. We got the highest level of cognitive impairment in India. This was published in Alzheimer's and Dementia. So 8.8 million Indians above the age of 60 years have cognitive impairment. The economic cost of dementia is about 630 crores per year. So this is how cognition was looked at, and the cognitive test battery was harmonized across 32 countries with cultural and national and cultural level modification. So health and retirement studies across the world, there are 32 countries which are carrying out, and the dementia protocol is nearly similar except for some modification which is culturally appropriate. And as I told, clinical consensus diagnosis, one of the innovative ways of trying to make a diagnosis from data, because after all, it is impossible for a field worker to make a diagnosis of dementia while taking an doing an interview in the field setting. So we looked at all the data, did a CDR, Clinical Dementia Rating Rating Scale of Washington University. The raters were trained in that, and then they looked at the data and made a diagnosis of possible dementia, and that were confirmed with 2 other experts who took a final call. So all the diagnoses that we say, 7.4%, have been confirmed by 2 psychiatrists. So these are the risk factors that I looked at. 22% had no education, 40% has vision impairment, 12% had physical inactivity, and 8% had social isolation. So these are some of the issues that we are looking at. Newer exposomes also in the next wave. So pollution and cognition, we coming from Delhi with some 800 AQI yesterday. So obviously we have a stake in this. Pollution is an important risk factor for cognitive impairment. We have already published this. Blood-based neurodegenerative markers, 6 proteins have been assayed on the first wave samples, and now we are going on doing it in the second wave sample, and to see if it changes over time and how it is making a difference. Please do remember that there are a few monoclonals who have come approved by FDA for beta-2 amyloid protein and related to those enzymes. So it is important that we must know whether they are really important in our context or not. Wave 1 data is available in public domain, and this is the website when anybody can access the data and do the analysis if they feel like. And Wave 2 data is also getting uploaded as things are just getting sorted out. So data is available to general public. The genomic data, we are trying to upload it to Indian database. The process for that is have started. It just requires a few ethical clearances, and data will be genomic data of 2,700 people will be available to researcher for analysis. Away from the dementia study, an interesting work was published by Priya Murjani from University of California in, I think UCLA or something. She told that the migration things are going on for last 50,000 years. This is a population genomics paper, unrelated to what our purpose was, but this is an interesting paper. We gave it a very big, good publication. So future direction, we are planning Wave 3, which will start in 2026. Funding is a major problem. We'll repeat most of the things. We are looking at natural language processing, temperature monitoring, and gait speed, sleep, and all those things as new parameters to look at how it affects our aging, and probably take a younger sample to look at cognitive aging starting in 50s rather than going to 60s. We expect this to start in late 2026. Challenges were many. Working with doctors with limited interest in research in India is a very major issue, but somehow by taking AIMS and other central institutions, we have addressed that issue, that they are forced to be interested, and they are generally interested in that. Local international leadership may not be very interested, and hostility towards field work in urban communities were extensive, because they do not know what AIMS New Delhi is wanting. They want a local medical college or local medical school to be attached to this, so that the field worker can go and say that I am coming from PGI Chandigarh, or I am coming from SC Medical College Cuttack, so that they will say, okay, we know this place and know these people, you can agree. We have a few law and order situations. Recently in Kerala, our field workers were taken to the police station because of local political issues. So keeping the work so motivated in field work is very difficult. A lot of attritions do take place. So these are the challenges which probably in the study that you are conducting, you may not be facing, because you are rather a very captive audience, but we do not have a captive audience. People say that get lost today, I am not feeling like. Especially if you are looking at a 70, 80-year-old person, field worker may be told, I am very busy today, I am not feeling well, my daughter has come, I am not going to have talk today. So these are some of the issues that we faced. This is a LACIDAD is not state-specific data. The state samples are too small, but country sample is good enough. So it's a representative sample for the country and not for any location. And this is NIH funding, and I thank you for your attention.
Thank you very much, Professor Day, for sharing with us your findings. Do we have any questions for Professor Day? Yes, sir. Shailesh, please. There should be a microphone around you.
Can you speak to Mike? Please, just hold on for a minute.
Can you share some challenges that you find while doing MRIs in general population? Because we find it quite challenging.
It's extremely challenging. I agree with you. First, agreeing to be inside the machine for 40 minutes when a person doesn't have a health problem, it requires a huge amount of persuasion. And we face that. But somehow, some of our field workers were good enough to convince people that it's worth doing. So it's a major challenge. And if the person has some degree of dementia, how he or she will react inside the machine is also unpredictable. So we had only one reaction where a patient possibly had a cardiac arrest or something, but could be revived in Kolkata. Otherwise, MRI in general population in community is very difficult.
Professor Ganguly, please.
Actually, you have a care pathway.
Shailesh,
actually, what I am also making the same comment. We have in Apollo in the bus a PET MRI. So our imager, Dr. Jena, has created a Indian brain matrix, and we are using some probes like the peptides which you showed from the tau protein as well beta amyloid, etc., to trigger those images to find out the functional changes in the Alzheimer and dementia, the changes which happen, the subtle changes which happen. So one of the, but this is frightfully expensive, and we were really struggling with creating a software which will analyze it appropriately and bring it for the interpretation to the common every physician. But this expensive thing can't be really taken to people.
Yeah.
So
yeah.
The one more point I want to make that with the Prasoon Chatterjee, who used to work under you and now has gone to Artemis, we have embarked on a very major, ambitious multi-omic study on the centenarians. But one of the major area which we find is we can do something very easily is the microbiome of the elderly, because the neural system and the gut in the elderly are so different than those who are young, that they suffer from constipation, they suffer from lack of motion, and it is not corrected by any drug. And dysbiosis is a very common feature in the lack of diversity. So really giving a fecal microbial transplant to these guys from the super donors with a good consortium really brings in wonder, while their metabolomes change appreciably towards the better. But this was actually lacking in the LACI study, so we should include it in future studies.
Yes, sir.
All right, thank you. Thank you, Professor Day. We'll move on to the next talk.
It's our pleasure to invite Dr. Deepak Saini. Dr. Deepak Saini is a long-term advisor to WHO, and because of his interest in establishing genetics in our country, he was included at the top 50 leaders by WHO in 2022. We know Dr. Saini has a title Saini, but he converted his title into an acronym. And the acronym says that this is a signaling in aging, inflammation, and infection. So Dr. Saini, please.
Good afternoon, good morning, everyone. I think we're still in morning, right? I'm just waiting for a connection to my laptop. But I think there is not major I can add after 4 previous talks where pretty much everything has been covered. I can just bring you the context of what we are doing with respect to this particular project. So while these slides load, I'll just quickly tell the previous speakers have done a fantastic job of covering what longitudinal studies can give, the challenges, and also what are the learnings which we are looking for. So I think I can skip half my presentation. So which is the best part. That means I can save time for everybody, but I hope my PPT can load. So the study which we're doing is called the Bharat study. I hope the PPT loads. Is it there, right? Okay. So it's perfectly fine. So it's called the Bharat study, and I represent Longevity India initiative. And for those, Longevity India basically means Ayushman Bharat initiative. And the narrative actually started with something which our group was doing for almost 2 years. And the Bharat study is actually an acronym which stands for biomarkers for healthy aging, resilience, adversity, and transition. Actually, from a clinical or a healthy person's perspective, that is exactly what we need to capture, that how does our body change at various stages of aging, and resilience for people who recover much better, and in adverse events, what fails in our body, and what are the markers which can tell when our body is undergoing transition. For this slide does not really need an introduction or does not need any information, but it's quite self-evident that there is a fundamental difference between lifespan and health span. When we talk about longevity, a lot of people actually talk to us about where you're talking about increasing the lifespan. The idea is not to worry about the lifespan, but worry about the health span. And for a country like India, which has got a lot big roots, lifespan is traditionally linked to greed, and the health span is for necessity. Because a lot of India, which is in a rural setting, the lifespan is not of consequence, it's actually the health span because of the dependency-related issues which we have. And if you look at historically, we have actually seen the public health initiatives actually is the greatest contributor for life expectancy gains. And then next comes the medical treatment, and the pharmaceuticals is like 35%, which is changing the way the narrative of life expectancy is talked about. So question is, what affects health span? And again, the previous speakers have done a fantastic job of covering. Shantanu has done a lot of great details. So while there's a good amount of genetic influence which we have in our health span, our genes contribute to how we're going to get old, but it's largely the environment, the exposome, which is going to change. And the risk factors for which affects longevity or health span is loneliness, metabolism, physical activity, unhealthy diet. It's all the same information which everybody talks about. And the next slide is even more same, because we have heard every speaker talk about that for India specifically, we have a shortage of biomarkers. I mean, we love to talk about biomarker discovery, but biomarker discovery needs a very good reference data, which is corrected for age, gender, socio-economic background, rural, urban, economic background, diet, lifestyle. We don't have that data. So what we do is we keep the person who's walking in as a family member, and we collect their data as a baseline data. And the question arises, is it the right baseline data? So one of the interesting things which we want to do is to generate this Bharat baseline data and keep it public so that any kind of biomarker discovery in future can actually benefit from this baseline data information. Then we talk about specificity of population. Again, in India, given the diversity which we encounter, the geographical regions will actually contribute to a lot of unique signatures which we must understand. And from the longevity perspective, we also would like to know when the dysfunction onsets in your body. Now, jokingly, when people ask me, what do you study? And I ask people, like, which organ should we study? And the answer is,
most people do not know how many organs are there in our body. And it's a challenge. We ask it, so people generally do Google and find out, but I think the easiest way to find how many organs in your body is to walk into a hospital and look at the number of specialties listed there. And that's where the tragedy and the beauty strikes you. That we have become very reductionist in our approach, is we treat an organ at a time. But as we have heard previously, all organs are interconnected. That means we need to understand systemic communication between these organs. Professor Ganguly nicely mentioned about gut healing, and aging and gut goes hand in hand. But is gut the only organ, or is lungs the only organ? In Delhi, probably it's the lung, which is accelerate. In the places where the gut health is poor, it's the gut which is accelerate. So we need to understand, can we identify early onset features of accelerated aging of organs? And lastly, we talk about tailored interventions. Do we have idea about what tailored intervention need to be given to population? And this slide does not need an introduction to anybody here, but this is where the evolution of medicine has gone through. 1.0 was observe, wait, reactive test is 2, 3 is what we are examine and prevent. And future of the medicine is called monetize, monitor and optimize. And the classic question is, monitor what? We always talk about monitoring our health features or parameters, but actually they are features of sick care. We are basically looking, when you look at a blood work, are we sick or not? We are not looking at what are the health parameters, and that's a fundamental challenge which we are looking at. Over the last 2 years, we talked a lot of industry, and everybody wants to develop new tools and platforms and technologies. And if you not summarize all what they're doing is, these are the 6 S the entire industry of healthcare is based on. Can I get a more specific sensitive test? Can I get a safer test, safer therapeutics? It should be simple, scalable, and lastly, sustainable. Now, these S's are the essence of the future of healthcare. But the idea is, what is that S, each S is going to contribute to the feature which we are looking at. So in longevity or aging, there are many places the science has fallen short of. I mean, look at where is the science fallen short of. The aging is far more complex. There is a lot of interconnected in biological system, so we need to understand how these are connected. Model systems, which are very great tools to study aging, they have actually fallen short of being applicable to human. There's a lot of individual heterogeneity or variability, and there's a lot of psychosocial factors which we must account for. So what's the answer? What's the solution? We know the problem. We know the problem that Western data is not equal to Indian data. We must do large-scale cohort studies. The need is there. We need deep continuous data. That's why longitudinal data. And why data? Because people talk about AI being the solution, but AI without data is meaningless AI. So we need to generate data for AI to be deployed first. So science for AI is what we need to do. So vision is to actually want to create an Indian longevity or aging data set. And our team strength is actually integration of people who are clinicians to data scientists under one roof. And a lot of people who do basic fundamental science to collect high quality omics data, that's where we are making the difference in terms of data acquisition. So this is where Longevity India, we started about 2 years back. Shantanu said the Phenome India is the youngest. Probably we have started after them. And we still are collecting samples, because what we have realized that when you analyze a lot of omics data, there's a lot of variation which comes from the batch analysis. So we must analyze a lot of samples in one go to prevent batch-to-batch analysis. So we're still collecting a lot of data. And this is where Longevity India has started this initiative, where we want to collect a lot of data from healthy Indians. We do not look at sick cohort, we are only healthy cohort, which is a very big challenge, because as the previous speaker said, healthy people are not in hospitals. We have to reach out to them at the community level, which is a very big challenge, because a lot of old people don't want to know about their health status. So in this study, what we do is we are trying to collect almost 2 million data points per individual. Right in the study, we are aiming at 5,000 plus people. But again, as the funding will grow, we'll probably start recruiting more people. And the idea is each individual. We do a lot of functional, cognitive, metabolic, which is, I'll tell you the details, epigenetic, gut biome, biophysical, and immune profile analysis. So we get almost 2 million data points per individual, which can be used to train AI and machine learning platforms. So this is what we do. So every individual who is recruited, we take 5 samples which are ethically allowed. In the study, we tried to do a lot of other inclusion criteria, wanted to get more tests. We failed because a lot of healthy people cannot be subjected to MRI or ultrasound, and we could not get approvals for that. So with the blood, what we do is we do blood proteome, metabolome, lipidome, epigenome, and immune profile, deep immune profiling. We collect also cheek swab, where we look at the glycation of the cells and also genomic profiling. Here we actually look for heavy metal composition, metabolomics, and hormone panels, and also stress hormone levels. urine is metabolome, hormone, and stool is metagenomic analysis. So the idea is when we collect such a large data set, we would be able to predict based on the age stratification, how is the evolution of age is taking place in this population. These are our study groups, 5 study groups, gender equal distribution for both gender. And there are 5 clinical hospitals which are in the fray right now. We are in process of enrolling more centers. All the sampling is done to community medicine departments. We reach out to people, we reach to Anganwadis, we reach out to schools where we set up our camps, which is a very interesting challenge because we spend almost 1 to 2 weeks to get even 50 samples which are of healthy people. So our team actually goes out multiple times, give questionnaires, give kits to people, and then one weekend we set up a camp in one of the schools or the Anganwadi place, and we actually sample the people. One of the challenges which we face is how do we generate the workflow. So this is a workflow we screen for healthy people. There's a clinical team which actually screens our volunteers. We collect the biological samples, and we do a lot of physical examinations, deploy a detailed questionnaire. And what we found that a lot of questionnaire which we were collecting and on-site, we were using a platform called EpiCollect, but a lot of rural setting of EpiCollect start giving us a lot of problems. So we went back to the drawing board, and we actually developed our own data collection platform with a particular company, which is the AI company, which is based on ODK. And what we do is we deploy virtual machines at this center. Data is collected, anonymized on the site, and it all consolidated on a virtual machine. And the moment the machine connects to internet, the data from the primary devices is erased, and it all goes to a centralized server, which is housed within IISc. So we worked out the issues about how the data sanctity is retained. The next is the sample sanctity. If you're actually looking at sample collection, we realize if you actually collect blood from the individuals and they see how much blood is collected, their cortisol level shoots up like crazy. And then we start getting wrong errors. Their inflammatory cytokine levels are through the roof. So we had to actually put these interesting masks on everybody's face so that they do not get scared about giving blood or they do not get erroneous reading. So all this, we have loads of masks from monkey shape to rabbit shapes. So all the old people are very happy to put this mask and give us samples. And our field team actually processes all the sample on site. That means the samples is collected within 30 minutes, samples goes on dry ice or liquid nitrogen, so the sample quality is retained, because for multi-omic analysis, that is one of the biggest bottleneck. Sample processing, if not done correctly, lead to sample quality loss. Lots of challenges. I mean, the previous speaker talks about native language speakers. So we had to recruit people locally, get tie up with people from the hospital, people actually are happy talking to them. We spend about 2 weeks prior to sampling date talking to people, doing door-to-door survey and getting them onboarded to become part of the study. Hygiene, cleanliness, communication and conduct, resource management, metadata, and all these aspects have slowly been resolved over the last 1.5 years, and this is what we are doing currently. So where is the differential comes from our study? We do a lot of interesting analysis which generally traditionally are not done. We do atomic force microscopy analysis on blood cells and hair to understand if we can collect features of sugar, glycation-related changes from RBCs. We do cytomorphology for glycated end product formation. A lot of cytochemistry is done in-house. A lot of modal lab is a multi-omics discovery and analytical lab which we are establishing at IISc. Several high-end mass spectrometry work will be done in-house. The idea is to bring the cost down, because input cost, we are trying to put an automated robotized omics lab, so we can analyze up to 500 samples in a week. And that would be something which we are open to collaboration with everybody, that if you want to work with us, with our team, we will be able to give you the back-end support for all that. Some preliminary insights, not large number of samples. Preliminary insight shows that we have a lot of undiagnosed diabetes in the population. Not surprising. We see in a lot of these healthy people which are not reported to be diabetic, we see HB and AC level to be higher. We did not see any major relationship changes with cholesterol. Vitamin D was again iffy. CRP in the healthy population, it looks like in the middle age, it goes up. But surprises here coming from the rural-urban divide in terms of HbA1c markers. And if you specifically look at this population, this is the urban population, which is a volunteer population coming from Bangalore and surrounding areas. 45 to 60, they actually had maximum number of undiagnosed diabetic cases. In the rural setting, we actually see increased HbA1c levels as the age goes up, but in the urban one, it's actually the mid-age group which actually had the maximum number of pre-diabetic people who were there. Interesting thing, we did some epigenetic analysis. The whole world is talking about epigenetic clock of aging. We love to talk about epigenetic because that's linked environment to our genome. We did analysis of small subset, very expensive platform. We have worked with Premas, who's been very helpful to do these studies for us. And what we find, that none of the globally established epigenetic clocks apply for India. Actually, they have failed miserably. And according to this clock, I probably am in diapers and my student is 95 years old. So that is a problem which we are facing. So we corrected this, and now we have an India-specific methylation-based clock, which we're still developing. We need more population. You can clearly see a gap in the sample window which is collected because we looked at the extremes of the population. But we have a very interesting epigenetic clock which we have established for India, which can be useful for further studies. And Professor Srimanto here in the audience, his group has been instrumental in doing this for us. So that's what Longevity India is doing. We are actually developing India-specific data. We also have this 3D model systems for aging for various tissues, so we can understand recording from the population level at omics, can we realize those signatures at a tissue-specific using 3D systems so that we can do molecular testing. We can also do therapeutic analysis. We're also a project in gut aging and hormonal aging, and the strength, as I mentioned, is our team. So they're all specialists in different parts of our body: physiology, data sciences. We have geriatricians, nanoscientists, AFM experts, omics experts, computational modelists, chemical engineers. I think the strength lies in the team there, where people can look at this high quality omics data in multiple lenses. And I think it's important that more and more people get to see the data, because I believe in omics or large quality data, more people look at it, more insights emerge from such a study. And that's where we are. So Longevity India works closely with science, clinicians, technology with companies. We're developing a lot of platforms. And also we are partnering with a lot of policymaker organizations like AHPI, Vaya Vikas, Dementia Research Alliance, to actually look at molecular evidence which can become a policy forward document. We have various ways of engagement. We are also very active on the social media and social community reach out, because healthy people have to come from community. So we have a very active engagement through webinars, podcasts, and newsletters, which Longevity India releases frequently. So this is our longevity vision. Longevity is all about durability. And durability does not necessarily translate with lifespan linearly. It actually means how healthy, happy you are. So we are starting with Bharat standards, baseline values for India, nutritional aspects. We do a lot of screening, drug development, therapeutic targets, and biomarker discovery in cellular model systems for aging. And the ultimate objective is what is in the green: reduce hospitalization, bring dignity in aging, preventive health, quality of life, and societal engagement. And these are our partners, academic partners, clinical partners, diagnostic partners, and policy partners. And I'll stop here. And this is on the lighter side, a cat in the hat for aging. And thank you very much.
So thank you, Dr. Saini, for a wonderful talk. Any question? Yeah, Dr. Ganguly, please.
I think we need a microphone there.
Actually, Deepak, you have raised a very important issue. I don't know how do we do it, because there are 3 or 4 major studies going on the similar basis on the multi-omics and other parameters into this. Some or other we should be able to combine.
Absolutely.
And create values which are better normative values.
Yes.
One thing which you have included, we find a tremendous signature on epigenetics, but one thing which is lacking in this study, that we have designed interventions, like these epigenetic signatures could be reversed.
Yes.
Even with the microbiome, this could be reversed.
Yes, absolutely right.
And then in the immune profiling, apart from the inflammatory cytokines and others, immunosenescence is the very important part on this. And one thing which I will like you to include in this, that there is a stem cell exhaustion which happens in the aging population. And these could also be measured. Finally, there is two very major areas which change there. One is the interleukin 18 universe. There are about 64 major data point universe.
Yes.
And that can also be controlled now. And they
Can we shorten the conversation?
Yes, please. And the in women, the senescence in women and senescence in men are very, very different.
Yes.
So if you have women aging population, we will have to include other parameters, including the iron metabolism.
Yes.
Sirtuin universe, NADH universe, and we should do something about these, because when you get an aging population, you are doing these investigations. There are 4 or 5 interventions. Some Dr. Day talked about, then handling the dementia, handling the frailty, handling the sarcopenia, handling the energy deficiency.
Yes.
These are all, there are interventions. So if you have geriatric population, actually Madras Medical College started the first geriatric courses in India. A lot of geriatricians in South India. If you have good geriatric population, collaborators over there, design intervention.
Yes. So, I mean, all fantastic points.
Can we sort the conversation?
I'll just give a very short answer to that. So, regarding the women's health, we actually run a very specific women-centric hormone panel for the women aging. We also believe there's a lot of aging aspects come from the lipid peroxidation. So we actually do deep lipidomic analysis, which is built in the study. Also deep metabolomic analysis, we also look into that. Regarding gut biome analysis, I think one of the previous speakers talked about challenges in getting gut samples. So we have streamlined that process, but we're also planning to establish a gut bank as a part of this study, so to do future FMT related transplant. And regarding including therapeutic interventions trials, yes, we have plans to actually do control testing in the geriatric population and also non-geriatric population to see if these interventions, which are globally well accepted, even work for Indian population. So there is a plan which is in place for these. Thank you.
Thank you so much, Dr. Saini, for a wonderful, wonderful talk.
Thank you.
Thank you, Dr. Saini. We move on to the last talk of this session, which is an industry talk. Will be given by Dr. Sohini Sengupta. She represents Healthians, and the title of her talk is Intersection of Diagnostics and Research, where lab medicine meets science. She is the Executive Vice President of Strategy and Operational Excellence of Healthian Labs India. Over to you, Dr. Sengupta.
Thank you, sir. Very briefly take you through what we do. We, like Dr. Sengupta already mentioned, we are the diagnostic partner for CSIR on the Phenome India study. And we are a diagnostic network of around 21 clinical laboratories in metros, tier 1, 2, and 3 cities. We have a very robust infrastructure which is totally built in-house, starting from sample collection to the logistics to the CRM as well as our lab processes. So we have a total of 21 labs, like we said, and the reference laboratory in Gurgaon, it is both NABL and CAP, that is the College of American Pathologists accredited, and all our other labs are also recognized by the NABL. So we have a test menu of more than 2,500 tests that includes routine, semi-specialized and specialized testing, and all the departments like clinical chemistry, immunoassays, molecular, microbiology, hematology, and flow cytometry and special assays. So obviously, since we are a clinical laboratory, we do understand that we are testing on patients, so diagnosis of disease, then monitoring, then guiding their treatment decisions is of paramount importance. But we also realize that effective patient care can only be achieved if there is a sort of, intersection between clinical research, science, and what we do in the diagnostic laboratory every day. So that's where the CSIR Healthians Association, and like Sir mentioned, there was a harmonization study which was done where the patient samples were tested on different platforms. So we know that the patient today goes to different laboratories, different hospitals, and they are tested on different instruments. So there is an inherent variability associated with it, which is more paramount in certain parameters and less in others. So a multicentric study was conducted wherein 429 samples, blood samples were collected across all CSIR institutes, and they were tested for 26 clinical chemistry and 4 immunoassay parameters on different platforms. So for clinical chemistry, it was on Beckman, Siemens, and Roche analyzers. For immunoassays, it was on, again, DXI for Beckman, Atelica IM Siemens, and Cobas for Roche. HbA1c was actually measured on 2 different parameters, that is the Biorad D100 and Tosho G8. Obviously, we kept a few things constant, that is the regular calibrations and the daily IQC, which I'll come to a little later. And the passing Bablock regression, Bland-Altman analysis, and CCC were done to finally analyze the data. The platform-specific vitamin B12 thresholds were determined using restricted cubic spline regression with homocysteine as a functional marker. So this is the CCC comparison, wherein you see that the comparison has been done between Beckman to Siemens, Siemens and Roche, and Beckman and Roche. So the inter-instrument variability for the enzymatic parameters, most commonly the LFT, like ALT, AST, ALP, GGT, also urea, uric acid, and HbA1c were pretty much okay. Like there wasn't much variability amongst different platforms. Creatinine was consistently overestimated on the Beckman AU5800 clinical chemistry analyzer, while total cholesterol and triglycerides were more or less correlating across the platforms. There was variability in LDL and apolipoproteins. When we came to the immunoassays, ferritin, vitamin D, and TSH showed a good concordance, but the maximum variability was seen in vitamin B12. So if you see lower down, there's this graph where it has been standardized against the homocysteine, keeping folate as the constant, and it has been seen that the rise in homocysteine for a particular level of vitamin B12 varies widely across the 3 different platforms. So while the cutoff in the Beckman DXI analyzer was 100 picogram per ml, on a Siemens platform, again using the same methodology, that is CLIA, it was 280 picogram per ml. It was 300 to around 330 for Roche, which of course uses ECLIA, that is electrochemiluminescence. So different analyzers actually deliver precise results within their ecosystem, that is their reproducibility is very good. But when it comes to the inter-platform agreement, that's where they significantly differ. So what does it mean for the patient? A patient nowadays, like I've already mentioned, tests themselves in different laboratories, different hospitals across instruments. So how do you standardize this? So comparability of lab results should be independent of time, place, and measurement procedure. It is crucial that different measurement procedures produce results that are comparable as well as reliable, regardless of which laboratory produced the result or when they were produced. And so this emphasizes on the critical need for harmonization. So even the IFCC, the International Federation of Clinical Chemistry, has been trying to do a harmonization study on TSH for a very long time. So likewise, any harmonization study or any result should come along with a reference interval that is not only method specific but also instrument specific for that particular population. So what we tried to do at our end was to be transparent and disclose the name of the instrument and the method on the patient report. Also, we put a note whenever there is a change in the methodology or the instrument for a testing parameter for the patient and the clinicians to be aware of that particular change. Now, a question that often comes is, Is it only about the difference in the methods or the instrument, or is it about how stringent you are about your quality processes? So what we do to ensure quality is to have a 3-level quality check at the pre-analytical level, where it is totally pre-barcoded sample collection vials are used. That's what has been done for the CSIR study also. ETRFs are generated through app-based entry of patient details, and there's a temperature logger in our collection bags. Automated sorters are used for segregation of samples. We do have a 2-level internal, we use 2 levels of internal quality controls at the PCARs, followed by 1 level every 8 hours as per the NABL guidelines, and we are enrolled in the proficiency testing programs from CAP, AIMS, CMC Vellore, and Biorad. So in the post-analytical phase, what we do is we have a bidirectional interfacing. There's no manual intervention, so no chance of transcription errors. And we have delta checks, again totally automated for clinical correlation of test results, auto-validation for normal reports, and of course pathologists to release the other reports. It is a tech-enabled paperless process right from test requisition to the report, delivery of report. So this is how it is, how we control the report accuracy. On the right you see we are disclosing the name of the method as well as the instrument. And whenever the sample is tested on a different instrument, it would reflect it on the report likewise. So this is in a nutshell about the harmonization study that we've done with CSIR. It's still continuing. I would just like to add one slide as I conclude on the introduction of a few novel biomarkers that we've started. Of course, it was very interesting to hear about the longevity study and the Alzheimer's. So we've just introduced the first blood-based biomarker, which is FDA approved, because so far it was all on CSF, or it needed to be a beta amyloid PET scan. So it is a blood-based biomarker, again CLIA-based. It tests p-tau 217 and amyloid beta 142. So we basically give the ratio for this. Then early cancer screening, which is a flow cytometry multi-organ screening based on APO10 and TKTL, that is trans-ketolase. Early detection of interstitial lung disease by testing for KL6. Food intolerance by microarrays, and an advanced complement result diagnosis, that is for allergy testing, again by microarray. We've also just introduced the enhanced liver fibrosis, so that's on metalloproteinases, then procollagens and hyaluronic acid. So thank you all very much.
Thank you very much, Dr. Sengupta, for sharing with us your experience and making us aware of these pitfalls. Thank you. I think with this, we come to the end of this session. Oh, sir, you have any comment?
I have a small comment over here, that when you do vitamin B12, yes, Indian vegetarians do not have vitamin B12 in the food, yes, and they boil milk. And there is a vitamin B12 malabsorption. So we have to set the normative values in very carefully. The same is for the folate. There is a sufficiency and deficiency, and then the tetrahydrofolate reductase mutations, as well as the homocysteine epigenetic arrays which are there, they need to be measured.
Yes,
so
sir.
we will discuss it. That
So we had actually done a study that was long back, 2013 I think, in St. Stephen's Hospital in Delhi. So we saw that in vegetarians in India, there is a deficiency of B12, and it corresponds to a high level of homocysteine, which indirectly also corresponds to a higher incidence of cerebrovascular disease in this particular population.
Thank you. I think that discussion can continue over time, but we are way behind time, so we'll conclude this session. Thank you, everybody. We have a tea break now, and I don't know if you want to shorten the tea break or it will still be of the same duration. So, Shantanu, when do we come back? When do we come back?
12, yeah.
15 minutes break, and we are back here sharp at 12.
Yeah. Thank you, everyone, all the speakers and chairperson of this session. So let's assemble at 12 so that we can maintain the time also. Thank you. session 2. So this session will be chaired by Dr. A.B. Dey and Dr. Lakshmi Ramakrishnan. We would like to request both the chairperson to please come and join us on the podium. Dr. A.B. Dey, who joined us late, I just want to tell that Dr. A.B. Dey was the former professor and founding head at Department of Geriatric Medicine, AIIMS, New Delhi. And Dr. Lakshmi Ramakrishnan, she is a professor at Department of Cardiac Biochemistry, AIIMS, New Delhi. So she is an academic researcher at the Department of Cardiac Biochemistry, Delhi, and her research focuses on the immunology of autoimmune and inflammatory diseases, particularly skin and cardiovascular conditions. So this work involves in vivo and in vitro studies to understand the cellular and molecular mechanisms behind diseases such as vitiligo, psoriasis, cardiomyopathy, and heart failure. So please.
Thank you very much, Professor Ramakrishnan and Professor Dey. If I can have my slides up, please. I'd like to start by thanking Dr. Shantanu Sengupta and Dr. Shobik Maiti and colleagues here at IMMT for this wonderful organization and for putting together this group, really. As I would say in my concluding remarks also, this is perhaps one of the most important initiatives that those who are interested in cohorts need to take. Bringing different cohorts together and learning from each other and thereby perhaps making it a force multiplier effect rather than just doing one's own individual thing. Can I have my slides up, please? I don't know who's managing the slides. So I represent here the Indian chronic kidney disease cohort, but I'd like to also add that I am, in addition to being a clinician, I have been in the population health research field for the last 13 years and heavily involved with implementation science. So my thinking has also been colored by some of those experiences as population health researcher and implementation scientist. Can we go back, please? Yeah.
Yeah. Down arrow is
it's not, the slides are not moving. What I'm going to talk about is not necessarily to describe the cohort, but what has been our experience and what are the lessons that we have learned, and hopefully those are the lessons that we can continue to discuss through these 2 days. So in terms of the age of the cohort, we are perhaps one of the older cohorts in this room. We started in 2010. And I'm going to now tell you a little bit about CKD, and I'm glad I had debated whether to include those slides or not, but I'm glad I did. And Shantanu, this is for you, if you're listening. We know that chronic kidney disease is a highly prevalent global disease, and that the global prevalence is between 9 and 13%, no matter in which part of the world we live. And what is even more important is that because of public health interventions, mortality rates due to almost all non-communicable diseases have been falling in the last 20 years. But as you can see from the left bar in this graph, the mortality due to kidney disease is still rising. So it is a kind of neglected non-communicable disease. Why I say neglected, even though the correct term is cardio-kidney metabolic, Shantanu omitted the word kidney in his slide when he says they're studying cardiometabolic health. And this is important, this is not simply a matter of joke, because kidney is often forgotten. And out of the various highly sophisticated markers that everyone is measuring, no one mentioned measurement of urinary albumin, which is one of the most easily measured markers and is a very sensitive indicator of cardiovascular health and can be easily implemented at a population health level, whereas all those fancy omic studies, which you also want to do, by the way, are difficult to implement at a population health level. In fact, so much so that kidney disease is currently the 3rd highest rising cause of death around the world, and from its position in the list of causes of death from number 16 currently, it is going to become number 5 in 2040.
So kidney disease is important. And with that in mind, in 2010, we approached the Department of Biotechnology with the intention to set up a cohort of patients with early stage chronic kidney disease and wanted to understand the rate of progression of kidney disease and end stage kidney disease development. Because a lot of patients, I'm sure those clinicians who still see patients know that patients with kidney disease often present very late in the course of their disease, and we don't know really what caused them to progress to that rate, whether they progressed over a period of 10 years or over a period of 2 years, and what are the factors, and so on. So we set up the Indian Chronic Kidney Disease Study initially with funding from the DBT in a pilot phase for 2 years, which was implemented at PGI because they wanted us to demonstrate that it can actually be done. And so when we said sure it could be done, then we got funded for a multicentric phase, which was across 11 centers across India. And the first thing we did was to really put together a governance structure by constructing a steering committee, and the steering committee had also a number of subcommittees as well, and I'll talk about them. We developed infrastructure at every center, and this was mentioned by Dr. Abide, I think, that clinical centers are, and researchers and clinicians rather are reluctant to do research. So it was very important to support them with development of infrastructure in their individual centers, and that they should also feel that they are not FedEx researchers, that they are sending samples to somewhere, and that research is actually done within the center themselves, to borrow a term that Professor Ganguly mentioned this morning. So I think I'm going the wrong way. And so biobanking was also a feature of this study, as it is for almost all the studies. So these are the 11 centers. They were spread across the country and hopefully represent the width and breadth of the population of the country. Chandigarh is shown there in the red because that was the PGI center is the central biobank. This was our goal: risk factor of progression, cardiovascular disease development, high risk subgroups. And the last one is important because I'll come to that towards the end. I think that is one of the most important outcomes that we have had so far, which is of public health importance. Why do we need to do a cohort study in India separately? Just like with other diseases, chronic kidney disease in India is also different from the chronic kidney disease that is described from the other parts of the world, both in terms of its phenotype, in terms of its rate of presentation, in terms of the age at which it presents, and this is something which has been documented several times, including for the first time in 2005, when we actually analyzed data from the Indian Chronic Kidney Disease Registry, which was simply a cross-sectional data set of patients with chronic kidney disease from multiple centers. And you see recently conducted meta-analysis on the right, which shows the prevalence of chronic kidney disease in different states. So, not sure where we are going with this. So this was the inclusion criteria, and the exclusion criteria design paper has been published. So again, the goal is not to describe that in great detail. We have going fast forward. We were successful in recruiting subjects on time, recruited more than 4,000 subjects, to the extent that it is the second largest CKD cohort in the world, and of course the only one of its kind in the developing world. It has established multiple national and international collaborations, and we are in fact leading the international network of chronic kidney disease consortium, which is the consortium set up by the International Society of Nephrology. So we have developed a model electronic biobanking solution, because when we started doing it, we didn't have a professional lab management software available, and we had to develop it from scratch. And we have started helping other centers also establish similar solutions in India, because it can be done really at a very, very low cost. Then in 2016, we were funded for the second phase of the study, and this continues to follow up the recruited subjects to collect endpoints, and the goal is to develop predictive models. and assess differences in various subgroups, and use the cohort for a platform for clinical trials. I would again emphasize the last one, because unless we use such a platform to also conduct clinical trials which will generate the highest quality of evidence to inform clinical practice, to inform guidelines, we would perhaps not be utilizing the value of the cohort to the greatest extent. This is just to show, not really for you to stare at each of the number, simply to show that we have been successful in collecting outcome events, and that is already giving us a lot of data which we are currently mining and looking at developing predictive models, etc. Biobanking, we have established, as I said, a distributed biobank. So what is a distributed biobank? A distributed biobank is that we have a biobank at each center. And then, in addition to keeping samples at each center, they also ship samples to a central biobank, which is at PGI. So this gives the centers an incentive to conduct research, to conduct and explore their own hypothesis. They can utilize the samples that they have at their center to formulate some local hypotheses and test them. So currently we have 13 freezers at PGI, and we have 9 freezers at 9 centers. More than 125,000 sample aliquots are there, and more are being collected, and we have, as I said, a central biobank management system. This is simply a picture of that, and this shows the steps of development of an in-house biobank management system, which allows us to track every single tube, no matter where it is located out of 125,000 tubes, either in the central biobank or in center-specific biobanks. And now this is another innovation which was developed by our researchers during COVID. Because during COVID, it became impossible to follow up individuals and collect information from them. So a mobile app was developed, again in-house, and that mobile app allows us to, this mobile app was shared with all the participants, and the mobile app allows the participants to upload their own data, and that data directly merges with their central record. And they can upload source documents also. So it makes monitoring very, very easy and efficient. It can be done at centrally, because monitoring for those who do this kind of thing is a huge challenge. And that goes to data quality, which has been mentioned a few times today. In terms of academic outputs, because unless we are peer reviewed by our peers, I think the value of the data remains always questionable. We have had already 21 publications. Almost all of them are in Q1 journals, and they have been cited a number of times. And these publications have also informed a number of global initiatives that have been taken by different groups around the world. Now, this is the most important finding, I would say, which has a policy implication. That of, and Dr. Ganguly did mention about the importance of collecting normative data. For those who went to medical school, you will remember that we have all been taught that normal GFR in an healthy adult is 100 to 120 milliliters per minute per 1.73 meters squared. But now we find from our studies that is not true. The average or the median GFR, when we measure it, as you can see from the red line in this nomogram, is actually closer to 90 than to 120, right? So Indians have a lower glomerular filtration rate, whether it is due to lower muscle mass, our vegetarian diet, or some other factors, maybe fewer nephron numbers and so on. That is something which needs to be investigated. And the second and even more important point for public health importance is that the current CKD classification scheme uses the global benchmarks for classifying stages of kidney disease. But if this value is correct, then perhaps we are over-classifying individuals with kidney disease. We need to actually ascertain what is the significance of this, whether people have kidney disease or this is a normal physiological state that we are in, by conducting a longitudinal study of these individuals and looking at their outcomes and relating them to baseline EGFR, which will take 5 to 10 years. But I think that is a very, very important study that needs to be done from a public health perspective in India. And on the right side, you can see a graph which compares the GFR from GFR in the European population. The European population is shown in the black lines. So the middle black line is the median GFR in Europeans. and the middle red line is the median GFR in Indians. So you can see that it is the median GFR in Indians is closer to the 3rd centile of European normal distribution of GFR. So very, very important that we take this further. We are also, as I said, using this cohort as a platform to undertake a number of ancillary projects of public health importance, such as randomized clinical trials, and they are all listed here, including, but also working with, for example, THSTI to undertake biomarker identification studies, and use the infrastructure that we set up to develop also a community-based cohort. And that community-based cohort is located in Andhra Pradesh, in coastal Andhra Pradesh, where there is a population that develops chronic kidney disease in really very high numbers, and the cause of that kidney disease is not known. They have a kind of different phenotype. There is always a challenge for cohorts in India to find how to sustain themselves. And that is both at the level of the center, but also at the level of overall, cohort, as well as biobank, as well as the human resource that has been created. Because we get funded from DBT, let's say, in 5-year terms, and this funding can end anytime. And what happens when it ends? We will have to let go of everyone who's being supported and has been supported through this scheme for the last 10 years, and all that knowledge and resource will be lost. We'll have a challenge in simply maintaining the biobank as well, and just ensuring that the database hygiene is appropriate and so on. So each participating center is doing its bit, but I think resources are finite, and we'll have to make sure. So what we are doing is that using some of the funds that come from ancillary studies to support the central biobank as well, and the central cohort. But again, that's not infinite. We are trying to get to international collaboration. One possible source of funding is collaboration with biotech companies, which are mostly based outside of India, that are interested in discovery research and finding druggable targets using omics approaches. And there we run into challenges related to regulations. A number of regulators in India are really very skeptical of these kind of collaborations, and I don't know what is the solution. And that is where I said to Dr. Sengupta that this kind of coming together of cohorts and coming out with position papers, statements, requests is going to be very important, and hopefully will force the regulators to change their mind. So again, as perhaps the keeper or custodian of ICKD, I'm making all of these points, but it is really important to maintain this kind of cohort, but it's true for any other cohort that all of you are engaged in putting together and running, because eventually what do we want? We want to improve patient outcomes. And that goal can only be achieved by making sure that our cohort contributes to those kind of initiatives of public health importance, and making sure that these platforms are again open to everyone, making them as open source as possible. And these are some of the hard-earned lessons. In terms of participants, I think ensuring participant retention is really key, and that's a challenge, and we have to continue to innovate to make sure that we keep on making sure that the participant contributes data in whatever way it is appropriate for them, right? We have to work with them rather than force them to follow whatever model that we want them to follow. The value of a robust database design and effective quality assurance mechanism, risk management, etc. is key and can never be overstated. Biobanking, as I said, it's an investment. It is not an expense. And I hope the funding agencies realize that, and that these resources that are being created, these are national resources. They don't belong to an individual, and it is very important also for the groups to create succession planning. For example, if once I step away from this role, someone should take over, right? So we are doing that in our ICKD cohort. We are building a next generation of leaders who will step up and take on the leadership of this. Data sharing and international comparisons are the multipliers. We should be able to present and be willing to be peer reviewed against our global counterparts, no matter where they are, and ensure that yes, it stands the test of that peer review. Capacity building is critical, and we should not lose capacity. It will be really a devastating loss if that happens because of lack of funding. So sustainability does remain a challenge. Translating research requires an intentional design, including multi-stakeholder input, and making sure that we think of implementation when we are designing the cohort. It should not be simply for the purposes of satisfying one's own internal curiosity, which is important. Discovery research is important, basic science is important, but as disease-specific researchers, we also have to think of the eventual beneficiary, that is the people with the disease. And eventually we also realize that these diseases, as I said right in the beginning, cardio, kidney, metabolic, liver disease, etc., they don't occur in isolation. They all occur together. They share common risk factors, they share common predictors, biomarkers, etc. So we need to pool our resources. We can't be doing our kidney thing in a silo and liver thing happening in some other silo, etc. We have to bring it all together, because eventually it is the individual who has the disease. It is not just the organ that we are treating, right? So I'd like to again thank all the centers and Department of Biotechnology. But I'll just want to add a few more thoughts before I close, is that we have to, in addition to hardcore science, we have to include socioeconomic determinants as factors in these cohorts, because they are perhaps even more important than the biology that we often think of as being sacrosanct. So we need to include, in addition to scientists, we need to include social scientists, we need to include statisticians in the cohort design and so on. We need to think of implementation science right from the beginning and throughout the course, and that needs to be done very, very intentionally. We have had some conversation already about data linkages, and data linkages sadly are not available in India because we don't have good healthcare databases, and that could be to some extent remedied by development of registries. For example, in dialysis, there are dialysis registries that need to be developed, and we need stronger cause of death ascertainment that will help with linkages. So I'm going to really stop here. I think I may have exceeded my time, so thank you very much.
Thank you, Dr. Jha. We are not taking any question because the minister has to come at 1:05 and there are 2 more lectures. Maybe time between the last lecture and ministers coming, we will have the discussion.
Thank you.
Dr. Gobind Makharia is the next speaker. My pleasure to kind of invite him to be here. We have shared the same floor in AIMS Hospital, 3rd floor for decades. Dr. Gobind Makharia, please.
Thank you, Chairpersons. Good afternoon, everyone. Thank you, Dr. Santanu, Dr. Souvik, and the whole team at IGIB and CSIR for this wonderful initiative. So, after talking about kidney disease, talking about some new disease which we call celiac disease.
Hello.
So I'll take you through one of the new disease which is called celiac disease, and many of you may not heard about this disease and why it's important that way. As you know, celiac disease occurs because of two points. One, that it happens to some people who have a genetic predisposition, and if they take gluten is a protein which is present in wheat, and that leads to celiac disease. And because of immune activation, both innate and adaptive, that leads to damage to intestine and multiple other organs. That leads to chronic diarrhea, anemia, short stature, and many other manifestations. So I'd like to tell you a small story first, that before this 1900, this disease was not known, and all the children who have this disease were treated by various kind of diet, giving a lot of bananas or giving a lot of fat-free diet. And nobody knew that why this disease happens. So one fine morning, one of the patient's mother told William Carl Dickey, he was a pediatrician, that my child is good if I don't give him wheat or bread. And from that narration of her mother, this doctor worked for the next 10 years. And just using 5 patients, 10 years, and he really convinced himself that indeed wheat is the cause of celiac disease. Right? And this is a wonderful story to share. that a simple observation by a very astute clinician could lead to a discovery of that kind. And this point of time, we knew how to treat this disease, but we never knew how to diagnose this disease. Therefore, this disease remained unknown for decades together. And only once we have blood tests became available in 1980s, this disease became much more prominent and much more common. So looking at how common this disease globally about 1 in 70% have this disease. And in our world, there will be at least about 40 to 60 million people in the world. It was thought that this disease doesn't happen in India, and some patients, only some are diagnosed in Chandigarh, Delhi, and Lucknow. But all over the country, there's no known about this disease. And people also believe this disease happens in children, but not in adults. So this disease remains unknown, but we developed interest in disease, and we found that in North India, is 1% of population have celiac disease, 1%, 1 in 100. That led to people believe that North Indian take wheat, so therefore celiac disease, South Indian don't take wheat, so why celiac disease there? So that led to one other study that called Pan-India study, where we looked at 23,000 people in 3 regions, North, South, and Northeast, and we found that 0.6% of people Pan-India have celiac disease. More common in North, but less common in South. That is the question that our diet is changing. Even in South India, people eat wheat, right? And will they develop celiac disease? The thought came, why don't we study those people who are South Indians, but they have moved to North India, and look at the second generation. And what we call migrant study, and what we found that the risk of celiac disease is almost similar to North Indians in South Indians who are residing in North India with change of diet. You simply send a message that if your diet changes, you are predisposed to a particular disease which is diet-induced. So therefore, in our country, we should have at least 40 to 60 lakh patients with celiac disease, and of that, only 10% or less than 10% are diagnosed. 90% still remain undiagnosed because of lack of awareness in the population, or even doctors, that we still think celiac is uncommon in our country. That led to interest and opening of a clinic in our institution at AIMS, that's called Celiac Clinic, where we see about 90 patients per year, new patients, and we have our goal was to optimize protocols because it's a new disease in the country, and we have to have protocols. We have to have a protocol for care to give to these patients. So therefore, we started thinking that why don't we create a cohort and make a multi-center? Because if you one center, you have about 90 patients per year, so your cohort cannot be large. So make it multi-center, and therefore we approached Department of Biotechnology, and they graciously agreed to create a cohort of celiac disease, along with multiple other biology questions, and we created a DBT-supported celiac disease cohort with multiple biological questions, but main intent was having established a cohort and biobank of these patients. So this ran through two funding we got for 5 years. Now second 5 years is going on with multiple other questions which are relevant to finding disease, diagnosis, pathophysiology, and all other clinical questions. The objective of this cohort is simply that if you have a patient with celiac disease, optimize what is the clinical outcome in these patients, and can you have new biomarkers to make a diagnosis which is non-invasive. Because how we diagnose celiac disease, if you think of celiac disease, you do a blood test called anti-TTG antibody, a simple blood test done by ELISA, and then if test is positive, do endoscopy and take biopsies, and so there's an enteropathy, there's damage to intestine. This is how we diagnose. But doing endoscopy is not easy in a country like ours, where there are only 4,000 gastroenterologists, but this test has to be available in our primary and secondary care. And for that intent, we thought we should develop a biomarker which could tell us. So in this cohort, we have multiple centers, both north, south, and northeast. But southern centers could not give us much samples because of still celiac is uncommon. And from northeast also, we didn't get much participation. But again, all our 3 North Indian cohorts are doing very well. So idea was that as standard to establish a cohort, all like steering committee, governance structure as defined by regulatory bodies. The framework was to have a clinical details, all demographics, symptoms, dietary habits, and comorbidities, blood workup, diagnostic tests, and histology, which is very, very important, and also digital records. This is what the protocol we follow. I won't go depth of it, but this is a standard protocol for care of patients with celiac disease. But most important, in celiac disease, the treatment is only dietary. There's no drug available. And therefore, nutrition is dietitian is a center part of it. And we are, being appreciated that we have a dietitian in our cohorts. And all these patients follow-up, standard, like both clinical, biochemistry, dietary compliance, and all these issues are being like. At the time of inception, at the time of inclusion in the cohort, we take blood samples, and in both plasma and serum and whole blood. So you take total biopsies, multiple pieces for proteome analysis, for microbiome, for histology, stool samples for microbiome, and also for urine for looking for other biomarkers. So all are being taken at multiple times, not one time, but every 6 months they are being stored in the longitudinal manner. So till now we have 1,100 patients, but most celiac disease 600, and on their follow-ups. We also include first-degree relatives because risk of celiac, if I have a celiac, the risk of celiac in my family is much higher compared to, we also include first-degree relatives and also controls. So now I'll give you a glimpse of outcomes, and the most important part, we believed that if you're making a cohort, keep learning from it. I'll give some outcome data, and outcome in terms of clinical questions, clinical protocols, which we true for our country, biomarker discovery, understanding pathophysiology, and patient care protocols. So first thing that since awareness is not there in the community about this disease, the diagnosis is delayed. Once diagnosis is delayed, what will happen? The patient will have more symptoms. They will persist. They remain short in height. And we found that yes, indeed, if you delay diagnosis, there are a lot of implications. Disease is more severe, and therefore difficult to treat and lead to more disease outcomes. Second, as I said, that doing biopsy is a difficult thing to do. So there are data emerged in Europe that if your TTG level is very high, with a blood test is very high, then you can predict that this patient has enteropathy. So you can do diagnosis without doing a biopsy. And again, we confirmed in our own studies that if your TTG is more than tenfold, then you don't need to do a biopsy. And this study was done by Aditya. Also, looking at celiac disease and liver disease, because celiac disease also have a liver disease involvement. And this study which Ankit did and showed that at least 1 of 100 liver disease patients have celiac disease. And same if you have cirrhosis, then 5 will have celiac disease. Celiac affects, if it is a female patient with celiac disease, her reproductive function gets affected. And we've observed that infertility, in our country, 5 women will have infertility of 100 people. If 100 women, 5 will have infertility. But in celiac disease is double. 10 will have infertility. And this is, again, important to diagnose early, treat early. And we've seen that if you treat celiac disease, some women, I would say anecdotes, they conceive on gluten-free diet. So also, since in our country, the availability of gluten-free diet is not frequently available, and therefore there is non-compliance. Patient can't take gluten-free diet. It's not available. And therefore, in our country, almost half of those patients remain unresponsive. They don't have a good clinical response. So again, looking at that, we made a protocol that how do we approach these patients. And most important of non-responsive is a lack of compliance, lack of adherence to diet. So we made a protocol, and this protocol now used everywhere in the world. So now coming to second part, that improving detection of celiac disease. And again, using this cohort, we had a question that if I have a patient with celiac disease, I can't do endoscopy for whatever reason, it's not available for whatever reason, can I do some blood marker? Because we know enterocyte, which are the cell of small intestine, they have very specialized properties. There could be some proteins which can tell us about damage to intestine, as like ALT. ALT like tells you liver disease. Same like, do we have any protein marker which can tell us about enteropathy? And then we met Santanu Sen Gupta, and then we worked together on this question to find a non-invasive new biomarker for detection of enteropathy. And this study is going on, it's in second phase, and interestingly we found 8 potential proteins which could have which can have an implication to tell us that if they are low or high, mostly low, then they could tell us there's enteropathy. And this study is under validation. So again comes, once you take biopsy of intestine, we need to have pathologists to read it. And we don't have many GI pathologists in our country, very few. There may be less than 100 pathologists who have interest in gastrointestinal pathology. And therefore, they need to develop a AI tool. And it's simple, that if you take biopsy, orient it, and make it. So now we have developed this tool. This is now app is being now validated. So a digital app where any pathologist can use this app and read the slides and give us a report. This is under validation, still not available. Coming to the third outcome was to understand pathophysiology of this disease. As there's no animal model for celiac disease at this point of time, therefore we thought we'd develop enteroids and do pathological studies. I won't go depth of it, but this is one of the pictures showing developing organoids, and then we can do many studies based upon that. Similarly, one of the very interesting things comes that why we don't digest gluten by celiac disease patients, because there may be gut bacteria some bacteria may have property to digest gluten degrading bacteria. So if that we find that if there is a gluten degrading bacteria, that could be a potential solution to treatment. So based on that, we are doing microbiome studies, and with National Center of Cell Sciences in Pune. I won't go in details of that because of lack of time. And last, most important, again, comes to how to deliver care to these patients. And in that care, till now, globally, if you start a treatment, you need to know when do a patient has to get better, right? And everyone has definition, but celiac there's no definition, right? And therefore, we don't say how is the activity of celiac disease and when is the response and when is the remission. We don't have knowledge of it. So we thought we'd develop a protocol and a definition for these that, and we look at 3 responses. The clinical response, did the patient got better? If the blood test got better, and did the histology improve? So 3 points. So, but how much decrease should lead to one called remission or response? So based upon that, we are developing trying to define the activity of celiac disease, response and remission. And this study is done by Suesa. And lastly, how to develop care. I said that we require dietitian in our country who can, because celiac disease, unlike diabetes, you decrease sugar, you decrease fat. But celiac disease, gluten-free diet is absolutely no to gluten. And gluten wheat is there in everything what we eat. You take anything, like you take chips, Uncle chips, they will have gluten in it. So patient will not know that what should I eat, what should I not eat, and who will guide them? I don't have knowledge, although I work in celiac disease, but I can't guide diet to a patient. There has to be a dietitian. And in our country, we don't have dietitian with interest in celiac disease. And therefore, we thought we develop a celiac app, which provides all information about celiac disease. Patient can monitor their own charts, own activities, and they can monitor themselves, even in a small town of our country. With that, there are some challenges, as Dr. Jha already discussed about it. That first challenge that we keep accumulating. So all biobanks around the world, they keep accumulating samples, and they remain in the stores. They are hardly used, or only partly used. So that's one big challenge, and one must be aware that if you collect, you must use it. It shouldn't be your balance. It should be more use. And second, as he also said, Dr. Jha also said, that there's new continuity. How do we continue these cohorts when funding expires? And how do we do that? And lastly, infrastructural issues are again major challenge. With that, I'd like to thank my celiac team, which is my joy, and love to work with them, and also all the collaborators, colleagues, and friends. I'd like to say my gratitude to all of them. Thank you for your attention.
Dr. Govind for that excellent presentation. I think we have time to take questions both for Dr. Jha and Dr. Govind. Apparently the minister is slightly delayed, so we can take questions for both of them. Okay. Otherwise, the better option would be to, I think, have the next speaker also speak. Sure. Then we can take up questions for all three of them. The next speaker is Dr. Ullas, and he'll be speaking on empowering public health through cutting-edge cohort studies, Arumda co-impact on society and science.
Hear me? Thanks Shantanu, Savik, and Ramanuj for organizing this fantastic meeting, timely and important. And also it's a pleasure to be here meeting some good friends. Can you hear me? Hello? Is it better? Hello? Okay. Again, thanks Shantanu, Savik for organizing this wonderful meeting, and this is very timely and important for the country, and I think many people have emphasized on the need to come together and build a larger consortia and efforts to address some of these outstanding unmet needs for the country. So I will quickly take you through some of the slides. Slide changer hai kya? Just 1 second, I think they're working out things. Okay, so I'm going to talk to you about the importance of having combined efforts to bring together people on the same platform, and describe to you some of our efforts that we have built recently, and then I hope you'll all see the merit in collaborating together. Okay, so ultimately what we would like to do is empower public health, and I think that's what has been emphasized by multiple speakers in the previous talks. Okay, so I officially belong to TIFR, the system. I'm also the director of CDFD, so this is just as a disclaimer. Let's think about what aging is all about in metabolic diseases. Ultimately, for a clinician, what matters is a set of symptoms that you have. Let's say, for example, if you're talking about type 2 diabetes or cardiovascular risk or obesity, you have certain outputs in the form of clinical symptoms. Now, the problem is, all of these symptoms have arisen because of certain predispositions that exist in the populations, or either as individuals or as populations. Now, we don't understand much about what this predisposition is, and then exactly what causes the onset, progression, and also diversity or differences in the pathological outputs. Now, no matter whether you're a biologist or a clinician, thanks to overwhelming data that has come up in the literature, all of us will seem to agree that it's an interplay between genetics and lifestyle. And the moment you think about genetics and lifestyle, obviously factors like epigenetics, epigenomics, and mitochondria, of course metabolism, become extremely relevant. 1 second, ye chala gaya. Nahi aa raha hai. हाँ नहीं आ रहा है. कुछ तो किया है. आ गया. Okay, so looks like there's some technical issue. Hopefully it will get better. Okay, so the point is, do we really understand the cause of the onset, progression, and the extent of disease burden is an important question. So I don't want to go into the details, but there are much more fine-tuned questions that one can ask. Now, if you think about predisposition, like I said, it's an unknown problem. And during our life course, there is a lot of metabolic onslaught and lifestyle changes that occur. And all of these ultimately lead to the disease or accelerated aging phenotype. Now, the problem is that they are not unifactorial origins, and there is an immediate and urgent need to understand the combinations or combinatorial outputs that ultimately lead to a disease outcome. Now, what becomes even worse is because of our civilizational changes and lifestyle changes, we have a huge change, diversity in terms of diets, like or also what we saw in the last talk, but also in terms of circadian rhythm, because we seem to be eating right kind of food at the wrong time or wrong kind of food at the right time. So there is a huge diversity that is created, and all of these leads to a biological challenge in terms of addressing some of these health problems. So what is critically required is discovering mechanisms that link diet or metabolism to physiological fitness and ultimately disease. Now, in this context, I would like to introduce the platform that we have built, or this is one of the first research centers in the country which is dedicated to metabolic disease and aging, called Arumda, and this is largely based at TIFR system. See, the overview and mission is that all of us have already heard talks about all diseases run into old age, and it's an important thing to address. And this is also linked to things like onconutrition, cancer cachexia, and even TB-related cachexia, which is also becoming relevant. So we have to bring together multiple people and stakeholders and multiple expertise to address this in one concerted manner. So this is, Arumda is missioned as a center to empower researchers, technologies, policymakers, and community health partners to tailor interventions. In fact, we are one of the largest platforms to bring together basic biologists and clinical clinicians together. We have a physical center at TIFR, we have a virtual network and a national facility. Now, we started very recently, as Shantanu said, probably all of us had thought about this at some point in time. We started in 2019 and we have made significant progress. I'm going to take you through some of the key platforms that are available and questions that we are addressing. So this is a truly open platform. We have researchers from multiple institutions who come together. In fact, we have a large set of basic biologists, which are called preclinical people from multiple institutions, people in the clinical domain, and of course, we have several nutritionists and dietitians who are working with us. We work with about 20 institutions in the country right now, and again, this was emphasized over and over again to bring people together and to allow them to think about problems that have to be solved in concert with each other. And we have the largest group of basic biologists, clinicians, community health partners, and public health experts. Now, what is one of the most important challenges that needs to be addressed? As much as we want to solve aging, all of us forget about what aging is caused by, right? And that's the most important thing. So one of the things that is typically devastating for the countries in the low and middle income settings is what is called double burden of malnutrition. It can be described in multiple ways. I'm not going to detail to you, but essentially it means individuals who have micronutrient and macronutrient imbalances and also are obese, or people, children who are born with malnutrition and also have high risk of developing obesity and diabetes. At a population level, it also means that people who are either stunted and wasted and are obese. That means it's the same population, individuals who have both overnutrition and undernutrition together. So how do you solve this becomes an extremely difficult question. Also, there is something called triple burden of malnutrition, which is called deficiencies of nutrition and diets, or hidden hunger, which means you are not able to absorb nutrients even though your nutrients are available in the diet. So that means there is a biological availability problem that is staring at us. Now, why is this important for the country? Right now, the median age of Indian population is around 20 years of age. By the time India becomes 2047, which is the Viksit Bharat, all of this population will lead to go to a median age of 50, which is when your age-related diseases set on. And if about a third of your population is malnourished, it will increase the risk of developing diseases later. Now, unfortunately, India has a very high risk of malnutrition. This is not undernutrition. It is both overnutrition and undernutrition or imbalanced nutrition. And despite multiple efforts, we have not been able to solve this. One of the major reasons is because we have been excessively focusing on what is called body mass index or BMI. The more relevant measure is what is called body composition, which is lean mass to fat mass ratio. And this is something that has been largely ignored, and that's something that Arumda is doing exhaustively. Now, why is this important? There is a fantastic epidemiological parameter called DALY, which is disability adjusted life years, is the number of years you lose because of early mortality or because of the number of years you lose because of a morbidity. Let's say stroke-related complications or diabetes-related complications. And if you look at it, what is the major cause of accelerated aging? It is the childhood and maternal malnutrition, which causes the maximum risk for aging. We are not going to solve this simply becoming a rich country, because the moment civilizations improve in terms of socioeconomic factors, access to more processed diets increase, and in fact it increases the risk of all of these diseases that I'm listing and we are all worried about. Now, let's see how you want to solve this problem. Again, I'll go back to the most important question. By the time there is a clinical manifestation of either a disease or accelerated aging, you have no clue about all the biological causes that have happened before, and when does this actually set in, whether it was during earlier generation, during gestation, neonatal growth, or during adulthood. It's important to deconvolute this information and to give you the outcome. And there are concepts of biological memory, which is in the form of epigenetic memory, metabolic memory, inflammation memory, and multi-organ system that becomes extremely crucial to understand. Also, we have learned that whenever you talk about intervention at a clinical or a public health level, you'll always have responders and non-responders. Now, you need to understand why some people responded and why some people didn't respond to the same intervention, and address what are the most important biological underpinnings that lead to this. So, unless we do this at this scale, we will not be able to solve the problem, either for the individual or for the population. Now, what is worse is that in the population, there are combination deficiencies. For example, we either study exclusively iron deficiency or protein deficiency. Unfortunately, you have a combination of both iron and protein deficiency that is present in human populations. If you don't ask this question about how they interplay with each other, I don't think we will be able to make a significant impact going forward. So, Arumda does this, and we do a comprehensive approach. We do a lot of basic discovery in terms of both preclinical and clinical outcomes. We do a lot of human observational, cross-sectional, and interventional cohorts. We also build facilities, and I'm going to quickly go through that. So, what are our ongoing cohorts? Remember, we are talking about longitudinal cohorts. So that means you have to trace individuals from across life course, and in fact, Arumda cohorts are designed to do exactly that. We are doing all the way from adolescent girls, which is pre-pregnancy, which is in the F0, and we're continuing all the way till the next generation and looking at aging. So we are looking at generating normative baseline for what is healthy adults. We are generating normative baseline for childhood development. We are developing normative baseline for adolescent girls, which is very important. So just to give an example of how we are spread out, we are looking at multiple populations in the country. And in fact, the populations that we study actually spread from urban, peri-urban, rural, and tribal populations. Again, it's important to get the diversity of the populations, because India has the largest genetic, geographical, and dietary diversities. So what works for one population may not work for the other population. So, for example, to give an exemplar of how a longitudinal study should be done, we are working with this cohort called MADLED cohort, which has been done for the last 20 years almost. And we have looked at the trajectories of these children from the time they were born until now. Now they're about 15 to 18 years old. And we're looking at maternal parameters, neonatal parameters, mid-childhood and late childhood. And we have been able to make some very outstanding observations in terms of when that double burden of malnutrition set in. Unfortunately, in the country, we have not understood about when does double burden set in, and this is for the first time that we are able to generate such data. Not just that, we are actually able to also pinpoint what could be the potential contributor to this double burden of malnutrition. And unexpectedly, we actually found it's the maternal BMI that seems to dictate the outcome in terms of childhood obesity when the child is around 12 to 15 years of age, which is completely fascinating because nobody would have anticipated that maternal BMI could actually determine the late life onset of obesity in these children. Not only that, we are actually looking at a lot of biological markers, and we have come up with very unique signatures of biological markers, which also predicts about when does a child could become succumb to this double burden of malnutrition, and whether the child has an enhanced risk for developing stunting or wasting or becoming obese. So I'm just giving you this as an example of how stitching together several cross-sectional data and doing longitudinal data becomes extremely powerful. Now, the other thing that we are doing in terms of policy impact is, for the first time in the country, we are developing a normative baseline for childhood development. Again, there is no normative baseline for childhood development in the country. And in fact, we are doing this beyond anthropometry. And we are asking very fundamental question about concepts like metabolic maturation of growth, because that's extremely powerful. And several reports in the literature actually hint at this particular thing. Now, for this, we are doing about 8,000 kids across multiple populations, again, both urban, rural, and tribal. And this is going to be extremely powerful because the power is very high in terms of the sample size. And we are going to carefully look at both cross-sectional and longitudinal information. Now, our efforts have also led to the definition of a new type of diabetes called type 5 diabetes. In fact, this was led by CMC Vellore and Albert Einstein College of Medicine, along with the International Diabetic Federation and American Diabetes Association. So we have been part of this historic definition of a new type of diabetes called type 5 diabetes. And we are now carrying out seminal studies in understanding what causes type 5 diabetes. Now, type 5 diabetes is typically what is called lean diabetes, or it's not typical type 2 where you have high adiposity. These individuals are lean and in fact have very low fat mass in them. Now, we want to build capacity. Arumda is not something that we do only for our science. We want to build capacity for multiple people in this audience, but rest of the country. So we have built what is called a National Analytical Facility for Nutrition Research, and we have multiple mass spec systems, and we make it accessible to everybody, and we also use what are called stable isotope methods. For example, if you want to measure body composition, typically people use DEXA as a body composition measurement. But DEXA is not available in primary healthcare centers, and DEXA is exposure to X-ray, and DEXA is also expensive. How do you make sure that you give access to such measures? I think people are more busy talking to themselves than listening to the talk. Sorry. Thank you. So, so how do you make sure that public health efforts really leads to the most lowest income settings? So there is something called heavy water called D2O. You can use D2O to measure body composition. It is more powerful or as powerful as DEXA. In fact, we are now giving D2O to every public health person or community health partner to measure body composition in children and adults, and even in people who have CKD or liver diseases. Now, this is a facility that is now accessible to everybody. This was inaugurated by the DA secretary recently. So this, we will provide service to everybody and anybody in the country for doing some of these efforts. We also have built capacity where private technology partners are actually building capacity to develop new methods, not just new technologies in terms of machines, but new methods to detect novel metabolites that can be assessed. We are also building the country's first human metabolic chambers. Now, I don't know how many of you will relate to this. Nutrition and diet is not only about becoming obese or diabetic. It has got to do with how much energy expenditure we all have. There is what is called resting energy expenditure and activity associated energy expenditure. How do you measure these energy expenditures? One of the best gold standard methods is by doing what is called respiratory exchange ratio. And for this, we have set up the country's first human metabolic chambers in CMC Vellore. So it's been bringing together a TIFR system and a CMC Vellore system to establish capacity in the country. This has already been established, and we will be inaugurating this soon. Now, the other thing that also becomes relevant is there have been several cohorts that have happened in the country, several birth cohorts, several adult cohorts. Now, there is an urgent need to harmonize these studies. Otherwise, what happens is that each cohort follows its own inclusion and exclusion criteria, this actually fragments and fractures the input and the output that is important for policy or intervention. So unless we harmonize studies, we'll not be able to make a big impact in terms of understanding dietary and genetic diversities that are causing accelerated aging and metabolic diseases. So ARUMDA takes the burden of harmonizing a lot of studies. In fact, we do a lot of harmonizations. So we also build capacity through training. One of the most important things is we hold annual symposia, and I welcome all of you to do this. In fact, ARUMDA does in a very meaningful manner. People come together, they identify an unmet need, they champion the study. We only support either technologically or by providing additional sites. We create a network where everybody benefits from the network. None of us want to be part of the publications if we are not contributed to it. The second and most important thing is technology should not be limited and accessible to select few in the country. For example, using stable isotopes, we want to make sure that every community health partner, every clinician sitting in this room or elsewhere has the access to these technologies. So we train people on stable isotope methods and metabolomics. We hold international workshops, and in fact, this has been attended by people from even South Africa, South Asia, and even Europe, who come and train with us to use this in their clinical settings or community health settings. So we are using a lot of these for building capacity in the country. So the next workshop is going to happen in March, and I invite all of you to kindly take this as an opportunity to come and participate. So ultimately what we would like to do is capture, again I'm going to emphasize, genetic, dietary and geographical diversities that are present in India. We have little understanding of disease spectrums that are present. How do these actually interface with socioeconomic factors is something that very few studies have actually come to realize. The same physiological settings can have very different socioeconomic backdrops. Interventions will not work in all populations, not only because of biological causes, but also because of socioeconomic settings. So unless we understand all of this, we will not be able to make a significant impact. So with that, I'll stop. Please join this platform. This is an open platform. This is the first research center which is dedicated to this, and it's not an exclusive thing. Everybody is welcome to do this. We are sufficiently well funded by multiple organizations, from DA to ICMR to BMGF and Unilever and also Agilent. And thanks to them, we are able to do a large number of studies. In fact, we are right now running 12 to 15 cohorts across the country, rural, peri-urban, urban, and tribal. With that, I'll stop. Thank you.
Thank you, Professor Ullas Kolthar. It's a rare occasion to hear some researcher telling that we are well funded. All my life I heard we have no funding. But anyway, thank you, I have accepted you well funded. We have the fourth speaker squeezed in, and then we'll have question answer for everybody.
Sure.
Please wait.
Yeah.
Dr. Puneet Prasad, please come over.
लगे दिया उससे सर का दे दिया ना सर को वो लगाना ठीक है माइक लगा जा रहा हूँ सर
Dr. Puneet, please start. We have about 10 minutes of presentation. The chief guest has arrived in the airport, so we have to clear the stage at the earliest.
Hello. Hello, can you hear me? Yes, loud and clear. So, Yes, so what I'm going to do is probably rush through. We won't get time to discuss, but I'm here whole day. So what I'm going to do quickly is to discuss ILS research initiatives, which talks about the Odisha's tribal population, what research initiatives we have taken through. This was started by Dr. Parida, and now it is led by Dr. Debashish Das, director, and we have 10 faculties involved. And today I'll be focusing mostly on my work, Sunil's work, and touch upon what Shanti has been doing. So the tribal group is very interesting. In this, we have been listening to the large cohort. This is probably a kind of bit more focused, and actually shows you why we are interested, because of their differences in the lifestyle, which is quite different from what we live life, right? So Odisha is quite rich in tribal heritage with their not only cultural aspects but also in their livelihood and food habits and what you can see. But at the same time, the problem is that they suffer a lot from different kinds of malnutritions, anemic, different kinds of disorders and so on, and kind of getting a little bit neglected, which we are trying to understand through research initiatives. And you can see from 2015, 2023, and a very recent paper in Lancet from RMRC covering tribal population, almost 53 tribal groups, and over 30,000, which discusses a lot about the issues that Odisha's tribal population faces, and probably elsewhere in India. So the question is our science or research capable enough to intervene without changing their livelihood, their lifestyle, and give them a better life? So here, in this slide, you can see what we are discussing is about the genome-based approaches, the microbiome-based approaches, and their food habits, if we can extract something from there. And these are different aspects of our studies. You can see here, the highlighted area are the districts which we have covered. And we have over 1,200 samples from here, and most of the tribal groups are facing problem with stunting, wasting. You can see 47%, 31%, and this is still not resolved yet. This slide basically shows you how we go inside. As a scientist, we go inside, we try to interact with them, discuss with them, find out, but at the same time, we also try to help them with their local thing, like, giving them some medications, supplying them their blood results, coordinating with the Department of Health to tell them what kind of problems they might be facing. So there are two posters from Sunil's lab. Sudeshna will be talking about whole exome sequencing, and gut microbiome from my lab, Rashmita. Please do visit for more details and technical aspects, and I will be basically discussing, giving an overview. So here we have over 600 samples exome sequencing from different places. These are the people involved, and you can see here the linguistic family, the descriptions which is over here, and mostly it is Austroasiatic groups which is coming in this. Now when we look into the exomic variants, allelic variants, what you can see here, this population Juang is having the lowest one, however Gadaba is having the highest one. So we are also getting a lot of rare and common allelic variants over here. Now with the help of Dr. Analab, NIBMG, Sunil's group also tried to look into compiling the Genome Asia population, and what you can see that the orange color which is below over here is Central Asia, and Eastern Asian group is kind of clustering. And when you do the subclustering within and do a PCA, you start to see a much more distinct cluster between South Munda and North Munda, and you can see the Juang population which is coming very distinct above. So this is the admixture analysis, unsupervised admixture analysis, and what you can see here, the Juang, which is kind of lemon green, is kind of more inbred population, and this is what we see in their genome as well. And you can see the inbred ratio, the coefficient that you are getting, Juang is very high in that. When we look into more of the identifying variants which having some clinical aspects or pathological aspects, you can start to see that over 10% of the rare variants are there in OD tribe or Odisha tribe, and over 7.7% are having very uncommon variants. So a couple of examples which I'll give you. We found beta thalassemia and delta thalassemia mutations, and you can see compared to Genome Asia group, it is in Odisha's tribal population, it is quite high. And when you compare the blood biochemistry, you can see that MCHS is low, while red blood cell distribution lengthwise and all is very high, where you have heterogeneity, the orange bars. Next, another example is giving the biotinase, which the enzyme or the mutation, which is unable to extract the biotin from the proteins, and you can see that these mutations are also present in there, which may be leading. So it's not about only giving them the food or better food will help them.
Excuse me, can you finish in 2 minutes?
2 minutes, okay. So basically, I will not have time to discuss more about the microbiome, but what I will quickly go through is just a couple of slides that we have done this gut microbiome studies, and we have urban population as well as tribal population, and you can see that the urban population, which is located in Bhubaneswar, is forming a very different cluster compared to the tribal groups. And we are not only finding a very differential abundance, we are actually trying to relate it to their pathological aspects, where the opportunistic pathogens or like Faecalibacterium longum and so on, given opportunity, are related to IBDs. And many of these groups are having very high amount of them, overabundance, and they may be related to the. Since the tribal groups stay in very close proximity, they even sleep with their livestock, you can see that the green bars, the bacterial population, which is primarily found in livestock, are highly abundant in their gut. So there is a very close association. This is. I will quickly go into the aspect of hypertension, which you think is probably more of a fancy disease, but it is quite prevalent in Odisha's tribe, which is reported from 2015 all the way to 2025, the latest report in Lancet, that over 40% of people have this. And then we looked into the reviews. There's a lot of microbes that are associated, which we find also in.
Sorry, we'll have to interrupt.
I just say thank you.
We'll have to close the session here,
okay.
And we can take up the question maybe after the
right.
inaugural session.
So we thank all the speakers and our chairpersons for this session to conduct this session quite nicely. So our Honorable Minister, Dr. Jitendra Singh, is almost here, and he will first inaugurate the exhibition, and then he will be coming here. So maybe within fraction of minutes, like 5 minutes or something. I would request all the audience, so please come forward, because there are a lot of empty seats and it is not looking nice. So the people and the students, staffs of IMMT who are sitting behind, you are all requested to please come forward and fill these empty seats. Only the students and the people who are presenting the posters, so please be at the exhibition at the poster area. Others, please be seated here. I don't see anyone is moving. Could you please come forward and fill these empty seats? Students? अरे आ जाओ, आगे आ जाओ, क्या पीछे बैठ के क्या मिलेगा? आ जाओ जल्दी से, खाना अभी नहीं मिलेगा, जल्दी आ जाओ. You have to wait, okay? आ जाओ जल्दी, आगे बैठ जाओ. All the students are requested, please come forward. मुझे दिख रहे हैं बहुत सारे students पीछे बैठे हो. I can see from your faces. So any staff of IMMT, could you please take initiative to ask the students, because they are not coming? Any of my colleagues? Live में अच्छा नहीं दिखेगा. When it will be live, we could see all the empty seats. So please come forward.
नमस्कार, हमारे आज के सम्मानीय अतिथि हम लोग के समक्ष होंगे. मैं अनुरोध करता हूं कि जो स्टूडेंट और जो भी कोई पिछली पंक्तियों में बैठे हैं वो कृपया अग्रिम सीटों को ग्रहण करें। यथाशीघ्र हम लोग इस कार्यक्रम को बढ़ाएंगे। आपका सहयोग के लिए हम लोग हमेशा आभारी रहेंगे। धन्यवाद। Please occupy the front seat if possible. Kindly cooperate with us. It's our sincere request to all of you. All the students, please occupy whatever the front row seats are vacant. It will not look nice. Our minister sir is probably approaching Nico Park Chak. So you may be understanding how close he is. So kindly fill the front seat and also call your other friends and colleagues to be here at the auditorium. Thank you.
Okay. Namaste and good afternoon, everyone. I request you to kindly be seated. And also I request you to please keep your mobile phones in silent mode till the program is going on. Thank you.
उनको अनाउंस नहीं करना चाहिए क्योंकि कुछ डायरेक्टर्स तो ऊपर आ ही जाएंगे। ज़्यादा
स्लाइटली फ्लाइट डिले ये क्लियर बोल दीजिए। हम बीच में
जब आएगी भीड़ आएगी एक साथ। लेकिन कैसे बताएंगे हम कि आप पीछे जाओ?
नहीं इसलिए थोड़ा सा आगे बढ़े, ज़्यादा आगे बैठाने की जरूरत नहीं, उनको बोलने बिल्कुल फ्रंट में आने की जरूरत नहीं।
लोग कर करके करती है। बाहर आ गए हैं शायद।
बोलिए प्लीज सेटल।
फोटो नहीं आ रही क्या?
All of you may please settle down. हाँ after the address confirm.
बट उनको बताया नहीं, मैं बता देता हूँ।
हाँ please बता दीजिए। We are apologizing for the delay. Actually, there was a flight delay of Honorable Minister, and that is why it is taking a little more time. But he is already approaching the institute, so we request you to kindly be patient. Thank you. The Honorable Minister has already arrived in the campus and is visiting the poster session. So he'll be arriving into this hall within a minute or so. Thank you. Oh, तो ये Namaste and good afternoon, everyone. Our Honorable Minister has arrived, and I request our respected Director CSIR-IMMT, Dr. Ramanuj Narayan, Director CSIR-IGIB, Dr. Shavik Methi, Director CSIR-CCMB and Healthcare Theme Director, Dr. Vinay Nandikuri, and Director BRIC ILS, Dr. Debashish Das, to kindly accompany the Honorable Minister to the dais, please. Thank you, sirs. We are immensely privileged that our Honorable Union Minister of State, Science and Technology and Earth Sciences and Vice President of CSIR, Dr. Jitendra Singh Ji, is with us to grace this national conclave on longitudinal cohort studies, Cohort Connect. On behalf of the entire CSIR family, I would like to extend a warm welcome to our Honorable Minister, all the dignitaries present on and off the dais, esteemed directors from our CSIR sister labs, all invited guests, delegates, colleagues, students, press and media, and each and everyone who is gathered here today. I request our respected Director, CSIR-IMMT, Dr. Ramanuj Narayan, to offer our floral greetings to the Honorable Minister, please. Thank you, sir. Let us commence our program by invoking the blessings of the divine. I request our respected dignitaries to kindly light the auspicious lamp. This is a symbolic moment that signifies the dispelling of darkness and kindling the flame of enlightenment. Thank you, sirs. May I now request our Director, CSIR-IMMT, Dr. Ramanuj Narayan, to deliver the welcome address.
Jai Jagannath and very good afternoon to you all. मंच पर आसीन देश के विज्ञान और प्रौद्योगिकी को दिशा निर्देश देने वाले और विकसित भारत की ओर अग्रसरता के नेतृत्व प्रदान करने वाले एक प्रख्यात मधुमेह चिकित्सक वो आचार्य CSIR के उपाध्यक्ष वो भारत के विज्ञान प्रौद्योगिकी और पृथ्वी विज्ञान मंत्री परम आदरणीय डॉक्टर जितेंद्र सिंह जी, कोहोर्ट कनेक्ट को नेतृत्व प्रदान करने वाले हमारे CSIR-IGIB के निदेशक डॉक्टर सौविक महती, CSIR हेल्थ केयर को नेतृत्व प्रदान करने वाले हमारे CSIR-CCMB के निदेशक डॉक्टर विनय नंदकुरी जी, हमारे साथ इस आयोजन में भाग लेते हुए BRIC ILS के निदेशक डॉक्टर देवाशीष दास, हमारे सामने बैठे देश के दिल्ली, पुणे, चेन्नई और चंडीगढ़ से आए प्रख्यात चिकित्सकगण, कलकत्ता से आए हुए निदेशकगण, CSIR के सभी निदेशकगण और कोहोर्ट के पूरी टीम जो भारत की यहाँ पर मौजूद है और CSIR-IMMT के परिवार के सदस्यगण, सभी ऑर्गेनाइजिंग कमेटी के मेंबर्सगण, प्रेस, मीडिया, आप सभी का हार्दिक स्वागत और वंदन। परमादरणीय मंत्री जी, आज आपकी गरिमामय उपस्थिति से हम सभी आह्लादित और अपने को गौरवान्वित महसूस कर रहे हैं। कैसा संयोग है, भगवान से जब आप इंतजार का फल मीठा होता है और ये इस वर्ष में दूसरी बार हमारे माननीय मंत्री जी हमें आशीर्वाद देने खुद यहाँ पर आए हैं। ये कैसा CSIR IGIB का नेतृत्व हो और CSIR-IMMT का साथ हो और उसके साथ बायरैक ILS का साथ हो तो हम कुछ भी कर सकते हैं, पत्थर में भी फूल खिला सकते हैं। और उसके लिए देश के विभिन्न भागों से हमारे परम आदरणीय चिकित्सक लोग जो कि देश के हेल्थ को प्रदान कर रहे हैं। मानवर आपके ही दिशा निर्देश और आपके ही सजेशन से हमने इस कार्यक्रम का आयोजन, जो खुद एक प्रख्यात मधुमेह चिकित्सक हों, इंडोक्राइनोलॉजी के प्रोफेसर हों, और ये आज हमारा पूर्वाहन है कि कल विश्व मधुमेह दिवस मनाया जा रहा है, तो उसके पूर्वाहन पर आपके जो महत्ता सर, मैं आपको संस्थान की तरफ से, पूरे ऑर्गेनाइजिंग टीम की तरफ से, CSIR की तरफ से हार्दिक अभिनंदन करता हूँ। महोदय, ये हमारा संयुक्त प्रयास है CSIR के 37 लेबोरेटरी 10,000 सैंपल के साथ कि किस तरह से हम पर्सनलाइज मेडिसिन और डिजिटल इंडिया की और डिजिटल हेल्थ की ओर अग्रसर हों। और ये हमारा हौसला है, आपका नेतृत्व है और आपका दिशा निर्देश है कि उड़ान तो भरनी है, चाहे 1000 बार गिरना पड़े, सपने तो पूरे करने हैं, चाहे दिन रात एक करना पड़े। माननीय मंत्री जी, आपकी उपस्थिति से आज फिजाएं विज्ञानमय है, हमारे संस्थान के गुलशन में रंगत है। आज हमारे बीच माननीय मंत्री जी की शिरकत है। दिल की गहराइयों से आपका स्वागत है। आपकी प्रेरणा से यहाँ पर हर चेहरा गुलजार है, खुशबू बनकर महकती रहे आपकी शख्सियत जहाँ में। आप हमारी प्रेरणा का कारण हैं। इस विज्ञान में समा में सर आँखों पर बिठाते हैं हम, आपका हर आदेश, आपकी इनायत से बढ़ता है हमारा ज्ञान। और मैं विशेष रूप से देश के विभिन्न भाग से जितने हमारे चिकित्सक आए हैं उनका हार्दिक स्वागत करता हूं। और आप जो कोहोर्ट के जो कोऑर्डिनेटिंग टीम है पूरे CSIR की, पूरे भारत की, और मंत्री जी की ही प्रेरणा थी कि कोलैबोरेशन होना चाहिए, कनेक्शन होना चाहिए। और आज ये जो कोहोर्ट कनेक्ट प्रोग्राम में आज डॉक्टर्स और वैज्ञानिक का मिलन है। और जो हमारे प्रधानमंत्री जी, हमारे मंत्री जी और CSIR के नेतृत्व देखता है कि भारत विकसित हो, इसी तरह के कोलैबोरेशन हो। आप सभी का मैं हार्दिक स्वागत करता हूँ। CSIR के जो हमारे निदेशक लोग हैं उनका स्वागत करता हूँ, ISI का मैडम का स्वागत करता हूं। आप सभी का हार्दिक स्वागत, वंदन, अभिनंदन। जय हिंद, वंदे उत्कल जननी।
Thank you, sir. May I now request Dr. Souvik Mehti, Director CSIR-IGIB, to give an overview of this conclave, Cohort Connect 2025.
Good afternoon, everybody. Honorable Minister, Science and Technology and Earth Science, also Vice President of CSIR. As you know, Minister Ji has very short time. I will not take more time to deliver my thought. But just one point I want to mention, Mantri Ji, is that the objective of this today's conference is that to collect all the cohort clinicians as well as researchers into the same network and exchange our knowledge as well as expertise, so that our study become more strong. And as all we know that Prime Minister has a dream of Viksit Bharat 2047. So time has gone to work as silos. It is the time to come together and solve a problem. So this is the dream we are trying to fulfill. With this, I again thank to our Honorable Minister to give us time and share his thought how we can achieve Viksit Bharat 2047. Thank you very much.
Thank you, sir. And now I request Director CSIR CCMB and Healthcare Theme Director, Dr. Vinay Nandikuri, to give an introduction to Phenom India, CSIR Health Cohort Knowledge Base.
Thank you. Our first and foremost, our heartfelt thank you to our chief guest, Dr. Jitendra Singh Ji, our Honorable Minister of State, Vice President of CSIR. Sir, thank you for being here. And fellow directors, Souvik, Ramanuj, and Debashish, and all the dignitaries of the stage. Thank you for participating in this very important event for CSIR. We have started this around 2 years ago, but it was in works for a while. We are talking about actually collecting samples from 10,000 CSIR employees, and this involves, originally our vision was to look at all the health parameters and a part of it for microbiome. But later on the numbers were increased to 6,000 participants for a microbiome, and some of the findings, we have already done 2 rounds of it across India, multi-institutional. IGIB is leading the project, but CCMB is also a major part of it, and NCL, IMMT, all these people, all the 38 labs of CSIR are involved in putting making sure that these cohorts are actually successfully collected. All the samples have been collected for 2 rounds, 2 years. And there are some interesting obvious findings. Like I believe the parameters that we have in India are going to be distinct and different from what is already known for the rest of the world population. So this is something we do not have, and that knowledge is something that we will gain. And we also have a scenario where our microbiome pattern seems to be, which is not very unexpected, directly related to the kind of diet we have, is distinct from the Western population. So some of these findings which very unique, and I'm sure this is only the first of this kind of a study. I'm very, very sure that as we go forward under the leadership of our Honorable Vice President and of CSIR and Minister of Science and Technology, Dr. Jitendra Singh Ji, and Honorable Prime Minister Narendra Modi Ji, we may end up doing much wider and much bigger studies, not CSR alone, maybe multi-departmental study where we might do a lot more than 10,000 samples to get much better clarity on how various parts of India and their diet and influences their health. This is something, our dream, and this is only a starting point, and I do not want to take much time because we were very clearly told that the Minister has to leave a bit early. So thank you for coming here, and this symposium of 2 days is going to give us fantastic insights into our program as well as other healthcare cohort programs that are going on within India, and it's a fantastic occasion. So thank you for being here. Thank you for everybody.
Thank you, sir. Having got a glimpse of Phenom India, may I now request the Honorable Minister to release the souvenir on the journey of PI Check, Phenom India CSIR Health Cohort Knowledge Base, from vision to milestones, charting the journey of cohort.
More copies was enough. बैनर ऑफ करो थोड़ा हाँ अब ठीक है
Thank you, sirs. Kindly be seated. Keeping up with the vision of our Honorable Prime Minister and Honorable Minister of Science and Technology that R&D institutions should work in close collaboration with academia and industry stakeholders, we at CSIR-IMMT have been working closely with the steel and mines industry majors and line ministries. We are very happy to inform you that today we are signing 2 new MOUs to foster academia-industry R&D partnerships further in the gracious presence of our Honorable Minister. In this regard, may I now invite the team from MS Lloyds Metals and Energy Limited, Maharashtra, to the dais please for the exchange of MOU with CSIR-IMMT. Mr. Ramkumar and Mr. Ganesavar Nayak, Vice Presidents Lloyds Group, and Dr. Shivkumar Angadi and Dr. Swagat Rath, Senior Principal Scientists from CSIR-IMMT, welcome to the dais. This MOU is on the development of advanced technologies for the beneficiation of low-grade iron ores. Thank you. For the exchange of the second MOU, I invite Mr. Rajiv, Director, and Mr. Rushi Kumar Reddy, Manager, Fomento Goa, and the team from CSIR-IMMT, Dr. Shiv Kumar Angadi and Dr. Swagat Rath, to exchange the MOU on the development of processing technologies for the beneficiation and pelletization of low-grade iron ores. Let these MOUs bring forth some fruitful collaborations and contributions ahead. Thank you. Being a distinguished professor of diabetes and endocrinology of international repute, there could be no one more befitting than our Honorable Union Minister of State of Science and Technology and Earth Sciences and Vice President of CSIR, Dr. Jitendra Singh Ji, to inaugurate this conclave. Our respected Director, Dr. Ramanuj Narayan, has already highlighted his illustrious contributions and visionary leadership. On behalf of all of us, I take great pride and joy in inviting our Honorable Minister to address this august gathering. Welcome, sir.
Thank you very much for your kind introduction. We have amongst us our very dynamic director, Dr. Ramanuj Narayan, Dr. Maiti from IGIB, Dr. Kuti, and Dr. Devashish. At the outset, I have to compliment you for very thoughtfully organizing this event and also planning it, because I have been here at least twice in the last 6 months and we've been talking about it, and I'm glad that you've made a headway very fast. So compliments, and also because it gives me a personal gratification, because tomorrow happens to be the World Diabetes Day, and on the eve of the World Diabetes Day we are all here to actually talk about a subject which is going to occupy our attention and our research and our future endeavors in the prevention and cure of the metabolic disorders. And thanks also, Dr. Ramanuj, for your very poetic introduction. और जब ये कह रहे थे कि आपको देखकर सब चेहरों पर गुलजार है, तो सब हंस पड़े. But being a scientist, I can't deceive myself. जो सब हंसे, वो इनके शेर पर हंसे, हमारे चेहरे पर नहीं हंसे. So all of us are researchers. We have learned not to believe anything without evidence. So if you see the chronology order, the evidence of the laughter was the poetry, not the face that he was describing. But nevertheless, it is very flattering, and always, like always, Dr. Ramanujan has been always one of our very active colleagues. Now coming back to what we were saying, I think this CSIR-led Phenom India Conclave and the Cohort study that they have undertaken is actually meant to study 4 basic determinants, which are also very important determinants, namely the biological factors, the environmental factors, the genetic factors, and of course the lifestyle. And it is not easy to decode these factors in the context of the Indian population, given all its heterogeneity, diversity, both in the terms of lifestyle, the eating habits, even the environment, and even our genetic makeup is different. Like, for example, the disease that I deal with, for many years till at least about 1980s, type 2 diabetes mellitus was known to be a disorder of South India more than North India. And now, of course, there's a democratization of diseases because of the breakdown of all that divide. So it's all over. But I remember we did some case reports of 1 or 2 newly detected diabetes about 35 years back from Kashmir Valley, a bureaucrat who had never heard of diabetes. So he could not even, make out his symptoms. He just asked his attendant to replace his glass of water every time he felt thirsty, and he said that I need a lot of water, so don't wait for me to place an order. Just when you find the tumbler empty, just replace it. Before somebody told me that he should get himself. So much was the ignorance about this disorder. And so also the metabolic disorders in the whole, because they all come in a cluster, sometimes in a package. So therefore, it becomes a challenge, but at the same time also important. And more so is that today we are also confronted with a biphasic disease spectrum. Like, for example, in the first half of the 20th century or even up to 1960s or 70s, we were mostly confronted with communicable diseases. And that's the reason many of us, I'm told there are medical professionals also there. Those of my generation, when we were undergraduates, our seniors and our professors told us, if you read syphilis, you read medicine. Because then you get to study each. In the tertiary phase, it affects the skin. In the final phase, it affects the neurosyphilis, and cardiosyphilis, everything. So in the process, you read all the systems of the body. But by the time we got into post-graduation, all that was over, because most of the communicable diseases have been conquered with the new set of antimicrobials. And then the dictum became, if you read diabetes, you read medicine. Because you read neuropathies, you read nephropathies, you read all the vascular episodes happening as a result of the coagulation tendencies, etc., etc. So, but now it is both, particularly after the coming in of HIV and the surge of COVID. We have a whole spectrum of, and that's the reason also why even in CSIR and the Department of Biotechnology, we are beset with a very huge task, which is occupying most of our attention, of developing new vaccines even for disorders like dengue, malaria, tuberculosis, because we have actually not yet got over that. So we still have that, or we have revived that. At the same time, we have all these metabolic disorders. And ironically, as many of us who are dealing with this would bear me out, that there is also a certain amount of reciprocal relationship between the communicable and the non-communicable diseases, which is not often talked about, either in the scientific conferences or even by the policymakers. They treat the two sets of these diseases as a separate. So they have a separate program. I was actually even discussing this with the health ministry. They treat NCDs as a separate entity and the CDs as a separate entity without realizing that they have somewhere common granduncles and grandparents. Like, for example, tuberculosis and diabetes have a reciprocal relationship. If it's an uncontrolled glycemic level, it will predispose you to tuberculosis. And if you have tuberculosis, you are more prone to have all these diseases. So likewise in case, and similarly also we have something called the inflammatory hypothesis contributing to vascular disorders, maybe even the coronary artery disease, which is known for years. So I think this is a very complex issue, and the relevance of a study like this is that though we didn't have enough of evidence or validation, because we didn't have these facilities of doing these kind of investigations, but we have known this for almost half a century now, or at least 3 decades now, that Indian phenotype is certainly different by all means compared to others. And I think even about 3 decades back, we had studies reporting that those of the Indians who had settled in European countries for 3 generations, 4 generations, continue to have more predisposition to these metabolic disorders, even having grown up there in a different milieu, different environment, different lifestyle. But they couldn't have changed the genes of their grandfather or grandparents. So this we had known, but we could not validate. So now I'm glad that this initiative has been taken to actually establish these facts and also find the future course of action. And both CSIR and Biotechnology Department are now, I think, most actively engaged in the government sector. We have now, even in the DBT, we have set up a sequence. We started sequencing of human genes. We already sequenced about 10,000. individuals. We hope to have 1 million very soon. We also have the first ever trial on hemophilia successfully done by developing factor 8. And we conducted the clinical trial in CMC Vellore. So now the other point is that as we learn, go on in this journey, the management strategies also keep on evolving. Like for example, even when we talk of the communicable disease, there were times we didn't have antibiotics before 1950 or so, because first antibiotic came in 1947 or 48, the penicillin. So they would treat, they had that sanitoria concept. I think the biggest sanatorium in the world was the one at Chennai, the Tamaram Sanatorium. So you would place the patient there in isolation, and then gradually you had. So we kept on evolving as we had more and more tools at our armament. Similarly, in case of diabetes, till 1921, they just made the patient starve painfully, because that was the understanding. They thought the more he ate, the more he would be having blood glucose levels. So finally, many patients died because the insulin came only in 1921. And that is the day that we commemorate on November 14. And then you kept on giving injections. We had short-acting insulin. You had to give multiple injections. Gradually, then we came into intermediate, then long-term. Finally, the oral antidiabetics, and also now genetic cures, etc., etc. So, as the research and the new findings keep arriving, the strategies also keep evolving. So you can understand how difficult. Similarly, also in our diet habits. For example, in 70s, there was a huge buzz all over India to use refined oils. And it became a big market. So Sofola, sunflower, etc., etc. And somewhere, I think in late 90s, there was a study conducted by one of the Mumbai scholars comparing the intake of these refined oils with the prevalence of the coronary artery disease. And what he found was that the refined oil consumption had gone up from 4% to almost 44% in just about 10 years, because it picked up like anything. Everybody thought if he had refined oil, if she had refined oil, they would never have a heart attack. And simultaneously, the prevalence and the incidence of coronary artery disease had also gone up, and coupled with young myocardial infarction. So nothing happened to reduce it, rather increase. And then they learned, no, it's better to have coconut oil or mustard oil or even desi ghee. So why I'm saying so, at the risk of sounding unorthodox, is that these new drugs which have arrived for obesity, though validation comes from FDA in 5 years, but the clinical effects sometimes take decades to appear. So we have the new tools, and that also require a great amount of discretion. And therefore, I think the thrust now, given in the Indian context that we have 70% below the age of 40, the context would be on prevention. And that's why I said we are hugely into the vaccines, the digital health, and the government also is also facilitating with Ayushman, etc. And we have the AI now also facilitating our diagnostic and therapeutic procedures, but how best to use is again a code. And then we have the quantum-driven solutions also. So in a nutshell, a longitudinal cohort study like this is basically addressing the mantra that I have always been trying to speak about, the Indian treatment for Indian patients, Indian prevention strategy for Indian subjects, and Indian data for Indian solutions. And for that, I think a study like this is imperative. This will be providing us a huge amount of data for our future strategies as far as our prophylactic, preventive, or therapeutic initiatives are concerned. And then integrating it with the private sector to make it more viable, sustainable, and must compliment the directors over here for facilitating these MOUs and the venture capitalists. So in the end, I would only say that, Hippocrates always used to say that even when a doctor has no tool or no instrument or no medicine at his disposal, he can still be of some help to the society. Like, for example, if you're sitting in a railway compartment and somebody says that he's sneezing or having a headache, even if you don't have a tablet to offer, you can offer some advice in some way. If not, at least a placebo effect. So from that extent, I think when we talk of Viksit Bharat 2047, the health of India is going to be the basic parameter. So in a single sentence, you can say India's health at 2047 will be the key to Viksit Bharat. Thank you.
Sir, we are always indebted to you for sharing your words of knowledge and wisdom. Now is the time to express our sincere gratitude to our Honorable Minister for gracing us with his presence today. I request the Director of IICT Hyderabad, Dr. Reddy, to kindly come on to the dais to felicitate our Honorable Minister. Sir, your presence added immense value to this conclave. Thank you very much, sirs. Now I invite Dr. Debashish Das, Director, BRIC ILS Bhubaneswar, to propose the vote of thanks.
Good afternoon and Jai Jagannath. I feel truly honored to deliver this vote of thanks on behalf of the organizing committee. Sir, first of all, heartfelt thanks to our chief guest, Honorable Minister Dr. Jitendra Singh, who despite having such a busy schedule took out time to come to Bhubaneswar and give his wisdom to us for inaugurating the National Conclave of Longitudinal Cohort Studies, Cohort Connect. My heartfelt thanks to DG CSIR for silently supporting this activity. Also, I thank Dr. Ramanuj Narayan, Dr. Saubik Maiti, Dr. Vinay Nandikuri, all the current and future leaders in the scientific field, CSIR, DBT, the science enthusiasts of the country. A special gratitude to all the doctors who have come here, faculties, speakers, young scholars sitting in the audience. Thanks to whole organizing team, volunteers, the backstage crew, and last but not the least, all the sponsors who sponsored this event. And thank you very much for coming here.
Thank you. This brings us to the end of this inaugural function, and I request all of you to kindly rise for the national anthem. Please be seated till the VVIP movement is concluded. all of you may please join us for lunch. For ease of arrangements and time management, all the organizers may please join in the Amrapalli garden where the tea was served, and all the other IMMT family members please join on the left side of the auditorium. Thank you very much.
Look nice. Please come forward. So after lunch, people are sleepy. I will introduce, sir. So good afternoon. Welcome to the third session of the today's cohort conclave. This session is conducted by Dr. Devashish Das, who is Chief Scientist and Director of Institute of Life Sciences, Bhubaneswar. I welcome him to come to the dais and honor us having a technical session chair. I request the committee to give the flower bouquet. To introduce Dr. Devashish Das, who is Chief Scientist and Director of at the Institute of Life Sciences, leads pioneering work in computational biology, bioinformatics. His research focuses on developing innovative algorithms and tools for proteome informatics, exome, metagenome analysis, and understanding of molecular variations through lens of genomics. He has developed several notable tools such as GenoClusters, PLHost, ProGAN, MassWidth, GenoSuite, and Proteostat for application of the proteomics and genomics. His collaborative efforts aim to advance the understanding of genomics and understanding of genomics and proteomics. Thank you.
Thank you. So, coming to IMMT is like homecoming for me. I was at CSIR-IMMT for about 20 years, more than 20 years. Now, currently serving as Director of Institute of Life Sciences. So when I came there, I found there is a seminal work going on the tribes at ILS, which was started by my previous director. And Dr. Puneet had talked about it in the previous session. But we will continue this session right now with a talk and a couple of eminents in the panel discussion. My first speaker would be Dr. Soumen Kumar Pradhan. Dr. Soumen Kumar Pradhan is a public health researcher and a faculty member in the Department of Community Medicine, MKCG Medical College, Odisha. He is a Bernard Lawn Scholar in Cardiovascular Health at the Howard T.H. Chan School of Public Health. His research focuses on chronic disease epidemiology, multimorbidity, and implementation research with a special interest in integrating evidence-based interventions into public health programs. Currently, he is also a co-investigator in Ganjam rural birth cohort implemented. Ganjam is in the southern part of our state, in collaboration with MR, HRU, RMRC, Bhubaneswar. Dr. Soumen, you have about 10 minutes so that we will have time for interaction. Friends, it is, I know it is difficult to stay awake post lunch, but thank you. A round of applause for Dr. Soman, please.
Thank you so much to the respected chairman, sir, and for this session, and the organizers of Cohort Connect for giving me this opportunity to be part of this academic event. So, I'll be talking about cohort studies and target tier emulation from observation to causal inference. This is the title of my topic, but why I chose this topic? Because there are many eminent researchers sitting here, and this may not be a very new topic for some of them, but the issue is that currently, if we compare that with our Western counterparts, India is lacking in this study design, how to use cohort data as to emulate clinical trials. So that's why I choose this topic. Coming to the evidence gap, so we know that RCT is a gold standard. I mean, for any kind of intervention, we talk about RCT. But like sometimes, most of them, it is limited by feasibility, cost, and it has very narrow eligibility criteria. That's why what happens, as a clinician, when we see RCTs, most of the time, the real life patients that we see in our clinics, they are not part of the RCTs. Basically, so that's why we say that RCT may have very high internal validity, but the external validity or general eligibility is less as compared because the patient population that they focus on has very narrow eligibility criteria. So that's one issue. Second thing is, there are some research questions which we cannot answer by RCTs. Like suppose we want to study whether stopping a drug leads to high risk of stroke or stopping antihypertensive leads to high risk of stroke. So we cannot do this trial in the form of RCT, but that is another gap. So for these kind of research questions, there has to be some other method, and that is what this emulating target trials means basically. So why cohort study? The main good thing about cohort is it's the population that we include in our cohorts doesn't have that much very big narrow what do you say eligibility criteria. We include a cohort and follow them up to a period of time. So that's the good thing. But the point is, it has other gaps like it. We cannot answer causal questions like whether some intervention will work or not, because the study is not designed for that. And there are other biases like confounding bias, then selection bias. This kind of bias will also be there in cohort studies. So how can we bridge this gap between cohort data? I mean, we have lots. The cohort is a large population. Sometimes, most of the time, it is a very large population. We have the data, but why can't we use that for testing intervention or answering research question which pertains to interventional study design? So one thing is, when you talk about cohort, most of the time we talk about association, right? And association are different from causation, that we know. But how can we convert that association, a study which is designated for knowing the association, to a study which can give us causal inference? And that is what target trial is all about. And so it's a emulating target trial. The term target means here we aim to emulate a ideal clinical trial through a cohort data basically, or observational study data. So that is what emulating target trial. So here the target is always a ideal RCT which we are not able to do, but we wish to emulate it. So so basically this is just like an RCT which we are doing on a cohort data, and we go retrospectively, and then from there we move prospectively in the design basically. So this is a prospective study embedded in a retrospective data. And this concept is first designated by, started by two scientists from Harvard H1 School of Public Health, Hernan and Robbins. So after that, many cohort studies they have adopted this study design to answer many research questions which pertains to interventional domain basically. So as I told, target is basically to emulate a ideal clinical trial. So how are you going to use cohort? So here we see that the most important part of RCT is randomization. So in cohort we cannot do randomization because we had already have the cohort data. We have followed them up since long, and now we cannot do randomization. So basically the randomization has to be emulated through through design and analytical methods. That's what emulating target trial is all about. So here there are two things are very important. One is designing the target trial, emulating target trial, TTE that we talk about, and second is what analysis we are going to perform to emulate the randomization. So suppose this is example, if a person has high blood pressure and he does start medication early, does it reduce the chance of stroke? So here we cannot do a RCT because we cannot have two groups in which one group will start early and then another group will start late. Okay. So basically here what we do, we have a cohort data of patients of stroke or whatever, and then we go retrospectively and see who has started early and who has started late, and then follow them up prospectively from retrospective data and try to see where the stroke incidence is, stroke incidence is more. Okay. So what happens in target trial? Basically here we start medication immediately, then in another, ideally, which is not possible, in another group we delay the treatment for 6 months and then compare the stroke risk. But here what we do in cohort emulation, we use existing cohort patients with newly diagnosed hypertension and then identify who started treatment immediately and who delayed from the retrospective data. Make the groups comparable, like we talk about matching in case control study. Similarly, here also the comparison has to be between two groups as much as possible. We talk about age, BP, diabetes, smoking, like this kind of risk factors has to be comparable between those two groups. And then follow both the groups forward and see for stroke outcomes. So this is the difference between the three things, that RCT, cohort study and target trial. We know about RCT and cohort study. What is target trials? Basically, this is observational study, but modeled as an experimental design. Second thing, it mimics randomization analytically. So we don't do randomization directly. Here, the randomization is done in the statistical analysis basically, and it estimates causal effect under real world conditions. Because in RCT, this is very controlled setting where patients are randomized and blinding is there, everything is there. But in real life, it doesn't work like that. So here, so basically, what we're trying to do is in target trial is kind of emulating a pragmatic clinical trial. That's what you do here. Then, and the confounding control is also very important because in RCT, the confounding is controlled by itself, like during randomization, but here we don't have the randomization possible to randomization. So that's why here we do it by achieved by it through designing adjustment basically, through statistical modeling and the study design. Then coming to internal validity, external validity, both can high, but it always depends on assumptions. In target trials, again, TT, the target trial emulation kind of studies where assumptions are very important. How effectively we are addressing those assumptions is also very important. So coming to the last example, what we say, so in RCT we can answer, does drug A reduce BP versus placebo? That is one in for RCT. But in target trials, we can answer the questions of what is the causal effect of initiating drug A versus not initiating the BP reduction. So basically, we are giving a drug and not giving a drug retrospectively in a cohort data. That's what target trial is all about. So there are basically four steps where for TTE, the target trial emulation, and as I told, design the target trial. This is basically the designing the protocol. Any RCT, the protocol is very important. Like that here also, the protocol is very important. So the protocol will be exactly almost like an RCT in target trial emulation study. Then we implement the, the protocol through emulation of the cohort, and based on the cohort data, then statistical analysis and validation of the outcomes or results. Coming to the first one, designing the trial. Again, here the same 6 important points, elements are there, that is there in RCTs. Eligibility criteria, treatment assignment and initiation, treatment strategy, follow-up time and outcomes, causal contrast and analysis plan. These 6 are also there in any RCT protocol, which we can see. So eligibility criteria, where this is important because in eligibility criteria we decide which patients are eligible beforehand. The protocol you have to mention that these patients are eligible and these are not eligible. So in a way that we from that we decide that yes, this study, the findings are applicable to this group of people. Then treatment assignment and initiation. So so basically here we are not assigning treatment. Here we are observing the treatment, because assignment happens in RCT only. But here we are observing the assignment of treatment which has been already done in past, and then observing that and initiation. So here one most important thing is there are 2 groups. One will getting treatment A, one other will getting treatment B, or maybe the intervention A or intervention B. So that assignment is very important, and at that point of time basically the 2 groups are created, and in future those 2 groups will be comparable to each other. So I will come in next slide maybe how to make them comparable. Then treatment strategy, there has to be a specific treatment strategy, has to be clear. Follow-up time and outcomes, how much time it will be followed, then what are the outcomes, primary outcome, secondary outcome, has to be designated at the before beginning of the trial. Then causal contrast. So here we have to decide that what will be based on the primary outcome, what we want to intend to see basically at the end of the trial. We have to link that with the exposure or intervention and the outcome. An analysis plan. So what statistical analysis we are going to do on those data, that has to also be predefined, because that also because transparency and this kind of things are very important in any trial we do, right? The second is emulating the cohort. So here now we have the data and we have the protocol, now we have the data also with us, and based on that we have to implement the target trial. So there are 3 to 4 things that we need to look into this. Time zero alignment. So what happens, normally suppose we are doing a target trial emulation among the research question is whether introducing whether stopping a drug leads to high risk of kidney failure among diabetes patients. So suppose that is the question. So in that case, the time point or zero time will be the clinical decision time point, not the calendar time. So here basically what happens, the patient has, suppose a patient is diagnosed of this CKD, chronic kidney disease due to diabetes maybe. After 3 months we start a drug, we start the drug immediately, and there are 2 groups. In some group they stop the drug, in other group the patient continue to take the drug. So the point where the decision is taken to continue or stop the drug becomes time zero point. So that has to be clearly mentioned, and from there the follow-up begins. Then baseline balance using propensity score matching and inverse probability of treatment weighing. These are basically 2 methods, statistical methods, through which we make 2 groups comparable to each other. Giving equal weightage to both the group. The probability of a patient being assigned to a intervention and control group, each basically decided by the propensity score matching, and inverse probability of treatment weighing. Each basically what we do is we provide weightage to same these, any of that can be used. So provide weightage to a patient or individual based a group of individual based on their certain characteristic. Then clone sensor weight methods. Again, these are some methods which we use to continue and emulate the cohort. It will be very detailed, so I won't go detail into that. Then finally, handling the missing data through multiple imputation method. These are the statistical methods. Then coming to statistical analysis, these so basically once you have the design and then you have emulated the cohort data, and we need to analyze the data, whatever we have based. The analysis is almost same as the RCT analysis, but here we use common techniques like G methods. Subgroup analysis, sensitive analysis are same like what we do in RCT. And again in this G method is one kind of adjusting the cohort data into a RCT data. This is a kind of statistical technique that we use in the form of G method. Then validation, finally, once we have the results, we have to validate that. There are two kinds of validation, internal validation and external validation. So, for internal validation, we have cross validation methods in which we have the data, cohort data, we divide that into test data and training data and compare and use the same technique in both the set of data separately and see if the results are coming same or not. And in external validation, we search for another RCT which has already been done, answering similar kind of research question, and that design has to be used in our cohort data to see whether there are similar kind of results or not. So this is basically external validation that we do in RCT. So this is also known as benchmarking in target emulation. Common avoidable bias, this is one of the bias, 3 to 4 bias that we commonly see. Immortal time bias, period where outcome cannot occur is misclassified. Like suppose a patient, as I told in the previous example, that a patient who is seeing the effect of stopping a drug on complication or incidence of death among CKD patients who are under diabetes treatment. So in that case, the time point, zero time point will be the clinical decision making point, not the point where it was diagnosed of CKD. So if we, some researchers do the mistake of starting the time zero point at the point of diagnosis. No, the intervention time zero point will be at the point of decision where we are taking that whether the patient will have stopped taking medication or continuing medication. Similarly, depletion of susceptibles, like in some group there will be the proportion of frail individuals will be more, in some other group, and another group the frail individual will be less. So frailty is one of the, study done in elderly people that we do. So there also this kind of biases are arising, because when a group has in certain group the during the course of time the frailty proportion is higher as compared to other group, then the true effect of the intervention may change and create some bias. Selection bias and confounding bias are two common bias that is also has to be looked into. So coming to the confounding bias is very important, because in any cohort or any cohort study that we see, confounders are very important to address at the earliest and before we design the trial basically. And DAG, directed acyclic graphs, are most common method to see which are confounders and then which are colliders and mediators. So there are three kind of variables we can find in any DAG, and apart from exposure and outcome. So anyway, we know that any statistical analysis you have to adjust for confounders, and we have to keep in mind differentiate between confounders, colliders and mediators. We need not to adjust for colliders and mediators, but we have to adjust for confounders. So that has to be clear through DAG. So while designing a trial, first thing we need to do is a DAG, that acyclic graph, and the diagram has to show the exposure, outcome, and the mediators, confounders, and colliders. I have already told about benchmarking, so I won't go into that again. So coming to this TT design, basically this is not a, it's per se a experimental study. Basically, we are using the design and analytical methods to emulate a cohort data into a clinical trial, basically. And still unmeasured confounding variables will be there. So what happens is, to control this unmeasured confounding variables, the richer the cohort data is and the more number of variables we have, the more chance of we can adjust that confounding variables in future when we emulate the clinical trial. So those cohort data who have more data points, there is less chance of getting into this kind of confounding bias, because at least we have the data for those confounding variables. If you don't have the data and we have already finished the cohort, then it will be difficult for you to emulate the trial. Then again, data completeness accuracy is also an issue, because that will show the quality of the how much the external validity and general validity, all these things depends upon this quality and completeness of the data. India has a rich and diverse, we have many cohorts, we have already many cohorts, but still we are yet to implement this study design in a more effective manner. Like we don't see much target trial designs based on cohort in India when I was going through some previous studies. And if we use this, we have many experts who are, experienced researchers who are sitting here, so that this trial design can be used on their cohort data also. I'm new to this field because we have this, now I'm part of my first birth cohort that we are starting in Odisha, in Ganjam district, and the participant recruitment has just started. So we are into that part, and maybe in future we'll try to emulate that.
Dr. Somen, Dr. Somen, 2 minutes.
Yes. So again, the main challenge remains is data linkage and harmonization and missingness. So for linkages, this code connect is a good platform. Like we are talking to each other, then maybe a formal platform can be, if that can be designed, then it will help us to collect the data from various cohort and then do this kind of studies. In the future, integrating anyway the AI and machine learning into in the statistical part, basically addressing the confounding variables, addressing the biases. So that can be a good initiative, research area in future, which will help us to emulate clinical trial more effectively. Then developing federated cohort networks like this, we are sitting here, and multi-site target trial emulation can be implemented in future if collaboration happens between various cohorts and researchers. Then escalating translation and observation data into clinical action. So basically, we have, apart from the cohort data, we have many secondary data also, like electronic medical records, large data set of large population. That data can also be used to emulate the TT, the target trial emulation studies can also be done on that. So, and based on that, we can talk about policies, how to improve them. Take home message. Cohort and causal thinking has to be occur jointly now, so that we can give more evidence-based, propose more evidence-based policy in future. Then you know that TT basically it fills the gap between observation and causal association. So TT is a good study design, which, but for that we have we need many kind of experts of many domains in that group. So that has to be there. Then finally, when you are doing a TT target trial emulation, then design as if you are running a real clinical trial, though the thinking has to be there. When you are doing a TT, then you have to think like you are doing a original clinical trial. Based on that, we can say that yes, like this TT will be successful in future. So by that I will finish my talk. Thank you, sir.
Thank you. You are dot on time. But you did not give me any time for taking questions. But however, if there are any burning questions, please raise your hands. If not, then you can also interact with him post the panel session. Are there any questions? So you have talked about design strategy, implementation of the cohort, statistical analysis, validation. But the most eye-catching for me in your slide was the federated cohort networks, which sounds very interesting. How do you propose to have a federated cohort networks if the variables are not similar, or how do one do it?
So again, in US I are going through some of the cohorts. They have done this. Not like old cohort, but some recent cohorts. Because what happens is they are the first thing is when you are designing a cohort, the variable definitions that varies. Okay. So again, ICMR has to take initiative in that, because they can create some standard guidelines for these cohort studies. That which first step. Second thing is, even if we don't have a standard guideline, in that case also, if we there are some at least if there are 100 variables in one cohort, another cohort has 30 variables. If even 10 to 15 variables are there which are matching with each other to some extent, and then we have statisticians who can work on that to emulate this kind of study design and create the study. And at least, so I was going through one article, at least 10 variables has to be there to emulate a clinical trial from
right. So that's what has to be the
yes.
guiding principle.
So at least some commonality has to be there between cohorts. So that can be done, I think.
Okay, thank you. A round of applause for Dr. Somen.
Thank you, sir.
So moving on, now we will move to a panel discussion. I would invite all the eminent panelists to come onto the dais. I would like to invite first Dr. Roma Ratan to come onto the dais and take a seat. Dr. Roma Ratan is the Joint Director of Medical Education and Training in Odisha. She works in the Directorate of Medical Education and Training, an organization responsible for improving medical education. So, madam, please have a seat. Our next panelist is Dr. Devadatta Bhattacharya. Yeah, please come. Dr. Devadatta Bhattacharya, Principal Scientist at the ICMR Regional Medical Research RMRC, is a microbiologist specializing in infectious diseases, epidemiology, One Health, zoonotic diseases, antimicrobial resistance, a very burning topic. So, Dr. Devadatta, please have a seat here. And my next panelist is Professor A.B. Hota, who actually has done his master's degree, MPhil, and a doctoral degree in anthropology from Utkal University under the supervision of late Professor L.K. Mahapatra. After being professor in anthropology, he was inducted into Indian Administrative Services, IAS officer, and a person who is regarded not only as a civil servant but also as a professor. So, Professor, please take a seat. Round of applause, please, for all the panelists. And I would like to request Puneet to join me as a co-host of this panel discussion. So, this particular panel discussion is designed in such a way that it will not be monologue. So, I would request them to share their piece of information that they have done. At the same time, I would expect that from the audience, some burning questions to come so that they are pushed to the corner to answer those questions. Anybody in the audience who has worked in the tribal cohort, please raise your hand. Any tribal cohort, आपने किसी ने कुछ इसके ऊपर काम किया है और करना चाहते हैं in future? Because the session is focusing on tribal cohort future. कम से कम हाथ तो उठा सकते हैं, माना कि लंच, yes. Oh, multiple hands, good. So, अभी इस सेशन में हम ट्राइबल कोहॉर्ट की विजन के ऊपर डिस्कशन करेंगे. So, we will start with, I think, my question. कहाँ गया? Right, this is where. So, the genetic reference map of genomic structure and disease inheritance as well as child and maternal health. So, इस topic के ऊपर, madam, आप would like to share something that what are the data that has been obtained on the tribal cohort and what are the things that need to be done in future? And you can take the podium maybe. Yes.
Good afternoon, Jai Jagannath. Namaskar to Dr. Ganguly, who's been a mentor and a very senior guiding person for all of us, and all the dignitaries on the dais and off the dais. Now coming to tribal health, vision, the cohort on tribal health, and I would like to join it with the One Health mission. That is presently the concept of Government of India, and all of us are supposed to follow that. Now see, when we think of One Health and when we think of the tribals, they cannot go parallelly, they have to go together. And when we consider genetic mutations, maternal health, child health, all this also goes hand in hand. See, we learned certain things from COVID, from Nipah, from various other pandemics and zoonotic infections, that as well as malnutrition, which is also a pertinent problem. It is not that there will be an intervention, there will be certain genetic mutations even after giving drugs, giving supplements. Still we are unable to cure anemia. We are still struggling with anemia, even though we have been running the Anemia Bharat program. We have been running Amlan in Odisha. We still have anemic mothers. We still have mothers dying from hemorrhages. Our maternal mortality at the national level, Odisha is nothing. The data from Odisha is such that I feel bad. So, is it that the intervention, is it that the implementational research is falling back? Are we giving the medications and the medication is not working in curing anemia? Is it because there is a genetic mutation? So these are the things that I would like institutes like ILS to collaborate with public health people like us so that we can know the way forward. Where are we stumbling? Why are we not getting to improve? Today also we see children with protein energy malnutrition, जबकि एक पोषण प्रोग्राम हमारा चल रहा था. आज भी पोषण 2.0 चल रहा है, but still there is malnutrition. So what is it that we are missing? We don't know. Then coming to research, like on Monday there's a meeting with infectious diseases where they say that drinking shallow water will cause diarrhea. So we give a letter to the works department that the drinking water supply should come from deep bore wells. Tuesday we have a meeting with the CKD team. They say that drinking deep down water from deep down causes leaching of heavy metals into the water, so you should not have water from deep bore wells. So as a public health person, what do I say? From where do we drink the water? So unless two of the teams talk together, decide a mid path, we don't know. And tribal population has a very unique socio-cultural, economic, food habits, everything is very unique to them. Though urbanization has started influencing, but still they are isolated, they have certain food habits, which is a little different. They have certain mutations, they have certain thalassemia, sickle cell, hemoglobinopathy diseases, which are not there in other populations. Earlier it was like there was no crossbreeding, but now there is crossbreeding, but still there exist certain diseases. So how does the One Health mission address them, bring them back to the mainstream? And also we need to think that this population may not be having access to healthcare. We are working on certain issues, but are we asking the right questions to find answers? So keeping all this, encompassing all this, I would request institutes like ILS, institutes like ICMR to collaborate with us at the State Health Department so that we find solutions and help us bring Odisha to the forefront and bring out a more healthy and happy Odisha. Thank you, sir.
Thank you, madam. Madam, please वहीं रहिए. एक question है मेरा co-panelist से.
Yes.
So, ma'am, just a comment actually. The questions that you are asking, what is the observation based? And that's where we connect, because we have answer in terms of genetic mutations. So we are finding, which was also part of my presentation, which could relate to low content of hemoglobin, or say unable to utilize biotin because of the mutations that they have.
Yes.
Right. So these observational studies has to be connected with the research interventions, which will become the basis of public health policies.
True.
Which I also think that just giving the nutrition, for example, will not help. Right.
Yes.
If there is a genetic defect in that, you need to find out alternate strategies. So in this regard, I think this platform is also very optimal because of the kind of expertise people have here to connect and give views on that.
Yes.
So what do you think about it? How do we work on this angle to, like multidisciplinary, but answering a single question?
Yes, we need to work in multidisciplinary projects. We need to involve the genetic mutation studies. We need to involve the NCD cell of the state. We need to also involve the nutritional components, which is supported by UNICEF, which is supported by the state as well as the Government of India team. where they are giving, and we also need to take the data from the ASHA, who is actually the ground level. The ASHAs and the ANMs, when they give the medicine and when they give this nutrition packets, whether the patient actually has it or वो नहीं रख दिया, नहीं एक बार खाया पेट खराब हो गया, मैंने और नहीं खाया. So there are so many small things, because in tribals they will trust their own hakim, not the intervention, not somebody who's come from outside and giving 4 tablets. So again, you have to understand the nutrition, whether it will be in the form of a tablet, or it should be some grains, or it should be incorporated in their diet, and how do they have. You have given an iron tablet to be had. मैंने iron खाया, उसके साथ साग भी खाया. So the folates, oxalates and the phytates in the sag have taken the iron and gone. There is no absorption.
That's really interesting, ma'am. Yeah.
So then you have to say, नहीं उसको आंवला के साथ खाती तो अच्छा होता. Vitamin C is there for better absorption. So you have to understand the very little nitty-gritties. When as a researcher you go, we need to take all these people in our team to understand the behavior of the population.
Thank you, madam. Point well taken. We will also take questions later on from the audience. So before that, we would like to move to our next panelist, Dr. Bhattacharya. So Dr. Bhattacharya, आप यहाँ से भी बोल सकते हैं, डायस पे भी जाएंगे जहाँ पे आपको comfortable है. We understand that while working on with the tribes, much of their health is dependent on the ecosystem they live in, the kind of cattle they have, the sheep they have, the surrounding all together, the healthiness. So it comes to a chapter called One Health. So you are an expert in that area. So how would you see One Health program helping the tribes or the tribal nutrition as a whole? Your comments, and we would like to take questions later on. Thank you.
So, very good afternoon to everyone. So, sir, your question is that how One Health is relevant to the tribal population or the indigenous population we are living with. So, actually, we at RMRC, we have experiencing of working with the tribal population from the last, I think, more than a decade. And we have some wonderful cohort being maintained with us. We have a cohort of something around 1 lakh in our MRHRU Tigriya, which we are using for the dengue vaccine trials. So we have a cohort, we have undertaken one of the first ever study on the tribal health survey in Orissa, which involving something around 30,000 population and 10,000 household, and around 60 tribes that we have covered in our study. So it was an enormous study where we have seen or assessed almost all the parameters, starting from anthropometric, socio-demographic, infectious disease, NCD, communicable disease. So, and we have another cohort that we are maintaining in Koraput to study the transmission of zoonotic disease like anthrax, brucellosis, and leptospirosis. The main issues, I'll not tell problem, the issue is to convince them, because the tribal population have their own belief, like anthrax. Anthrax is a problem for us because they don't understand the bioterrorism aspect of the anthrax bacteria. Because it is spread through cattle, livestock, and most of the household, they have livestock. So when we tell them that it's spread from livestock, they told that we are handling livestock from the last, I think, 100 years. So we have never found anthrax, and until unless hardly there is 1 or 2 deaths. So it doesn't matter for them. It doesn't. They don't understand it died of anthrax. Might have died from something else. So it took us some time to convince them that the livestock that they are harboring at their houses has to be vaccinated, because vaccination is one of the major interventions to stop the transmission of anthrax from animal to human. So we had shown them how anthrax is affecting them, how anthrax is affecting their lifestyle, their economy, their earning, and even we have shown to the district administration that the charge of the anthrax vaccine being charged by the veterinary department is something around 5 rupees. So getting a vaccine charged of 5 rupees is a luxury for them. They try to avoid it. So now, based on our recommendation, the vaccination of anthrax is free of cost for the entire district. So these diseases like anthrax, brucellosis, leptospirosis, scrub typhus, dengue, these management of these diseases require a One Health approach. I think everyone here knows what is One Health, where we all come under the one umbrella for a better life for all, not only for human, it is better for all. So in that aspect, we all have to join hand together. We cannot work on silos. Sitting in a AC room, we'll tell, okay, we will work on One Health and all that, but in the field, the moment we start working together, because when we have seen earlier in 2016-17, when there is some outbreak of anthrax, human health used to go in one line, veterinary used to go in one line. So we have successfully demonstrated how we can, a coordinated approach can be helpful in a better management of this kind of disease, and we can do a timely intervention and management of such infections, so that we have seen in COVID, how all departments starting from administration, the Prime Minister's office, local administration, Sarpanch, Panchayati Raj, labs, public health, everyone has come together and we could defeat the COVID-19 outbreak in the country. So I think we require, and again One Health, it will be again a big word for tribal population. We have to make them understand. We have to make the local administration understand why it is important and why it is important for betterment of this population in the state of Odisha. And we can come up with a model for the entire country. Odisha can be a model for the entire country. Thank you.
Thank you. You may take your seat. So now I think the final panelist, sir, I will ask you a little bit difficult question, and maybe I'll try to push you to the wall so that I know you always tell, you don't mix the words, you tell the thing that is the hard fact. सर एक तरफ RMRC या कोई ऑर्गेनाइजेशन कहते हैं हम 10 साल से ट्राइबल कोहोर्ट पे काम कर रहे हैं, ILS कह रहा है हम 5 साल से काम कर रहे हैं, और पॉलिटिकली देखा जाए तो लोग बोलते हैं कि इनका हेल्थ ग्रो कर रहा है, और दूसरी तरह से देखते हैं तो अभी भी स्टंटिंग है, अभी भी डिजीज इश्यूज है, अभी भी तो उनका लॉन्जिविटी का इश्यू है. तो आगे बढ़ते हुए आपने जितने सालों से ट्राइबल हेल्थ प्रोग्राम में काम किया है, आपका पुराने जो नॉलेज है एंड क्या आगे कर सकते हैं, इनको कंसाइज करके अगला 5-7 मिनट में अगर आप ऑडियंस को बताएंगे. Slides, please.
No. Let me first speak. If I need, I will go to the slides.
Okay.
Because the way you have asked me, probably it reduces the opportunity to show the slides.
No. You have the freedom to express.
I'll be absolutely comfortable, speaking back to you. The esteemed panelists, chairperson, and I find a number of experienced persons sitting in the front row. You see, we have been always saying that the tribals are suffering from different kinds of diseases. We have no clue to it. And whatever medicines we give, whatever medical facilities we provide at that doorstep, there are cultural barriers, resistances for which they don't access that. But let me tell you, we have a lot to learn from them. If you look at the indigenous knowledge system and practices and the method of cure, I tell you, all the medicines, important medicines that you see in the market today, that you see in the system today, have a tribal connect. I remember when I was young, barely 6 to 7 years old, and we used to move with our parents because they were moving like, moving like migrants, migrant laborers, when they were working in government sector in those days. Tribals always have an answer to any kind of disease. But of late, the indigenous knowledge system and practices are dying away. They're vanishing. Time has come when probably the medical practitioners, particularly I talk about ILS because I have been connected with ILS for about 3 to 4 years. They have machineries in place and we have connect with the tribals. We can access the tribals and you can, go in for, scientific validation. With the modern, system of validation in place, I believe before talking about the tribal diseases, we must try to find out what are those traditional methods of cure, what are those tribal medicinal plants on which they're depending, and how to zero it down so that it can be integrated with the modern healthcare system. I tell you, it is found to be mission. There are so many institutions who are working on that, but everybody is working in silos. I remember during COVID, when restriction to go out was heavily on us, I had been to Raigada. When the corona was at its peak, believe it or not, you won't even find a small kid, in the forest areas. But I was surprised to find out that there are people who are moving, who are not tribals, who are not from, our state, but from outside the state. And I could find out that they are from pharmaceutical companies. And they were probably looking at whether there will be some answer from the tribals about corona. I will not be surprised, whatever you see has come up today might have a tribal connect. So my point is that there has to be two sides of it. You have to find out what kind of diseases the tribals are suffering from. There are marvelous studies which, when I was director of Tribal Research Institute, we had collaborated with RMRC, and we had done for the first time in the state disease prevalence among PVTGs in Odisha. Out of the 64 tribal communities that you find in the state, we have 13 such communities who are more vulnerable than the rest. And this study, in fact, came up with such revealing, findings that we shared it those days, I think NHM director was Salini Pandit. We shared with her, and it was taken to the policy level and implementation level. I can just tell you how action research is done and how it will have, serious implications in addressing the issues of the tribals. One community, all of you must have known, is Dongriya Kandh. It is a PVTG, and it is a PVTG underlined, Dongriya Kandh. They fought against the mining mafias in, Vedanta, in the, Niyamgiri Hills. So we found, our studies found of RMRC, which we collaboratively did, we gave them the connect and they brought out the results and the causatives. We found that about 30% tribals were either blind or they were developing, they had near blindness. And after this study, I'm just telling you this, there are so many other kinds of, effects that, the tribals are confronting. But after we got this, at a cost of about 30-40 lakhs from Ministry of Tribal Affairs, I had done it. I tried to find out, whether the study will end in itself or will go a little beyond that. We found out a very enthusiastic person, Dr. Das from L.V. Prasad Eye Institute. And when we spoke to him, he said, I only need about 10 lakh rupees. I'll try to do a screening of all the 10,000 Dongriakan people that are inhabiting in that particular area. So he did that. We found out, identified who need cataract, who need corrective glasses, so that the embroidery which the Dongriakan women does and they were not able to do, they could see and they could do it once again, which gave earning to their food basket. And today you see that particular issue, I won't say that issue has been resolved, but at least those who were losing eyesight, they have got back their eyesight, barring only 36 people out of 10,000. The causes as to why this eyesight, they are not able to see, is now getting worked out by Jodhpur AIMS. AIMS Jodhpur has taken it up and they are conducting a study on that. So what I would like to tell you is that let us try to understand which diseases the tribals are suffering from. And on the other hand, we should also try to identify what are those indigenous knowledge system of cure that the tribals are doing. Not all of them are scientifically valid, but we should also then go in with a kind of validation, and probably an integration is necessary. Coming back to the studies and the priorities that we should give in respect of tribals so far as health is concerned. Before I go into that, because I might forget, so I'm telling you, often we think that the tribals are illiterate. The tribals are illiterate and they are not availing the modern healthcare system. But we must understand and acknowledge the fact that cultural barriers and those things are definitely prompting the tribals not to easily access the modern healthcare system. What do we do? Madam might be failing, from her, directorate, or our doctors may be failing in their own blocks, districts, and in the state level. We have to constantly follow a strategy, social and behavior change communication. Social and behavior change communication should be, at the center stage when we do any kind of developmental initiatives in the tribal areas, may it be health, may it be livelihood, whatever it is. Coming back to research, I'm very sorry to tell you that here is ICMR, here is health department, you find AIMS to be in Bhubaneswar, and there are so many institutions who are doing studies on the same subject at the same time or at different points in time, not sharing as to what one agency is doing with the other. This is a matter of concern, I tell you. Time has come, we have to join hands together. I was talking to the director, ILS. He was also concerned about the funding part. Yesterday, I had the privilege of attending tribal business conclave in Delhi. A lot of discussion took place on 11th and 12th. Even ICSSR came. I asked them, because they are funding in a big way for research. And research on PVTGs is now their priority. for 25-26 and 26-27. Coming to Odisha, when we see 64 tribal communities, out of which 13 are PVTGs, and our kitty is small, which are those most vulnerable whom we should target? There are two categories of tribal communities whom we should definitely target. Who are those? And how many out of 64 they will be? All the 13 PVTGs, though we have done this study, I'll come to another study which has been done by, again, RMRC with the fund that I could arrange and with collaboration of SCST RTI. But which are those two groups, which we should focus so that with limited funds, we can make a dent. These are the PVTGs, 13 PVTGs. And you'll be surprised to know that out of the 64 tribal communities that we find in the state of Odisha, though the overall population growth, decadal growth, is little more than 15%, there are 21 tribal communities who are declining in number between 2001 and 2011 census. I don't know if I'm taking both time.
No.
Between 2001 and 2011. I think as important these 13 PVTGs are, those 21 tribal communities are equally important or more important. They are small communities, they are reducing in number, and reducing in number with a big magnitude. I think we should focus on them. Studying on small community is easier than studying on large communities of 10 lakh, 12 lakh, you find Santals, okay? So I would suggest that whatever studies ILS, the other day they shared with us and I had the opportunity of coming, whatever studies RMRC is doing, whatever studies your AIMS under your nose is doing, I think, and Tribal Research Institute should be the facilitator who can give you an access to the tribal communities, which is very, very difficult. We should come up with a collaborative kind of a study, try to identify the causes, identify the practices, how much we can get benefit from them. We should also organize a benefit sharing arrangement, otherwise the tribals will not give you the details as to what they are using for treatment, lest you may hijack it out and they will be paupers without that. So it may be proper to have a very small group of 8 to 10 of us who can sit down in a small discussion and set the priorities for research in a collaborative mode. Funds are available. When I asked, one of my students who is now joint director in ICSSR and looking after funding for PVTGs, she says, sir, nobody is applying with a sensible project. If on a health concern that, institution of repute will give us a proposal, we are prepared to fund. Funding is not an issue. Yeah. The second, Ministry of Tribal Affairs is spending hundreds of crores of rupees to address the critical health issues after the banged report on tribal health. You must have, heard about it and you must have seen that. So they are also asking if an institution worth an institution who is concentrating on tribal health issues, we are prepared to give a center of excellence to that institution. So here is RMRC, here is ILS, also AIMS is under our nose. I believe 3 of you can come up and can have a joint venture and a center of excellence, which will probably give you the answer. Lastly, I will tell you, I retired in 2017, but for whatever good or bad reason, I got an extension for 5 years and I worked in Tribal Research Institute. The tribal health was the first project which I told, on the PFTGs. The second project is just over. And you must, you must try to access that data, and that data will speak to you about tribal health and the socioeconomic correlates. Why? What is that research? You must have known about the NFHS. When somebody asks you, tell us, about maternal and child health care, infant mortality, child mortality, or maternal mortality, we look at the National Family Health Survey. Already 5 surveys have been done, and the 6th survey report is probably going to be out in April or May. But if you try to find out the disaggregated data for the tribals, it is a pity. So what we did, we brought quite a handsome amount of money. Handsome, I'm saying, for a research institute, 10 crores is a handsome money. We didn't have the expertise, but we had the wish list with us. We spoke to Sanghamitra Pati, and I asked them that why don't you do a state tribal family health survey. So we instituted a state tribal family health survey where all the tribal communities and all the PFTGs have been separately studied, and you can get data on each community. That is a very big thing. The report has come out. It has not come to the public domain though, and I would request you to please tell your director that this should come to the public domain so that others can use it and others will not beat at the bush. Third important thing, which I was speaking to Mrs. Ranjana Chopra, who had just taken over as Secretary Tribal Affairs from Odisha cadre. When she was there, we had a discussion with RMRC and a health observatory, which would have been the first of its kind in the entire country. A proposal was given. Government of India, Minister of Tribal Affairs had given 10 crores of rupees to start, but for some good or bad reason, that money though has been given to them, they have been stopped to use that money. Now, Ranjana Chopra ma'am yesterday has said that not only for the state of Odisha, but we would like to have, health observatory for the entire country, which will be a kind of, real-time basis, data that can give you, and one can know where the shoe pinches so that the, issues can be addressed. So friends, lastly, I would like to say all the institutions are good, no institution is bad, but let institutions do not do work in silos. They should come together and work on such issues where probably collaboration and collaboration will come up with much better result, with better coverage, and that is the result, that is the issue. If we don't take a place to do a collaborative kind of a research, probably the tribals will remain as tribals, their indigenous knowledge system and practices will die out, and they will continue to suffer, or the way the health indicators are improving, still there will remain a gap, huge gap, or the gap will be widened between the state average and the tribal average. Thank you.
Thank you very much. Round of applause, please. So, sir, as I understand from the panelists, dear audience, the consensus over here is that Madam is saying that the healthcare givers, the researchers, and the public researchers also should work together, not in silos. And Dr. Somen talked to us about not just think of human health, at the same time think as a one health along with the animals and all the surrounding around it. And sir, finally you suggested us that this is the way we can go forward, where we can focus with taking all the expertise together and do cohort kind of study. Already RMRC has done something. So my point is that, sir, in this particular meeting, when many doctors and researchers have come, CSIR has initiated a program called CSIR Cohort, where 10,000 individuals, they are basically CSIR employees, are spread across the country, where health has been monitored for, it is supposed to be monitored for 3 times right now in 5 years, and all parameters. So what is your idea if we say that similar thing we should do on the tribes, and maybe if not 10,000, 5,000 individuals, same questionnaire, similar parameters, if we monitor, then we can have a contrasting analysis. So I think you have told most of it in your speech. I think to the point, brief answer, how would you support such a program when we try to collect data in the same lines as CSIR cohort, 10,000 individuals, tribal cohort, 5,000 individuals, same questionnaire, healthy habits and all. Brief answer.
Definitely, this is a very welcome suggestion that you have given. Without waiting, without any further delay, I think we should grab that and do it. And you see, again I'm telling you, at times fund is a problem if the magnitude is very big. But if the magnitude is small, I don't think fund is a problem. We can always access for fund. It could be, can you imagine, yesterday 3 ministries were there together in Government of India. Piyush Goyal, I think is from Commerce, okay?
And I'm glad that you have access to such people. You just have to tell them that this is what.
Yes, yes. And our own person from Odisha is there, Jewel Oran. He is also open to any good ideas in the name of tribals. What is the outcome doesn't matter, but in the name of tribals, sky is the limit for him. And we have our own, lady from the state cadre, who is Secretary of Tribal Affairs. I think we should go with both hands
and
try to not experiment, I'll say. These days, experimentation and going in for all-encompassing 10 years down the line is not possible. Anything which is good is, not waiting for any kind of small-scale, what you say, small-scale, experimentation.
Chota research नहीं कुछ बड़ा सोचना है.
बड़ा सोचना.
So I would like to take a couple of questions from the audience. Let us take some questions from the audience. Anybody? Yeah, Santanu?
Yeah. So, in the lines that you have been telling, we had actually submitted a similar. I am Shantanu Sengupta from CSIR-IMMT Delhi.
Okay.
So, we had submitted a similar kind of a proposal, what Debashish said, that whatever we are doing in CSIR cohort, can we repeat the same thing in tribal population and see and have a contrast in what is going on in tribes versus, because as you rightly pointed out, there are a lot of tribes which are fast becoming extinct.
Yes.
Right? So it is important to see what their health parameters are, why this is happening. Unfortunately, for last 2 years, it is under consideration, but nothing is happening.
Which project, sir?
So we have submitted a project to Ministry of Tribal Affairs.
So he is not going to approve here, but he will definitely put his weight behind and tell people that.
Let me tell you. Let me tell you, whenever any proposal is accepted, normally Ministry of Tribal Affairs have got 57 Center of Excellences. Now the Center of Excellences are under scrutiny. Somehow or the other, because I am a retired person, and I am a useless person now, so I have been taken on the board. We will be removing most of the COEs, barring 10 or 12, and they will be inviting proposals for Center of Excellences.
Thank you, sir.
Center of Excellences have a better opportunity to be hard, for consideration when you submit a proposal. So please try to find out and.
Professor N.K. Ganguly, retired DG ICMR, sir.
Actually, what I was suggesting, that while we do research, the intervention should go back to the tribal population. And I will correct one conception, that this arsenic leaching is through shallow tube well, not the deep tube well. So when for the diarrhea program they dug up lot of shallow tube well, this particular basin they did arsenic leaching, it went into food chain, killed. But I will give you few examples. Like there were 5 room air for ARDS and the hypothermia, the kangaroo mother, but better things, as well as septicemia coverage at the local level through gentamicin injection. So Dr. Abhay Wang and Rani Wang has trained the tribal women, and I was surprised that they go out home and they do the birthing better. They take care of the ARD. Created a milk bank from the healthy tribal women, provide the best milk to those who don't do. So these are actual interventions which have come from a great research, and they go through that. Like in the one when we were talking about this was done with the DBT program. Dr. Vivek Kapoor and the CDC guys came from Penn University, and they had a plan that One Health immunize the cows. There was one of the best anthrax vaccine which was produced. We never used it. Bhatnagar and another got a prize for that, but we never used it. Panacea produced that, but never used it. So they said inject anthrax into the cattle, inject BCG vaccine into the cattle. There is a brucellosis vaccine with the bison strain made in India. Tanvaso is made in Bangalore. Inject the brucellosis vaccine. There is a common leptospira antigen vaccines also. So we need not actually immunize the tribal population, but we can immunize the cattle population through which they get it, and the One Health concept is. So what I will say, my comment, that whatever research we have done, some of them like Deepika Mohanty created a dot spot way of 29 thalassemia mutation. Coal India gives the complete treatment to many medical colleges if they want to treat thalassemia, even through the stem cell transplant. But if you could really provide safe blood donation, if you could provide the chelators, the affordable chelators, you could do something. So what I want to know from you, Dr. Mahapatra, that why are not we using the known proven research which we have done in tribal population effectively? What is preventing us?
Okay. I'll answer to you, but I'll take one more question.
And then we'll take and then answer. Yeah, 2 more questions, then we'll.
Okay.
Okay, great. Thank you very much, Doctor. No question, just a comment to answer your question, Devashish. Cohorts in tribal population, and it is possible, provided the researchers break the barrier of saying that it is difficult to work with the tribal, but believe me, it is one of the most easiest population to work with. Leave aside the terrain. So if we break that barrier, that is possible. And second thing about the One Health also, it is not we teaching the tribals the One Health. It is about understanding One Health from the tribals. Yes. I think 80% of the tribals know that. Sorry, that's all from me. Thank you very much.
Yeah, Arindam, last question.
Sir, this is Arindam from National Institute.
I mean, he has mic. I cannot avoid it. But एक question के लिए mic दिया हुआ है. समझ रहे हैं ना? वो हाथ खड़े के तो mic. Okay. ऐसा नहीं करते.
Sorry. So this is Arindam from National Institute of Biomedical Genomics. Okay. So I have a very focused question, like, one way in which genomics can actually address in specific population groups issues of health is understanding the health disparities. So if you look at specific tribal groups and the disease susceptibilities that are predominant in these groups and conduct focus studies where we understand what are the So for example, infections, susceptibility to different infections. So what are the different genomic susceptibility markers? I mean, that kind of study is easily done.
Yeah.
And maybe in Odisha, I am not sure whether you have already conceived or run that kind of program and then maybe expand it to a pan-India level. Your thoughts?
Okay, I'll touch that, but we must,
Yeah, last question, please.
Sir, thank you.
Basi.
I think it is a very good talk with us. So, it's a tribal basic problem, but it is galloping in your mind here. The tribal sensitiveness is not coming forward to our podium. I think so. The tribal economy is not very the visa law the tribal is the maroon of such an economy, and the tribal, the hopefulness for the proper scientific education, academic, the overall maroon in here or Odisha. So can you give your suggestion, how do you influence all that? Please tell us.
Sure, thank you, sir. All the questions are in, if you can take the, and we are running short of time. So.
I think I'll go to the question, of the DG, former DG ICMR. Sir, let me, your question was on why so many researches have been done. Most of the researchers are micro researchers. Micro research is also very important. But why these findings are not getting used by the policymakers and implementers? I think that's precisely your question. Sir, it is a matter of shame, I must tell you, that if you see number of researchers on health issues pertaining to tribal is concerned, there will be, huge bunch of, bundles that you find. But that's not being used precisely because we have not been, I'm including we. Well, I'm not a doctor, I'm an anthropologist and a bureaucrat. But then I must tell you, we are not able to bring it to the public domain. We are not using the media. Here is a media person, I'm telling you, we are not using the media. We are not, bringing it out to the public domain. And we are not reaching out to the policy makers and influence them so that some of us, like you, maybe like others, will be taken in the policy formulation group and the issues can be taken advantage of. I have seen institutions doing research after getting money, they are keeping it in the bundle. They are not sending it to the right, right forum. Why I am telling you collaboration is necessary. If collaborative researches are done, probably it will be easy. 5 institutions come together. They draft a host of things which probably government cannot deny and they will take this into cognizance. What is happening? ILS does in silos a study. They will come up with the report. Who will listen to them? Yeah? Sir, you have to become a collaborative one to catch the eye of the bureaucracy, the government to take cognizance of. Sir told us about, I'll just, in one line. Sir, you asked me about the comments. Okay. Now coming to, our journalist friend. Yes, tribals are suffering. If you see from the economic point of view, the poverty level is highest amongst the tribals. But you'll be very happy to know that recently 2 flagship programs have come up. 3 flagship programs of Government of India, where about 1 lakh tribal villages of the country have been identified. And the gap analysis have been done. Earlier, beating at the bush, development initiatives were done in areas. But now you have 25 indicators and the gap analysis have been done for 1 lakh, vulnerable tribal villages. This is covered under PM Janman for the pivotages, involving 9 departments, 11, saturation mode targets, which is reviewed every week by the PMO. That's the sensitivity with which they're doing. The other one is Da Juga, Dharti Abba. I'm not able to, say the entire, Juga, what Juga stands for. There also about 1 lakh, villages have been identified and 25 interventions, and existing 14 schemes of government is getting, roped in. And this will be done on saturation mode, on a convergence and saturation mode. This is early days. A review was taken maybe 6 days back by Honorable Prime Minister. And though early days, these 2 flagship schemes have made a dent. I think government never before was trying to do things on a convergence mode. For the first time, for past 2 years, government is doing, when I'm saying government of India. Government of India is doing on a collaborative and convergence mode. Let us hope the tribals, though they have developed over a period of time, the pace of development has never commensurated with the amount of funds that has been pumped in, but now the results will be seen. Even in early days also, the results are coming really better. But so far as health is concerned, again, convergence is the only answer to it. Come together, do something big, and you will see the tribal knowledge can be integrated with the modern healthcare system, and the tribal health issues can also be addressed.
Thank you very much. That's really indeed a very positive message. So much have been done, much more to do. And I thank all the panelists who joined me and all the people who heard us and then the question being asked. The job of the chair is to finish the session on time. I've been late by maybe 10 minutes. Over to you, organizers. Thank you.
Thank you. Thank you. On behalf of CSIR-IMMT and Cohort Connect, I would thank Dr. Devashish Das, session chair, and co-session chair, Dr. Puneet Prasad, and also our esteemed panelists. Thank you. And now it is over to tea. After 15 minutes or 10 minutes now, due to paucity of time. So in 10 minutes, we will assemble here again for the session 4. Thank you.
We have to.
Hello.
Yeah.
Doctors combination, okay?
So we may invite the first speaker, Dr. Pallavi Kshetrapal. We are please invited to present your talk. She is an associate professor at ST with experience in developmental genetics and maternal health, child health, and with a MSc from DU and a PhD from JNU CCMB. She did her postdoc at MGH Harvard Medical and has established a placental research program investigating molecular processes. So she'll be talking about the Garbhini, which is one of the famous cohorts, and we would like, in paucity of time, to restrict the talk to 17 to 18 minutes.
Thank you so much. So as I have the time, so I will start. So I am representing Garbhini, which is an interdisciplinary group for advanced research on birth outcomes TBT India initiative, and this is being led by Dr. Shivani Karnaka. She could not be here. She's at of talk. So I'll just talk about, which is a have the biological, epidemiological and environmental factors that could be associated with preterm birth. So BRIC THSTI coordinates, RCB is the proteomics counterpart, NIBMG, Dr. Arindam Maitra is here and he works on the genomics and the epigenomics component. The cohort is basically, was initiated at Civil Hospital Gurgaon, which is a district hospital in Haryana. And mostly we have migrant population from in and around Haryana. And we have Safdarjung and also AIMS as partners. Thank you for inviting me to this Cohort Connect. So maybe we can connect with this cohort. So let's see. So we begin with a hypothesis that attributable risks to preterm birth of various clinical and epidemiological factors vary during pregnancy. So this is a longitudinal cohort. It cannot be a snapshot because nutrition at the first trimester of pregnancy not necessarily is something which would be at the third. So that is why this cohort was built as a longitudinal cohort. And PTB could be a result of the static, which is the genomic predispositions, and dynamic, which are the epigenomic, proteomic and metabolic modifications or modulations at different stages of pregnancy. And time series data on diverse variables, which I just mentioned, across pregnancy will help stratify the women into defined risk groups of preterm birth. So with that hypothesis, what were the objectives that we had to basically deliver? That was epidemiological understanding or deep evaluation of the risk factors, clinical risk factors, ultrasound and AI tools, multi-omic biomarkers, integrated analysis of all this multidimensional data, and also, as mentioned today morning, that it builds capacity. Cohort builds capacity not only on the different omics that we are doing, on the different disciplines also. So we biologists met the clinicians, we understood what is the unmet need and tried to understand and put it into our platforms. So why preterm birth? Because preterm birth complications, which are 43.7, are the causes of neonatal death in India. So that is why it was to understand how we could prevent preterm birth. And this was a cohort which was built for that. Now this is the cohort profile. I think everybody wants to know exactly how they can plug their research into this. So if we see the birth cohort, we have 2 time points when we enroll the mother, which is the less than 11 to 14 weeks, and the second one is 14 to 20 weeks. And this is all done with a dating ultrasound, because preterm birth is birth before 37 weeks of gestation. And you have LMPs that can decide that, okay, the mother says that I missed my period and this is the LMP that I have. But it could be off by 1 week, it could be off by 2 weeks. So dating ultrasound is something that you really need to have done using ultrasonography so that you can risk stratify that which ones of these are preterm birth and which are term birth. Interestingly, then we were following these mothers at 26 to 28 weeks, 30 to 32 weeks, 35 to 37 weeks delivery and postpartum. So there were 7 such visits which were happening. And at all the 7 visits, we were taking clinical and epidemiology data. The data that we have taken is 2022 variables across these 7 time points. And I'll give you a brief about what this data is. And then we were also collecting biospecimens. If you see that the biospecimens collected at 5 time points. And today is World Quality Day. Tomorrow is World Diabetes Day. So quality has to be maintained so that we can stratify who are diabetic, who are not. So now the point why I talk about quality is that it was not only the quality of the ultrasound images, the quality of the biospecimen, and the quality of the clinical and epidemiology data that was being measured. We had internal quality monitors that were going to the site, and 10% or at places 100% of the data was being monitored by them. We had different ways of assuring quality control for the ultrasound images. So we had 2 ultrasonologists who were taking all the ultrasound data. And then there was a tier 1 quality control, where 10% of those images were going to 3 renowned ultrasonologists. We had a score that we had given for around 8 of the major parameters for anthropometry. If the scores were below that, the radiologists were trained,
Then there was a tier 3, because we cannot go back to collect the data again. So the tier 3 radiologists who were experts were able to see whether they can salvage some data, whether it is correct or wrong. So that way the quality of the ultrasound images was being maintained. Same way the biospecimen quality was maintained by taking the DNA, RNA quantity, quality, and also we have pooled samples that we have in the biorepository which we keep quality checking after 6 months. We also had clinical epidemiology data that was quality checked, and this was all taken on REDCap, so the quality was checked real time. These were some of the samples that are being stored in the biorepository: maternal sera, plasma, saliva, urine, high vaginal swabs, cord blood tissue, placental punches, membrane, neonatal heel prick, placental saliva, and now breast milk is also being collected, and infant samples in the birth cohort. So this is all being stored at the biorepository. We have 700K images and 300K videos of ultrasounds that are now being used to generate AI tools. 3 of them have been patented. And 1.4 million well phenotype samples in the biorepository of Garbhini. This is the participant study flow. So we had a sample size of 12,000 women who were enrolled in the cohort. 39,000 odd were screened, and we have all the data for 11,995 because there was a consent withdrawal also for 5 of them. Now, who is this cohort? So we have the socio-demography of these women, and we had an 82% of literacy rate, 15% unemployed head of the family. Family characteristics has been taken. Many of them were residing as nuclear family, that is 50% of them. 17% were exposed to second-hand smoke. Then you had the gestational history. Around 40% were primigravida. We also had 11% previous till preterm birth. So that is what is also known, 11 to 13% preterm birth is there, which is genetic in nature. And then we had the clinical features. We had anemia in 79% of them. So rightfully said by the panel discussion that anemia is there, but we did see a decline after the Anemia Mukt Bharat Abhiyan was there. First we used to see around 97, 98%, now we see 79%. So there is something that is happening when the free tablets of iron are given. Now, talking about the antenatal events, so we have 10.5% gestational diabetes in the cohort of these 12,000 women. We have analyzed the 10,000 out of them. Then we have 4.1% which are pre-enclemtic. We have fetal growth restriction, which is 10.5% at 30 to 32. So these are late fetal growth restriction. That is also a very different subtype of fetal growth restriction. Then we had 24.4% which are low birth weight. Low birth weight is anything which is less than 2,500 grams. 37.7% small for gestational age babies. Everybody is talking about stunting, so it all begins in the women or the womb. 2.2% which is stillbirth, and 12.9 preterm birth, which basically was the primary objective of this study, to see what is the prevalence of preterm birth, which is 12.9. When we initiated the study with the government records in the Gurgaon hospital showed that it was 5% preterm birth. So you can see that when you do a research study with complete quality, you get to know the real prevalence of the problem that is existing. Now, I'll quickly come to so there are many stakeholders in it, and I'll be speaking on behalf of the biology stakeholders now, because apart from the clinical risk factors and the epidemiological risk factors, which are not good in their dynamic prediction model, they have an AUROC of only say 68%. They wanted to have the biology predictors put into that model to see whether the AUROC can increase to around 80% and have good sensitivity specificity for the algorithm. So we initiated with not only developing biomarker panels to predict preterm birth, which is on the right hand side, but with also a notion that we need to understand the biology of normal pregnancy. Everybody is talking about normative values. So here also we need to know what which is going wrong at which trimester. So this longitudinal cohort helped all our biologists to understand biomarkers, or you can say predictors, risk predictors for genomics, epigenomics, which Dr. Arindam will be giving a talk right now after me. Proteins is being led by Dr. Tushar Methi at RCB, microbiome by Dr. Bhaptosh at THSTI, and metabolomics by me. So I also started something as an offshoot in the Garbhini cohort. We weren't collecting placenta first, but we initially understood that you have preeclampsia, you have small for gestational age, you have preterm birth, you have low birth weight. So if you combine all these pathologies, they are known as great obstetric syndrome, and these great obstetric syndrome is around 28%. Preterm birth is only 12.9%. Why I say that is because all these pathologies are somehow linked to placental dysfunction. Keeping that in mind, that if we try to understand the cornerstone of the pregnancy, which is placenta itself, if there is enough nutrition, why is it not being taken up by the baby? Are there transporters which are not working well? Is the placenta not being formed properly? Because it's a vascular organ. You need a lot of perfusion to happen. Is there any malperfusion that is happening? So based on that, we wrote a grant, and I think 4 of us were in the same group, and we worked out to understand what the placental implications were, and I think I'll leave it to Arindam to talk about it. And coming back to the biomarker panel to predict preterm birth, so we plan to integrate all these markers that we have identified, and I'll come to in a bit what we have, and integrate them to use them as risk stratification for the mothers who are high for at a high risk of preterm birth. Now I'll quickly go down to the work that I do. I do a lot of clinical metabolomics. So we have LCMS based metabolomic workflows that we have developed in the lab. And thanks to Shantanu, sir, he has helped us a lot in this. So we started with a case control study. We cannot just go with the platforms which are there, which is not cost effective, because these omic studies are costly. So we start with a case control study, where we started with a case control study of taking sera samples from 62 preterm birth mothers collected at early 20 weeks of gestation, and we had the controls which were term births. This we did as a nested case control study within the Garbhini cohort. So now, to keep the confounders away, we had our inclusion and exclusion criteria well defined, such that there is only one difference between the homogeneous population, that one group gave preterm birth and the other one gave birth to a term birth baby. So I'm not going to details, but this is the LCMS platform that we work on and have established in the lab, where we identified untargeted predictors of preterm birth. This is how we have done it, and we use the Progenesis QI. So we identified 17,000 odd features, and they were reduced to 818, and these 818 features were reduced to 8 metabolites. Now, this is an untargeted study. We have relative concentration of these metabolites, so we need to have the absolute concentration. So we transformed it into targeted metabolomics. So these 8 putative were identified, and we went ahead with targeted verification for these selected metabolites. So we, just a representative here, we were able to verify 3 of them out of the 8. 2 we did not find standards for. So sometimes these metabolites are not well, you can say, annotated that you will find some standards. So, but we were lucky enough to find 3, and one of them I just projected here. But interestingly, when you make a model of clinical and imaging data, so why imaging data? Now we had a very beautiful imaging data, and as I mentioned that I'm very interested in placental malfunction. So in the ultrasound, in the Garbhini cohort, we have the imaging data for the placental hemodynamics, which is pulsatory index. So basically clinicians use this pulsatory index to identify mothers who are at a high risk for preeclampsia, or there could be a high risk for any adverse outcome. So we tried to use that in our model. So the first model is the clinical and imaging risk factor, where we use the mother's age, BMI, and uterine pulsatory index, and we were able to see an AUROC of 0.53. Now, when we went into the only metabolite model, we were able to increase our AUROC to 72%, just with the metabolite. We also integrated the metabolite into the clinical and the imaging markers, and we further reduced our AUROC to 70, which is near to 72. So that tells us that integration of these omic markers really is something which is needed, and maybe the gap that is required for risk stratification at the clinics. Now, how do you transform that into the clinics is something, a second challenge which we are working on. Now, just to the last 3 slides, as I told you, I represent many people from the stakeholders from the Garbhini cohort. So I'll just tell you that we have many other panels that are being made. I just talked about the metabolomic panels. We have the genomic panels which are ready now for external validation. We have the proteomic panels which are ready for external validation. And they are all at different stages, which are the TRL stage. Apart from that, as I mentioned, that we have lots of videos that we have captured, so sweep videos, where trained ultrasonologists are not required. It's only that we have a specific probe that can just sweep the mother's womb to understand whether she's a breech position, whether there is any risk for preterm. So these models have also been built up, and there are 3 patents that have been already put up. 25 publications and 10 theses. So capacity building, that is where capacity building is, there is where sharing is. Now with all this clinical data and the images, we have the samples also. So we have put all the samples into a biorepository, which I take the privilege of saying that this is the first DBT supported biorepository which is now internationally accredited with ISO 20387. So we have credibility to all the samples that we are keeping. We have proficiency testing for most of the samples which are externally validated by external providers. And major thing that we are here today about the Cohort Connect is how do we share the data. So it's better to enjoy the car ride when the fuel is full, but we need to empty it so that we can enjoy the ride. So what we have done is that we have put biorepository governance and access to sample process with the help of the funding body. So we have an access control committee for Garbhini, which is known as the Garbhini Access Control Committee, and we have been receiving lots of requests. This happened because of COVID, because in COVID we gave around 99 requesters samples for vaccine development.
Last 1 minute.
Yeah, last slide. So 30 requests have been received and 27 have been fulfilled. Now, how does one approach us? These are the few requests which were external requests which were given to people, not only the samples, but also there was a data request that came to us. How do people reach us is, so the best way of reaching out is WhatsApp, but I think also web. So we have this Drishti platform. You people can go into the Drishti platform. We have put data for what variables we have, what clinical data we are taking, how many samples we have. And this has also helped us to reach the global collaborations, I think. Long hair. So this is a team. I just wanted to point out that we have a team, and thanks, Dr. Bhatt.
So I think we'll close this particular talk now. Ma'am, you can take rest. And questions can be asked during the dinner time to her.
Yeah, so we can have questions after the next talk, because this will be a continuation of the first talk. So may I invite Dr. Arindam Maitra from NIBMG Kalyani. He is the Associate Director of this NIBMG at Kalyani, West Bengal. He holds a PhD from AIIMS Delhi, and he has been a critical player in lot of nationally and international projects, and he is one of the leading researchers in the genomics in the country. So he'll be talking about the genomics part of this Garbhini project at this point. And so, अच्छा, ओ हम लोग भी critical use करते हैं ये word. अच्छा नहीं करेंगे, ठीक है, no problem.
So, as the slides are being put up, so I am surprised Pallavi is coughing because I am the person who succumbed to the temptation of the ice cream that was offered to me in the train in yesterday night's dinner. So I was the person who is supposed to cough. So thank you, Pallavi, for the wonderful setup, which I will continue and show how cohorts. So we had been talking about cohorts, we are describing cohorts and saying what we can do throughout the day. It was fascinating, simply fascinating. And the talks were fascinating. Food, of course, is a different thing that I will probably will continue doing. As we were, and of course, I must thank the organizers, particularly Professor Shantanu Sengupta, Dr. Souvik Maiti, our Director Sahab, who gave a very beautiful poetic sojourn in that meeting with the minister. And of course, so what I want to talk about is I'm a geneticist or a genomicist who works on human health and disease, and it is my dream every night that when I wake up tomorrow morning, all the diseases will become monogenic and single factor, and they never turn out to be two. And in that context, that is what drove me to preterm birth is something I was not working on, say, last maybe 15 years ago. But then somebody, and that individual I will show you at the end of my talk, managed to interest me into preterm birth and into this fantastic group. Pallavi is, of course, one of the key members of that group. And what the whole concept of a complex trait, disease trait, is embodied in preterm birth by sheer nebulousness. I mean, we know type 2 diabetes, we know coronary artery disease, we know hypertension, we know they are multifactorial, polygenic, but preterm birth is a trait, if I can describe it as a trait, which has enormous number of biological, environmental, and many unknown attributes or underpinnings. And that makes it very challenging to understand what causes preterm birth and how can we predict preterm birth and whether we can modulate the risk of preterm birth. So Garbhini is a very beautiful platform that actually takes care of these kind of things. So that leads me to the talk which I will deliver today, where I work on genomics, epigenomics and transcriptomics in collaboration with the rest of the Garbhini team, particularly Pallavi. And what is particularly important is what I show is basically fueled by young people. Few young people from my lab who had been doing their PhDs on them primarily, and many of this work is actually output of their thesis, of their PhD work, or some collaborative work they have undertaken. So we looked into this genome, epigenome, transcriptome conundrum. We conducted the first genome-wide association study on preterm birth in South Asia. It is very surprising that it has not been done before, given the fact that South Asia and India has the highest number of preterm deliveries every year. And there were certain rates of preterm birth that Pallavi showed earlier, which underscores that point. Isha in my lab has finished her PhD, moving out on her postdoc. She did the GWAS, and now it is being taken over by my next student, Rishika, who is working on long reads and looking at structural variants. Again, something that is not tapped at all in preterm birth outcomes. We did a longitudinal epigenome-wide association study. So this is probably the only example of longitudinal EWAS that has been conducted in preterm birth worldwide in any population. And the student who did it, Jagashila, has gone on to UPenn for her postdoc. Divyank is taken up and trying to integrate the GWAS and EWAS, and I will talk about that. And then finally, with Pallavi, this is a lateral study that we have built out of Garbhini, and Garbhini has given rise to many such lateral studies that are enshrined in Garbhini, but then going on, kind of working deeper on certain aspects. There's the placenta. And we had been conducting placental single-cell transcriptomics in preterm and term deliveries, and Piali and Suprati presently have done a fair amount of work with Pallavi's lab, and we have come out with very interesting answers to some of the results that we are seeing that nobody has seen before, if I may say. So the GWAS was conducted on 6,211 women in the Garbhini cohort, and we have exact dating information in these women, and that is one important thing to consider when you are investigating preterm birth. The cohort had both ultrasound-based dating as well as LMP, and then clinicians in the cohort and our team members, we all came together and came out with a very accurate dating method, so that we know that preterm birth is delivery less than 37 weeks of gestation, and we have not excluded any late preterms in our analysis, because late preterms are the most of the preterm deliveries, and we have to take them into account if we try to solve or find out solutions of preterm birth. So we used this 6,211 women. We used a GWAS array, which is global screening array, where we have not only 650,000 SNPs, but another additional 50,000 SNPs, which are built into the array, which have been found to be important for various disease association studies worldwide. Now, these 700,000 SNPs were genotyped in these women, and this is something that Shantanu will probably find interesting. Way back in 2023, when we did the analysis, there was no appropriate, so people who do GWAS analysis would know that there is something called cluster file that is required to do accurate genotyping. And generally the array manufacturers like Illumina provide a standard cluster file for GWAS analysis, and they say that you have to build your own population specific cluster files for more accurate genotypes. So we took the pains of using this opportunity to come out with our own custom cluster file, and that has been in our earlier publication in Lancet Regional Health. So anybody who was doing these cohorts and doing these GSA arrays of 700,000 SNPs, please feel free to access those cluster files and use them. And it has been proven that they provide more accurate genotype data on Indian samples that we have tested, and many others have used from us and done that. So cohort studies not only is all about sharing data, but cohort studies is also about developing methods, innovations, and sharing them across cohorts in a country like India. So we did this analysis, and then we came out with typical, so this is a typical Manhattan plot that you see there, and we identified one SNP, which was at genome-wide significant level. So that SNP is RS57480735, where the minor allele is G, and presence of the G allele is associated with risk of preterm delivery. Now, preterm birth is a dichotomous trait. It can be converted to a quantitative trait by looking at period of gestation at delivery, or POG in weeks. So we also found that the G allele, which is the risk allele, was associated with decrease in gestational age at delivery. So it was not only associated with a dichotomous phenotype, but also with a continuous trait like gestational age at delivery. And then we also found additional 39 SNPs which were associated but at a lower level of significance, and out of them 20 SNPs were associated with a, if I call it a more severe phenotype, which is early preterm birth, that is birth less than 33 weeks of gestation. So this is the whole GWAS summary that we developed. We found that this genome-wide significant SNP is known to be a regulator, or EQTL, of a gene known as NR2F2. Now, it is known that NR2F2 expression ultimately leads to arterial stiffness and increase in arterial pulsatility index, which can lead to impaired uteroplacental perfusion. Now, this is again, I use these as examples to show, underscore what is the importance of clinical and metadata in cohorts. Why very accurate clinical and metadata is required in the cohorts to make full use of whatever kind of omics or whatever investigations we do. So we found that in this cohort we had uterine arterial pulsatility index data, and we found the risk allele was associated significantly with an increase in uterine arterial pulsatility index, which shows that this is actually in line with what has been previously identified in biology, and then using our bulk and single cell transcriptome data on some of the placentae, we found that indeed the NR2F2 expression is more in preterm deliveries, and that too in specific cell types, like fibroblast or vascular smooth muscle cells in the placenta of women delivering preterm. Before this, there were 3 large GWAS, 2 very recently done, and one was done fairly earlier. The earlier one was on 23andMe cohort, and the last 2 were on Scandinavian cohorts, very large. And what we wanted to do was, we wanted to compare our results with those that are found in European women. So we did a cross-ancestry meta-analysis. Now this cross-ancestry meta-analysis, when we combined our 6,211 with 11 women's data with the data from all these large GWASs, combined number of women we analyzed was 300,000. And we identified about 212 SNPs which were associated with preterm birth in this combined analysis. These 212 SNPs were associated both European and Indian women in our cohort. So these 212 are kind of cross-ancestry risk associations. So out of these, one I'm talking about is very interesting. This particular SNP, which is associated, was found to have a risk allele, was found to have an increase in the expression of a gene known as AKIP1. Now AKIP1 is known to lead to, ultimately to pro-inflammatory cytokine expression, COX-2, metalloproteinases, and then ultimately lead to myometrial contraction, fetal membrane rupture, and cervical ripening, leading to preterm delivery. Now we looked back at the clinical data in our cohort and found that indeed the risk allele in the preterm women had, there was this increase in this AKIP1 expression in placenta, and this risk allele genotypes were associated with reduced cervical length, which is an immediate impact of cervical ripening. So again, we are trying to integrate genotype data with expression and with clinical data in this cohort, and it worked out very well. So I'm not going into the details. There were 2 other examples where in this cross-ethnic SNPs, one was found to lead to associated with nutrient transport to placenta, and the other was to defense against infections. And in both cases, these were cross-ancestry SNPs that were associated. So then what we did was, we had these 212 SNPs, and then we had this 50 SNPs, about 40 SNPs that we had identified specifically in our cohort. We combined these 252 and did an analysis to identify which of these SNPs best, minimal number of SNPs that predict risk of preterm birth in our cohort. And we came out with a list of 66 SNPs which were strongly associated with spontaneous preterm birth. So we have now built a panel of these 66 SNPs. We are designed sequencing assays. We are now validating them in additional samples in the cohort, and we have already, we want to test it out, so whether this can be used as a panel to assess women's genetic risk for preterm delivery. So now we tried to understand how some of these SNPs modulate the risk of preterm birth. So we had this longitudinal epigenomic data at 3 time points during pregnancy, using a methylation array known as EPIC, where we looked at 850,000 CpG sites in each of these women. So we combined the GWAS 252 genetic variants that we identified and this longitudinal EWAS, and did something known as methylation quantitative trait loci analysis. Interestingly, we looked at only MEQTLs which will be present consistently at 3 time points, and we found that there were 33 such MEQTLs, and which are only focusing on 3 genes, promoters of 3 genes. So there are, the SNPs were actually, some of the SNPs were actually altering DNA methylation of promoters of only 3 genes. I'm talking about the most significant one, which is very interesting. It's in the promoter of a gene called EGLN3. Now what we found was that the risk allele of the SNP was associated with reduced methylation of promoter CpG of this gene at all 3 time points during pregnancy. reduced methylation at promoter means increased expression of the gene. Now there were various studies earlier, including studies from IGIB and studies elsewhere, which had shown in Highlander populations that there is something called EGLN1 in the same family. This gene is associated with, it's a response to hypoxia of HIF1 family, and that results, so there is an impaired response to hypoxia that is associated with EGLN1 genotypes. So here, what we found is EGLN3.
Hello. So you have 2 more minutes.
I will finish up.
Sure.
So what we did was this looked at this EGLN3 and found that this is expressed in the placenta. So what we finally figure out is that this women who have the reduced, women who have genotypes which result in reduced methylation of this EGLN3 results in increased expression of hypoxia. So there is an impaired response to hypoxia, and hypoxia happens during pregnancy in the placenta, and that results in these women in preterm delivery. I will, so we have done a fair amount of various kind of assays. So one particular example I will talk about, and then I don't know. It doesn't move. Yeah, I wanted to make it. Yeah, thank you. So I told you that we are doing this long read sequencing to look at structural variants. We picked up a 1.5 kb deletion in intron of a gene which is known as CSIR-IMMT. Now this deletion was present in many women who delivered preterm, but that was not present in any of the women who delivered at term or in the 1000 genomes long read database as well. Now when we went back and looked into our single cell data, we found that in preterm women, where we did single cell transcriptomics, the NK cells had a lower expression of KIR3DL1, and these women also had a lower expression of HLSC in the extravillous trophoblasts. So it's known that KIR3 interaction with HLSC in the placenta results in immune tolerance. So if this interaction is going down, that means the immune tolerance is going down, and that can result in preterm delivery. So this is one that we are working on right now. So this is again a lead that we have integrated the genomic data with the single cell transcriptome and showing that it can be an interesting hit. So I will stop here. So this is a slide I showed earlier where it was empty. Now we find that there is various different kind of leads that we are getting from this cohort, which is kind of giving us a picture of how preterm birth might be happening. So on one hand, we have these SNP panels. We would like to use it to triage women for risk of preterm delivery. On the other hand, these kind of biological information that we are generating, which needs much deeper mechanistic investigations that we are now trying to initiate, we would be trying to see how this this can be used in future, if at all, for a potential intervention approaches to reduce preterm delivery. So I end here, but with 2 things. One is, of course, in meetings like this, we should think of how to share data, which has been, a lot of data is being generated in this cohort. Data generation and analysis is expensive, requires expertise, and we should pull together everything. The second is, as I said earlier, that we are also generating a lot of innovative methods and tools, and we should share them across the cohort. And I would be happy to, do that if anybody approaches me. Thank you very much.
Yeah, excellent talk. And so we may take 1 or 2 questions on this cohort. So if there is none, apparently, yeah.
So ma'am.
So pregnancy can worsen any time during the trimester. So snapshots people have done. Mother, when she is pregnant, she'll go for her antenatal checkups. According to the policy of the government, 4 antenatal checkups are a must. None of them go. 40% unbooked pregnancies still happen in India. What do you mean by unbooked? एक भी अल्ट्रासाउंड नहीं होता. जस्ट डिलीवरी के टाइम पे ट्रायज के लिए एक अल्ट्रासाउंड होता है. सो दैट डज नॉट गिव यू द कंप्लीट पिक्चर. तो स्नैपशॉट है, मदर्स का कंप्लायंस नहीं है, गवर्नमेंट इज़ नॉट रियली मेकिंग पॉलिसीज विच आर इम्प्लीमेंटेड जस्ट बिकॉज मदर्स को भी कोई गरज नहीं है या मे बी देर इज़ नो literacy going on there. So right from the start of the risk factors of clinical, socio-demographical, we will have to make interventions. हर intervention हर department में अलग जाएगा. ज़रूरी नहीं है कि हम डॉक्टर्स के पास जाके बोलेंगे तुम ये मेटाबोलाइट या ये प्रोटीन टेस्ट करो. That could be a simple intervention stating that you have to have a policy of 1 visit per trimester. Follow up. Iron. न्यूट्रिशन का भी हम लोग अमीनो एसिड्स का सारा डेटा ले रहे हैं. तो एग्जैक्टली कम टू नो मदर्स को सारे टाइम बुलाने से अच्छा हमने ये देखा है मेटाबोलाइट्स या अमीनो एसिड्स या न्यूट्रिशन देख के कि सेकेंड ट्राइमेस्टर पर उनको इस तरह का अमीनो एसिड चाहिए ही चाहिए. उसी टाइम बुलाइए, उसी टाइम टेस्ट करिए. सो क्लिनिकल लोड भी कम होगा. द पॉइंट इज वी ऑल हैव दोज थिंग्स बट बिकॉज वी हैव सच अ लॉट ऑफ पॉपुलेशन वी हैव टू हैव टारगेटेड इंटरवेंशंस at targeted departments. हम सब मिलके अलग अलग काम कर रहे हैं ताकि वो अलग अलग जगह से उनको पकड़ा जाए. एंड एज सच प्रीटर्म इज़ अ मल्टीफैक्टोरियल डिजीज़. हो सकता है न्यूट्रिशन में भी खराबी हो सकता है जीन में भी खराबी हो. आज मेरा गला बहुत खराब है. सो दैट इज़ इट.
So right now preterm deliveries have an associated high rate neonatal death and infection and complications after delivery. And many cases these women are born in health centers where such neonatal or antenatal care is not possible to provide. Now अगर हम लोग ये SNP panel use करके risk of preterm delivery पहले से predict कर सकते हैं, clinician can predict that, then those women who have a very high risk they can be advised to move closer to such medical centers towards the end of their pregnancy where such antenatal care facilities are available. At least that will reduce these kind of neonatal adverse outcomes.
So I thank Arindam and Pallavi for presenting Garbini. Now we invite Dr. Anamitra Barik for the next talk. Anamitra is a physician and a senior medical officer with Department of Health and Family Welfare, Government of West Bengal, and currently holds the position of Project Director for Birbhum Population Project, abbreviated as BIRPOP. And he currently leads it and is committed to integrating both clinical and public health research. So over to Anamitra. So we'll prompt you when 2 minutes are left, 18 minutes.
Good afternoon, and thank you, the organizers and everyone. It's indeed a privilege to be here. So, we're trying to introduce the Birbhum Population Project, how it started in 2008. It's a unique cohort, as it is I think it's one of the cohorts which was established by the government of West Bengal. It's a government-funded project. It's running from 2008. And it was actually the brainchild of Professor Abhijit Chaudhary, the eminent hepatologist of IPGMER, Kolkata. So, this is. So the question that who will fund SHDS? It was started in 2008 after a visit from Philabavi in Vietnam and Matlab in Bangladesh, and Professor Chaudhary came as it was his hometown in Birbhum, and he started advocating this thing to the government, and then government was convinced and they started a population project in 4 blocks, the community development blocks of Birbhum, which is Rajnagar, Shiuri 1, Mohammad Bazar and Saithia, 4 different types of blocks encompassing around 60,000 population initially. So then the question came, then leadership. Actually it was headed by him, and I later joined in 2011 as a research coordinator, and it was running since 2008. So, and this is the area, as you see, so the western part of West Bengal, and we have 4 blocks here, 351 villages we have here, and it's almost bordering Jharkhand and Murshidabad. So this was actually started in 66,343 households with around 2,97,000 members. So then after stratified sampling, it came down to 13,261 households, and we actually perform our socioeconomic survey almost every 3 to 4 years, and now we are, due to different attrition problems, around 11,563 households we have now. So the concept was to generate the high quality community level data that can support epidemiology, social science and policy research. That was the idea. You can see this is in snapshot what we are dealing with, and almost go to the right hand side, the latest survey where you can see we have highlighted the sex ratio, because Birbhum is one of the districts in India where the child marriage is maximum. So we have trying to highlight this one also. The sex ratio is increasing a bit, and literacy has also increased. So this is the actual picture whom we are dealing with. We are dealing with tribal population of around, you can see 9 to 12% tribal population we have, and most importantly in Birbhum. But in our area, we have a huge scheduled caste population, and always we have to remember, as you know, there is a area called Deutscha Panchami block, which is now important because government of West Bengal is starting a coal field in that area. So it's majorly inhabited by the tribal, and now they are being uprooted. So we are also working in that area. So maybe the demography will change again. So this is the way how we function. We have a project director who actually plans, and the thing is we have an adjunct faculties also, like you people. So other scientists from different areas of India, even abroad, they come and they collaborate with us. They give a different opinion. We sit together and we decide what to do, what is the research question. Then we have a fantastic team of surveyors. We have 47 clusters in 351 villages. These surveyors collect the data, and they are the backbones of our system. These surveyors, they report to a field monitor. We have 8 field monitors and 47 surveyors, and then they report this to our survey manager, and it's a both-way communication. If any problem occurs, they can strictly go to the field. And we have a data manager who supervises the data along with the quality control analysis, and we have some data entry operators also. The thing is, now we are doing to the open data kit, and our surveyors who are plus 12 passed, they have plus 2, and after that they are trained in-house. They know how to do the verbal autopsy, they know how to do birth, death, marriage, migration studies. They go to the field, they do the household visits. Every day they visit not more than 15 to 18 households. The thing is, on an average, they have 300 households under their belt, so they try to cover every household in a 28-day cycle. So, and this field and office, they actually coordinate with each other. And whenever a problem occurs in any regarding data and all those things, the paperwork or the online open data kit, actually the correction is done at the field itself, and then they come back, and we have started from the very beginning. It's called the cross-checking of data. That means one surveyor's data will be cross-checked by another. So there are some, the first infection profile in 2015, this was published in IJE. So when the Birbhum Population Project was first highlighted at that time, and we again, you can see the last one. So 2015 and 2024, we have updated the profile in the IJE itself. So what are the things we are doing actually? We have some focus survey and we have some routine surveys. Routine surveys include the enumeration of the births, deaths, marriage, migration, pregnancy tracking, and we have some other surveys like focus survey, like we have done on tobacco, some studies on the psychiatric mobility. We have done anthropometric measurements, done some surveys on the NCDs, which we'll discuss later on. So these are the things we have again visit. So regarding what we do actually, we have some to calculate the birth rate, fertility rate, and of course we have the immigration statistics are also here. And how many cesarean section delivery are also, you can absolutely see this. In 2012, that was around 13% cesarean section delivery. Now it has climbed up to 37%, which is fearsome, I think. So these are the specific things we have done here. So from this data, this is the whole exome data of non-obese NAFLD patients from India. And this is the famous thing, about the lean NAFLD. It was called that time, it was NAFLD, not NAFLD. So this was under the tutelage of Professor Partha Majumdar, we have done this. These are another thing, the South Asian medical cohorts, which reveal the strong founder effects and high rates of homozygosity, followed by this, we have done metabolic syndrome among rural Indian adults. And these studies, these 4 studies, have something in common, which we want to discuss. One is, these 4 studies, they highlight the intersecting metabolic and genetic challenges faced by the Indian and South Asian population. And the whole exome investigation of non-obese NAFLD revealed that this genetic architecture may guide the precision risk stratification in the population where lean NAFLD is common. Complementing these findings, the large whole genome analysis of the South Asian cohorts in the second study, they show strong founder effects and higher levels of homozygosity across India, Pakistan and Bangladesh. Such population structures create unique opportunities for identifying the disease-associated variants and highlight the scientific value of the South Asia and the genomic research. Again, the thing is, here we have found out the waist circumference is more important than the BMI, only BMI. And here comes the importance of the central obesity. We know the Asians, they, although not being typically fat, not obese, they're having these problems because of their central obesity or the visceral fat. So together these studies underscore a unified message. Indian and South Asian population face unique metabolic and genetic risk patterns characterized by the lean phenotypes, strong founder effects, rapidly rising cardiometabolic disease burdens. This evidence supports the need for the integrated genetic, metabolic and lifestyle focused public health strategies. My previous speakers has highlighted those things. I will again stress in these aspects why Cohort Connect is becoming more and more useful nowadays, because we are unique than the others. You just can't simply extrapolate the Western findings, population findings over here. Then comes the bowel autopsy. This is one of the things we think our strong points. Our surveyors go home to home and they collect the data after the death. So the last person who have seen the person during the death, they give the data and they write it down. And we have 3 physicians here and 1 umpire physician who determine the death. And the parity comes in. So this is the thing. We don't want clinical trial because we are more interested in observational study. And as we are committed to our population, we don't want any intervention by us now. So these are the different published papers we have. So we are, this intergenerational transfer of menstrual taboos remaining strong and discussions remain confined to the women. We are currently working on the unhygienic disposal of sanitary napkins in mud ponds. So this is the going on survey. So, and our survey, another is a drowning and twin cohort study. Why drowning? We think drowning is one of the public health problems which is least addressed, and it is a preventable public health problem. So we have discussed a lot of things about snake bite, other things, but not about drowning. In our area, we have counted around 200 persons almost died in last 15 years in our cohort area, which is astounding, and it is entirely preventable.
Last 2 minutes.
So the most important thing is why here. So actually I invite everyone to come and engage with us, because this is the right time to collaborate. And as every previous speakers were saying, I will also join them in chorus, that linking the all community cohort centers will not only reduce the budget, but also bring expertise in us and help to establish this. We, the South Asians or the Indians, are completely different from the Western world, and we need to establish this Cohort Connect, because we can exchange our ideas, we can share, and the science science will go to the top whenever we exchange our ideas. We can by harmonizing the data, and what one of speakers asked about the federated data structure. That means the data remains with us. The authority, ownership remains with us, but we can share the anonymized data with others so that a common platform is created. And of course, the cardiometabolic risk clustering, genetic polymorphism, environmental things, all are being studied in silo. So let's have together, and our idea is not about centralization of data, it's all about connection of data, how to connect data, not centralizing it. Not ownership, but stewardship. And it should be locally rooted, that's most important, globally relevant, and scientifically transformable. Thank you all. Thank you.
So any questions for, so Dr. Barik, there is a question.
did not understand this drowning. Is it a health-related problem or what is that?
Yeah, so I think drowning is, I think, one of the least addressed problem in rural India. So if you see, say the road traffic accident, we are addressing the road traffic accidents. So people may discuss a lot, people writing a lot of columns about this, but drowning in our area, as you know, you can't believe that out of 212 we have traced out in last 10 years, of them below under 5 children is almost 198, and after the event what happened, and the mother started to believe that she is the main culprit, and throughout her life he lived in such a tragic experience. So when our surveyors, as they have a very good rapport with the villages, they feel that all those mothers, they secure herself. And believe me or not, if the child who died is a son, the tragedy becomes much more, because he is being suffering, he's suffered in the families, and he, as you know, the abuse, women abuse, the wives are being abused by the husbands, by the families. And this drowning study was actually proposed by one of my surveyors. So, sir, what can be done? Can we do anything about the drowning? And you may, it may seem a bit, it's not so glamorous when drowning. Drowning is such a thing which is least talked about, and we are thinking to, and when we started collecting data about this, we realized, so 30 years back, the villagers know how to swim. But last data, the baseline data we are collecting around, we have just completed around 10,000 population. Even in villages, they don't even teach their offsprings how to swim. So that's, I think, as a unique thing, which we knew previously that all the villages know how to swim. But nowadays what's happening, in the villages, the population is decreasing. Maybe 1 or 2 children they're having. They're also trying to get them, no, I have only 1 child, I will not let them. So that's why drowning, that's it, nothing else.
Thank you.
Okay, thank you.
Thank you.
Thank you, Dr. Amitra. And may I request Dr. Shailesh Mohan as the next speaker. So he's a professor at PFHI and the director of its Center for Chronic Conditions and Injuries. So he'll be talking about the CARS cohort and the epidemiology of cardiometabolic and other chronic conditions. Yeah. Podium is yours. So we have a request from our side, so please try to finish your talk within 17 to 18 minutes. I think it's got dropped.
Something got dropped also.
Yeah, can I get the slide mover?
Something got dropped just there.
It's here. Thank you very much to the organizers and Dr. Shantanu for the kind invitation and the opportunity to present a cohort that has been long running and is a collective endeavor of many institutions and individuals. So just a little bit about the organization that is running this cohort and I work for. So the Center for Chronic Disease Control is based in New Delhi, and it was established in the year 2000, and it's celebrating the 25th year of its functioning this year, and has been focused on chronic NCDs, particularly cardiometabolic diseases, looking at ways to measure cardiovascular disease as well as cardiometabolic conditions and other chronic conditions in a robust and reliable manner, developing and testing out low-cost country-relevant solutions to address the rising burden of NCDs, and contributing to policy endeavors within the country, as well as developing capacity, which is a very fundamental aspect of our functioning. So this cohort, called the Cardiometabolic Risk Reduction in South Asia, was set up in the year 2009-2010 with funding from the National Institutes of Health. And it was an investigator-initiated cohort led by our Executive Director, Professor Prabhakaran, and colleagues from Emory University in the US, led by Professor Venkat Narayan. This has now grown and is in the next phase, which I'll describe in the next few slides. So essentially, to summarize, so initially it started off as a cross-sectional survey, and then the investigators had the foresight to convert it into a cohort to study cardiometabolic conditions, because that was the focus at that time. But with time, another wave was recruited from urban and rural Delhi, urban Delhi and urban Chennai, using a very rigorous multi-stage stratified random sampling technique of adults aged 20 and above residing in the selected census enumeration blocks. So this is truly representative of the population of Delhi and Chennai. So far, across the two waves, we have data from over 20,000 people who have been followed up for a considerably long time, who have accrued close to 200,000 person-years of follow-up, and have also provided at least one, most of them have at least provided one biosample, that is blood and urine. It is very carefully phenotyped, very carefully geocoded, the built environment, the household environment, and we are running the cohort with a very high retention rate so far, and we have very good community engagement with the communities that are being studied in both Delhi and Chennai. And we also have stored samples numbering close to 4 lakhs, which have serum, plasma, Buffy coats, and also DNA being extracted. So this number, which is 21,000, is almost 3 times the Framingham Heart Study, based on which many risk scores are being used across the world. And it is also a robust platform to train the future investigators or maintain a steady pipeline of investigators to take this cohort forward. So you can see here that there were founding members, founding institutions and founding members. This is a truly collaborative cohort, and you can see the expansion to several institutions in this phase, which is called the Precision Cars cohort. So in the original cohort, which started off with the cardiometabolic perspective, we have done all the standard measurements, including socio-demographics, health behaviors, history of medication usage, medically diagnosed diseases, as well as psychosocial factors. We have also looked at air pollution and also geocoded and looked at the built environment of the household members. In terms of specific cardiometabolic measures and outcomes, we have, of course, the standard anthropometry, blood pressure, blood glucose, and other biochemical parameters, lipid markers, renal function, liver function, and also all the major cardiovascular as well as other events. And we have also done verbal autopsy to determine cause of death, which we are currently analyzing. So this was the first stage in which those measurements were done, and with subsequent funding from the National Institutes of Health, we had slightly different objectives. And to summarize in simple words, the objective was to collect data on subclinical and clinical cardiovascular factors leading to cardiovascular disease, and come up with more precise measures of assessment, which can be used for fostering precision medicine and precision prediction of cardiometabolic conditions in the future. So with that in mind, now we are tracking activity patterns, sleep patterns, stress levels, etc. using wearables. We are also looking at a range of inflammatory markers. We are looking at genomics, epigenomics, metabolomics in a subsample. We are also doing subclinical CVD measurements, which include echocardiography, carotid intimal media thickness assessments, arterial stiffness assessments, CT scans of the coronary arteries, CT scan of the liver to see liver fat, as well as also the coronary fat and the coronary artery calcium. And we are also looking at assessing advanced biomarkers, including APO markers and ApoLittle-A. And we are also looking at leptin and adiponectin. So these measures have been added to the long-running cohort in the current phase of operations. So just to give you a sense of what the timeline was and how many rounds of follow-ups have been completed and what has been added recently. So if you look at the left side, so we started at around 2010 with a random cross-sectional, stratified random cross-sectional survey amongst adults aged 20 residing in Delhi and Chennai. And we followed them up every year till the funding was available, and even beyond that with additional resources being raised. So we had around 5 follow-ups, and every other follow-up also entailed taking biosamples, including bloods and urines. In the interim period, we had a brief questionnaire to assess new events as well as changes that have occurred, and also hospitalization episodes. So after the first round of funding ceased, we had to raise additional resources, and with that, we also continued the next 6th follow-up, which was largely during the COVID times and by telephone. During the meantime, we also recruited another wave of participants, a different cross-sectional survey in around 2014-15. So we call it the Cohort 2. The Cohort 1 had about 12,000 plus participants, and the Cohort 2 had about 9,500 plus participants. And then we had a complete baseline assessment, as we did in the first cohort, and then this cohort was also followed up once before we commenced our Precision Cars program, under which we envisaged 2 rounds of data collection and 1 round of all the subclinical measurements, that is echo, CIMMT, arterial stiffness, and CT scans. So into this mix, we have also added other projects, particularly one looking at Alzheimer's disease and Alzheimer's disease-related dementias. So we are going to have neurocognitive assessments, brain imaging, retinal imaging, and assessment of Alzheimer's specific biomarkers. So in the process of developing this cohort, we have also utilized the resources to build a very robust lab, which has got several accreditations, and it's the performance on a variety of parameters is close to, or in some cases exceeding, the average world-class levels. So you can see the infrastructure that is available, the number of studies, the number of participants, and the number of aliquots that are in storage for any further analysis, as well as any future analysis of emerging biomarkers. So currently, in the second phase of what is called the Precision Cars, we have completed round 1 of data collection, and we have commenced the second round. And these are the numbers from the second round, and we are well on target to finish the second round by March or April of 2026. And you can see that we measure many different parameters, and we also are looking at frailty as well as multimorbidity in this cohort. So what is this Precision Cars? So it is integrated mix of 4 interrelated projects. So it's called by numbers. So we have project 1, which looks at the epidemiological and pathophysiological pathways of subclinical and clinical atherosclerotic cardiovascular disease. We have project 2, which looks at the impact of exposure to ambient air pollution, particularly PM2.5, and its relation with subclinical and clinical atherosclerotic cardiovascular disease. There is project 3, which looks at integrative multi-omic analysis of markers related to subclinical and clinical cardiovascular disease. And project 4, which is a study of spousal diets, in which we are using variables to track activity patterns, sleep, diet, stress levels, etc. So participants wear a watch which gathers information on all these parameters, and this is being done in a subsample of 1,500 diets or 3,000 adults. These 4 projects, as I said, are interrelated, and they're supported by 3 cores: the administrative and field coordination core, which is responsible for the field activities, maintaining quality control, etc. The CVD phenotyping core, which looks after the CVD phenotyping as well as all the subclinical assessments. And we have a robust data management and analysis core, which provides the data management support as well as the statistical support. So we have also leveraged this infrastructure provided by this cohort to study other issues, and one of them is air pollution. So this is another, this was made possible by another NIH grant, which aimed to, called the GeoHealth program, which aimed to look at the impact of environmental exposures on a range of health conditions. In our case, we looked at the exposure to PM2.5 and cardiovascular and cardiometabolic conditions. And what was found, and we developed a model that could assess air pollution and combining a variety of data sources, including what's available, and at a much more finer resolution than currently available strategies. So essentially, what we found was that high exposure to PM2.5 is associated with a variety of health outcomes. I will just describe 2. So we found an increased risk of, or increases in PM2.5 exposure by 25 microgram per meter cube was associated with a considerable, that is 3 to 5 millimeter increase in blood pressure levels, and this is in the population. Similarly, there was an increase with increased exposure to PM2.5 in blood glucose as well as HbA1c levels. So the message is that if we manage to have a handle or a grip on air pollution, we can reduce a considerable fraction of hypertension as well as diabetes in the population. This grant also was accompanied by robust capacity building, under which many people were trained in degree and non-degree programs at the collaborating institution, which is Harvard School of Public Health. So expanding on this 5 years of work, we have also received funding to look at a variety of other pollutants or environmental exposomes, which include obviously PM2.5, nitrogen dioxide, ozone, and extremes of temperature. So in this, we have been, as the mantra today has been, connect and collaborate. So we have managed to connect and collaborate with various cohorts across the country so that we could apply a modified lifestyle approach and find how exposure to this environmental exposomes at various stages during the life course is related to a variety of health outcomes that we plan to study. So you can see that there are around 5 cohorts, which include cohort of pregnant women, adolescents, older children, adults, and older adults. So this study is currently ongoing, and the data is being collected currently, and hopefully we'll have some results in the next year or so. So this is a very pan-Indian collaborative effort. So in addition, we are also expanding beyond the cardiometabolic realm of investigations. So we have got funding to study Alzheimer's disease, and we call this study CARS Brain. So what we plan to do is enhance our understanding of Alzheimer's disease and Alzheimer's related dementia in this sample of South Asian adults who are obviously understudied, and come up with precision measures both to predict as well as possibly help in better management. So in this, what we are doing is we are recruiting or re-examining everybody who was 40 or above at baseline, giving them wearables to track diets, activity patterns, stress levels, sleep patterns, etc. Doing cognitive assessments using a digital Linux tool, and also looking at the Alzheimer's related specific Alzheimer's related plasma biomarkers. In those who are aged 50 and above at baseline, in addition, we are also doing brain imaging, retinal imaging, as well as a whole variety of cognitive assessments. So when you see the timeline, since CARS began in 2010, by the end of this grant, which is around 2029, we would have accrued considerable amount of person years of follow-up. You can see 19 years and sufficient person years of follow-up to really look at what are the risk factors for Alzheimer's in this population and what we can do about those risk factors.
Dr. Shailesh, 2 more minutes.
Yeah, so thank you. So what are the key takeaways? I won't dwell more into the findings because my co-investigator and colleague Shivani Patel will be describing the high-level findings in the next presentation. So suffice to say that we have found South Asians, or Indians specifically in this case, to have a high risk of cardiometabolic conditions, developing cardiometabolic conditions. Diabetes is more common among the wealthier, but there's no social gradient in terms of hypertension or cholesterol. Many people in India, over half actually, are at risk or have lifetime risk of developing diabetes, particularly if they have excess weight. And most of the people who have diabetes in India, or are prone to develop, have insulin deficient phenotype. So that is a new finding. And they also experience rapid progression from pre-diabetes to diabetes, and also extensive multi-organ involvement. In terms of blood pressure, many of us already know that the blood pressure, uncontrolled blood pressure burden is very high. Very few people are aware or put on treatment, and even fewer people have their blood pressure controlled to recommended targets. We also saw that in our sample of adults, kidney function decline is very rapid, and we have a high burden of the so-called new syndrome, which is the cardiovascular kidney metabolic syndrome, as well as MASLD. So I'll just quickly run through how we have used this experience and expertise gained from establishing CARS to establish another cohort, which is actually a rural-urban cohort. So it's got both rural and urban component. It's called Uday. It's a population sample of those aged 30 and above, residing in urban and rural areas of Sonipat in Haryana and Vizag in Andhra Pradesh. So we have studied 24,000 plus people over 2 waves, and we have mimicked what was measured in the CARS so that there could be comparison. Because of lack of funding, we have not been able to regularly follow up, so we are exploring funding sources to actually develop this cohort further, and it's one of the rare rural cohorts. So we have used this cohort for a variety of other studies as well. We have looked at food systems and how they impact cardiovascular disease, NCDs, and other chronic conditions. So we collected extensive nutrition data from 9,000 people. We looked at their diets, household food wastage, the snacking behavior, food purchase. We published many papers, and we found that a lot of food wastage happens at home, a lot of water is wasted, and there could be a lot of interventions that could potentially reduce that and also help in the larger goal of improving planetary health. And we've also compared the diets people have with the Eat Lancet recommendations, and we found that Indian diets in these places are deficient in comparison to Eat Lancet recommendations. We've also used this to see how COVID-19 and NCDs are associated, and this is a study we just completed, and especially we're looking at long COVID, so we should have some results soon. And lastly, we have also used this Uday cohort to build a surveillance system for influenza using health workers who will get the data on cases from both health facility as well as from the community members who are sampled. So I won't go into the details. So this is currently, we have developed the application for collecting this data, but we're waiting for funding from DBT, which has been not coming for a long time. So once we have the funding, we will be implementing the surveillance system. So thank you very much.
So we might take questions after Dr. Shivani's talk is over, because we will cover entire car study. So next speaker.
So Dr. Shivani's talk would be online. Can we connect? Can we take the industry talk first?
What happened?
We'll take Shivani's talk first and then Thermo's talk.
Am I audible?
Yes, we are audible to you, Dr. Shivani.
Yes, I can hear you perfectly. Should I share my slides? Could you see my slides?
Yeah, we are yet to share the screen, and you can start sharing.
I started sharing.
Okay.
At least I think I have. Waiting your confirmation.
Ask her to share now.
You have shared the slides?
I am sharing the slides, correct?
Yes, please.
And also turn on my camera. I don't know. I'm not sure if it's all on.
Yeah.
I hear you perfectly. That much I know.
No, you are loud and visible, so please go ahead. Slides are visible now.
Okay, wonderful. Okay, thank you so much for this opportunity to present and build on my colleague, Dr. Sailesh Mohan's presentation. I regret that I can't be there with you in person, so appreciate this remote opportunity. So I'm going to pick up a bit where Dr. Mohan left off. And before I go there, I really wanted to start with the global significance of having a South Asian cardiometabolic cohort. And I'll really focus on the metabolic piece, because in 20 minutes we just don't have enough time to cover too much more. This is the global burden of disease. You all or many of you who work in the space of epidemiology at least are familiar with these numbers. This is from the Global Burden of Disease study in 2021. And so we see that ischemic heart disease is been the leading cause of death worldwide for at least the past 30 years. But we also see in these figures that diabetes is rapidly rising in terms of its contribution to overall mortality. Also, when we look at the contributors, meaning the risk factors to the global burden of morbidity and mortality, high fasting plasma glucose and obesity, or rather high body mass index, are two of the risk factors that are leading to progressively higher morbidity and mortality. Whereas we've made substantial progress in low birth weight, high systolic blood pressure, and smoking in terms of contributors to disability and death, we are failing to make that progress in fasting glucose and high body mass index. This is extremely significant given that we are now finding that diabetes is eroding past life expectancy gains. So we see life expectancy rising everywhere in the world, including India. In the United States, we've already seen stalling progress in life expectancy, and people like me fear that in India, we may suffer the same fate due to the rise in diabetes. Of course, it's not just about the global burden, and the global issue is also about India specific. So India has one of the highest age standardized prevalences of diabetes. It also has one of the among the highest absolute burdens just due to population numbers. Why do we focus so much on diabetes in South Asians? I don't need to make this argument to this audience, but let me show you some data anyway. What we've known for many decades now is that South Asians, so Indians and also other South Asians, wherever they've gone in the world, they have higher rates of diabetes than their peer populations. This is in the USA, this is the United Kingdom, South Africa, Norway, and also in Singapore, we see this pattern. So for some time, it was not clear whether this is a phenomenon of the migrant experience, or is this something about the South Asian predisposition to diabetes? And this was, of course, a big motivating factor for the CARS cohort to have an indigenous, India-based, South Asia-based data infrastructure to understand the problem of diabetes and other cardiovascular conditions in this population. Again, I'm only focusing on the diabetes because of the short length of time that we have. So Dr. Mohan has already covered the infrastructure that has been built over the past 15 years, this population-based biobank, longitudinal and multi-level, multi-dimensional infrastructure. And I'm going to talk a bit about how these multiple risk factors, and especially diabetes, compare across the world. So this figure is showing the baseline prevalence of modifiable dementia risk factors in the CARS cohort. This is the cohort starting at age 40. I'm highlighting the dementia-related factors just to note that these are the same common shared risk factors across most chronic diseases. In the pink color are the shared cardiometabolic risk factors. We have a couple of others, hearing impairment, vision impairment, that are more specific to dementia. And of course, type 2 diabetes, which is a major risk factor for both dementia and also, as we all know, highly prevalent in this population. In CARS, in adults over the age of 40, diabetes prevalence was already at 38% at baseline, which is extremely, extremely high, as you all can appreciate. And if we go to the cohort-wide, meaning we start at age 20 and older, we still see a very high prevalence of diabetes, between 20 and 26%, depending on if you're talking about Chennai or Delhi, depending on if you're talking about men versus women. One of the big concerns about diabetes in our setup is that even though it is very high, there is decent awareness. 50 to 60% of the people in CARS, and these are major, as you're aware, were not aware. They were not aware that they actually have A1C levels or fasting glucose at levels that are indicative of diabetes. So this means that even in major cities, we have a huge burden of undiagnosed diabetes, which is progressing towards complications, untreated, etc. The lifetime risk of diabetes in cities is again astronomical. Dr. Mohan briefly mentioned this, that in men that are 20 years of age, there's a 56% lifetime risk of going on to develop diabetes. For women, this is 65%. I want to also highlight another piece of this story, and that is obesity. We know that obesity is also rapidly rising. We are not seeing it as much in the national data in childhood. I think that is yet to come, that is imminent. But we are seeing it already show up in our statistics for adults of reproductive age, so midlife onwards. for people, young people who are obese, the lifetime risk of diabetes is going up by 20 to 30 percentage points. That means we're almost, you could say, not quite doubling, but getting, you know, a 1.5 kind of X risk of people who have obesity versus not in terms of lifetime risk of diabetes. Then the other thing I want to highlight about this cohort is our ability and to track how diabetes progresses in India versus in other populations, or Indians who have migrated. So these are some data showing the comparison between findings in the CARS cohort and findings in the Masala cohort. The Masala cohort is a population-based study called the U.S. Mediators of Atherosclerosis in South Asians Living in America. It's predominantly Indians as well. And what we found there is that when you age standardize, the diabetes prevalence in CARS was 38% and 24% in Masala. So up till this point, a lot of the belief was that it is the migrants who leave the country and have higher rates of diabetes because we were seeing it first in migrant populations. But we find that diabetes prevalence actually is higher in Indian cities than it is in US cities when we're comparing Indians to Indians. So that was quite a finding. Also, I want to highlight this just to show the power of what we can learn from comparative studies. You know, I applaud this effort to think about what we can learn across the cohorts within India, but there's also an opportunity to think about what we can learn across different countries using such cohort data. Now, this is a study showing the prevalence of type 2 diabetes by body mass index in India, specifically in Chennai, to whites in the United States. So this is national survey data in the United States. And the figure I want to highlight here is that, first of all, diabetes prevalence increases with higher levels of obesity in all groups. This is true of men, this is true of women, this is true of Asian Indians, it's true of whites. But Asian Indians have a much higher prevalence of diabetes at that lower body mass index. This has also been covered in part by our colleagues in West Bengal, and I believe familiar to many of you, but this is showing us how bad this phenomenon is in numbers. Another very telling comparison that we have made with the CARS cohort is comparing Asian Indians to Pima Indians. Pima Indians are an indigenous Native American community in the United States. Asian Indians and Pima Indians are both world famous for their high prevalence of diabetes, but they have a very different phenotypic profile. So Pima Indians are very obese, whereas Asian Indians are historically leaner when it comes to body mass index. When it comes to glucose profile, the Pima Indians have higher 2-hour plasma glucose, whereas the Asian Indians have higher mean fasting glucose. So overall, it's suggesting a picture that Pima Indians have a diabetes that's predominantly driven by insulin resistance, whereas Asian Indians have a type of diabetes that is also driven by insulin secretion deficiencies. So this is very important because most of the diabetes research that we have globally has focused on this insulin resistant variety. And what we're doing in CARS is really highlighting the importance of insulin deficiency, and we hope developing insights that other populations can use. Because of course these phenotypes are not restricted to one race or ethnic group. They are prevalent everywhere, but the distribution differs. Now this is showing a measure of insulin resistance on the left-hand side, a measure of insulin deficiency on the right-hand side. And what we're seeing is that insulin sufficiency, you could say, on the right-hand side. And again, these are data that are supporting what I showed in the previous slide on the comparison between South Asians versus these Pima Indians in terms of the differences in phenotypes. Let me also say that we see similar patterns when we compare to U.S. blacks as well as U.S. whites. has been mentioned, the field of diabetes treatment and we hope eventually prevention is being revolutionized by the consideration of diabetes subtypes. So diabetes has been subtyped into at least 5 groups depending on the model that you use. And one of the findings, more recent findings in CARS, is that the insulin deficient phenotype is in fact the phenotype that dominates in the CARS cohort. And we also find that this insulin deficient phenotype is associated with higher risk of mortality. So we have these findings published in abstract form, and they are now under review at a journal. And the concern about this insulin deficient type is that, again, it manifests at lower BMI, and so it is not being flagged necessarily by the traditional risk factor of obesity for diabetes. So this is a common consideration, and it's going to be something that I hope in India, I think people are already beginning to be aware of it, but we need to bring more and more awareness through studies like this, that diabetes screening should consider not only those who are obese, especially when there is South Asian ethnicity involvement. As has been mentioned by my past couple of colleagues who presented here, that diabetes is closely connected to chronic kidney disease. So what we have found in CARS is that at least 7.5% have indication of chronic kidney disease, and there's a confluence of abnormally high A1C, also high blood pressure, and chronic kidney disease in the CARS study. So 86% of participants with chronic kidney disease had either abnormal A1C or hypertension. So you see that there is this overlap. And I think it's worth noting that this overlap of cardiovascular, kidney disease and metabolic disease is also very, very hot right now in settings like the United States, because we're seeing these same phenomena happening in global populations. So this is again where I'd like to highlight for all of us the importance of doing this work not only for the health of Indians, but also having a better picture of what is happening globally, since we're seeing such a convergence in the distribution of risk factors as well as outcomes. These are data showing the distribution of non-alcoholic fatty liver disease, NAFLD, at least this was the terminology used at the time of the study. So what we found was that 66% of the CARS cohort had indication of NAFLD based on ultrasound. About half of the cohort had indication of NAFLD based on FibroScan. We found that diabetes increased the likelihood of presenting with NAFLD by 2-fold. This is a finding that has been replicated, and we see this also in other cohorts in rural setups as well. So this is not restricted just to the urban setup.
Shivani, last 2 minutes.
Great. And I wanted to also highlight the importance of cardiovascular disease. And so for the past 15 years, cardiovascular events have been ascertained and adjudicated. They've been corroborated using medical records where available. We find that CVD events are higher than populations of this age in other settings. We know that glucose is an underutilized measure of cardiovascular events in global populations in terms of risk prediction. And we are very well poised to release a score, a risk stratification score that is uniquely tailored to the South Asian population using this data. So this rapid progression of diabetes that is occurring because of this unique phenotype means that we have a very narrow window of prevention. And it also means that we have to be thinking very carefully about specific pharmacological management, comorbidity prevention and management of cardiometabolic disease in light of the compendium of comorbidities. What are the opportunities for lifestyle prevention? And I've already touched on screening at lower body mass index, and potentially we need to be screening for measures that are not picked up using just high A1C or high fasting glucose. We have a lot of opportunities in CARS to develop, to build on the carefully geocoded population, so we are able to look at built environment, measures of physical environment like air pollution, which has been mentioned by Dr. Mohan, measures of the social environment, including the spousal concordance. And we also have an opportunity for very carefully constructed longitudinal and life course investigation. So this is a figure just showing the distribution of follow-up by age in this cohort. I know it's a busy figure, but the point here is that we're able to track people from midlife to the older ages, especially if we are to bridge these lifetime trajectories together. And so really this is an opportunity and invitation from your specific point of view, expertise, and disease domain to get involved and join us on this journey to understand how can we study people from midlife into the older ages, thinking about cardiometabolic disease and its intersection with all other organ systems. So with that, thank you. And also invite you to visit our website at thecarsprogram.org, and please feel free to contact me at my email that's shown here. Thank you.
Thank you, Shivani, for finishing and following the time. So what we'll do is we'll have 1 or 2 questions, and meanwhile we invite the industry speaker. So 1 or 2 questions on CARS, so if anyone has. For Dr. Sailesh, Mohan and Shivani. So if there is not a question, I had one query to Dr. Sailesh Mohan. He specifically mentioned about the CARS brain. So any specific reason to bring it with a cardiometabolic cohort, and what were the primary reasons to bring a brain study into the picture?
Thank you for that question. So we already had this infrastructure, population well studied, and as I said, initially this was established to study cardiometabolic conditions, but we always had the thinking to go beyond that and look at other important public health issues, particularly in the area of chronic diseases. And clearly, dementia, Alzheimer's is a very important health issue. And since we already had this well-phenotyped cohort, we thought this was a very robust platform to study these conditions, which have not been adequately studied so far in South Asians. And as I showed in the slide, by the end of this study, we would have accrued close to 20 years of follow-up. So that will give us enough numbers and events and the power to look at all the objectives that we had outlined. So this just, it is one, the importance of the scientific question, 2, the availability of the necessary infrastructure, and 3, this was additional funding to keep the cohort running and sustain it into the future, because funding such cohorts is very challenging. And as I said, the initial funding was for 5 years, but the investigators, founding investigators, were very wise, clever, and strategic, and managed to raise additional resources to keep it, to sustain it for another 5 years or so before we got substantial funding to continue the program. So it's very important that first of all, we have to look at questions that are relevant, can be answered, but also we have to be a bit opportunistic to garner funds that are necessary to sustain the program and also expand. And another thing I forgot to emphasize more in the presentation was that we have also built sufficient capacity. So we need the cohort to keep running with new investigators, new questions into the future. So we need to, maintain that momentum.
Thank you, Dr. Mohan. So we see that cohorts also need to evolve, and as the new techniques and things come in, they should be incorporated to sustain and also to improvise upon the outcome parameters. So thank you, Shivani. Thank you for your talk. We will take up the industry talk now. So this will be the last talk of this session. So the talk will be by Srihari and Olink Thermo Fisher Science. So I request you to please start.
Thank you very much for giving this opportunity to talk about our proteomics platform and how we can support the cohort studies. So I will mainly focus on our next generation proteomics platform, and then broadly also touch upon some additional possibilities and wider support capabilities which we provide as a Thermo Fisher scientific entity. So today's highlight in the news, some of you have seen the news, it's all about personalized medicine, and I saw sort of Dr. Shantanu and your team in the news talking about Phenom India and the event today, and you're mainly emphasizing the personal medicine as a motto behind this endeavor. In fact, we at Olink, the personal medicine is our mission. That is to expedite personal medicine by offering the right treatment at right time to right patients. So our next generation proteomics platform, it enables large-scale protein profiling and reveals disease mechanisms and novel biomarkers all the way from discovery to clinical translation, thereby accelerating the targeted prevention and intervention strategies. So, in fact, Olink made a trend. It was a trend-setting moment when we did our first largest ever human proteomic study with UK Biobank. Today morning, Dr. Krishna Reddy was mentioning about UK Biobank with 54,000 samples. In fact, there is the latest news. So Olink's Explore platform has been selected for the world's largest human proteomic study. That means, so we are collaborating with UK Biobank to support analysis of 600,000 samples. So this second phase of UK Biobank, the largest ever human proteome study, it evolves around the pilot study which we had collaborated with them on the 50,000 samples earlier. So this UK Biobank study, it is largely funded by 13 plus pharma partners, and each of them are supporting with their own research questions and helping it to advance this study further. And so what is the utilization of this study? So today morning, Professor Ganguly talked about data sharing and how such large-scale studies can benefit not only the sponsors, but also the research worldwide. In fact, the earlier study, the pilot study with 54,000 samples from UK Biobank, it has resulted in more than 160 papers. And if you see where these papers are coming, this is not only coming from UK, there are people around the world from Asia and US. So people around the world are utilizing this UK Biobank data. So this data is now available in public, so everyone can access and perform their own analysis and perform also validation studies as well. So this is the beauty of such a large-scale cohort study, which can benefit the researchers and patients and the healthcare community worldwide. And this again showcases how in future, when you plan expanding such a large-scale collaboration studies, how this can benefit not only our Indian researchers, but somebody mentioned earlier, delivering the results globally, and we can help to gain deeper insights and help our global colleagues as well get benefit from this. And one concrete example of how the UK Biobank studies have helped. So Benjamin Sun and his colleagues, they used this UK Biobank data to identify the protein risk score for type 2 diabetes. In fact, they were able to demonstrate the protein risk score for 10-year incident type 2 diabetes was superior to collagen risk score by 20-fold. Of course, HbA1c was good, it performed very well. However, protein risk score was even better than HbA1c's as well. And when you include HbA1c and protein risk score, it gave an excellent area under the curve. And adding to this, we have seen many other papers coming. So we have seen papers coming from Oxford University on solid tumors and many other papers focusing on common and rare diseases. So the trend is that it really demonstrates the value of proteomics in coming up with protein risk score for identifying the at-risk population. So one final example from my side, combining all the discovery to the clinical translation. This is a beautiful example from Octave Biosciences. So Octave Biosciences, their interest was to assess the severity of multiple sclerosis among this population. So they did a discovery study with us and were able to identify the protein biomarkers, so-called the protein signatures for multiple sclerosis. And they went ahead and collaborated with us to develop a custom panel, and which was then finally validated and went ahead with clinical validation as well. Now this custom panel is commercialized across 100+ hospitals in the US. So this demonstrates, it's a clear showcase how the value of cohorts can be utilized to benefit the patients, and that's too in a quickest time possible. So major population programs around the world, they are investing in proteomics. So we have already heard a lot about UK Biobank and Cohort studies and many more. So in India, we are proud to collaborate with Combat Study. So Dr. Arvind Maitra is here. So we are collaborating with Ujjwal Niyogi for this Combat Study program. So this is one of the first collaborative consortium study we are collaborating in India. And I do agree with earlier presenters, we need our own UK Biobank study here and to generate data from our own country for our own population and to help the global community. And with that, all of this data which I briefly showed you earlier was possible by utilizing the Olink technology. So we at Olink have solutions for broad discovery of protein biomarkers, be it using our solutions such as Explore HT, which has the capability to discover up to 5,400 protein biomarkers, or maybe somebody's interested in hypothesis-driven discovery, or maybe validation and development. So we have the end-to-end solution from discovery to clinical translation. So if you're interested, so please let us know. We do have booth outside, so we are happy to discuss with you further. So switching the gears. So
last 1 minute.
Next few slides, I'm talking on behalf of my colleagues. So they have requested me to share a few slides on their behalf. So we at Thermo Fisher Scientific, so we are broadly supported with 4 business verticals to support end-to-end solutions for the cohort studies. So taking some examples, so we are in a leading position for mass spectrometry solutions, chromatography, electron microscopy solutions, and many more. And in fact, some of these solutions we already have seen from the presenters earlier, and we do have broad capabilities from our broader divisions such as lab equipments and maybe some of the lab essentials or chemicals or maybe anything related to biosciences. So we have this broad capability to support end-to-end requirements for your cohort studies. And with that, I would like to end my presentation. Thank you very much.
Thank you. Thank you very much for this presentation. And so this essentially concludes today's session. And those who are interested in Olink technologies, as the speaker suggested, you please contact the booth and you can have a bit detailed discussion over there. Yeah, and obviously the dinner will be served at Suryamukhi Resort, and it's for everybody. Everybody is welcome. Please join us at around 7:30, I guess. 7:30? Yeah. So any announcement from the organizer side? Okay, then.
So we conclude the session. Now over to the organizer.
Thank you, Sardana sir and Partha Chakravarti sir. Already the dinner has been announced and the hotel is known and transport facility is also available, I hope. And tomorrow the session will start at 9 o'clock. So kindly assemble in time so that we can conduct the sessions in time. And tomorrow photo session will be also there. So kindly cooperate. So thank you once again and Jai Hind, Jai Bharat.